Welcome, dear people, to Virtual Azure Community Day, your Virtual Azure Community event, where we talk about all things Azure. Anything that's related to modern day software development using cloud technologies. We're going to have so much fun. We will be here all day long. There will be multiple tracks. So in about half an hour, there's a track starting from Denmark as well with great talks. But we're happy to have you here live from the Netherlands in our studio in Utrecht. So Virtual Azure Community Day started out a few years ago. I don't even, Henk, when was it? 2018? Like 20? No, COVID? Yeah, during COVID. Okay, well, we started out during COVID from our homes. Then it became crazier and crazier from studios and whatnot. And we decided after a little absence that it would be time for another virtual conference. Why? Well, because we love sharing knowledge and spreading that across the internet and making sure that also the recordings look really, really, really nice. And that's why we are in this beautiful studio. So that's a very long story. There's a lot of talks coming today. Please feel free to interact using the chat. We'll keep an eye on it. If you have any questions for our speakers, do interact. We love it. If you want to tweet or toot or whatever that your social preference is, use the hashtag VACD so we can take a look and enjoy your social messages. It's hard not to say tweet or Twitter, that sort of things. But we don't care, just use VACD as hashtag. There's a code of conduct, which you can find on the website azureday.community in the top bar, and you can find how to reach out to us if there's anything happening that you think is not right or feel is not right. So without further ado, let's kick off the day, because it's not me talking. We have Stacy here, and Stacy, welcome.
Hi, it's so cool to be back in this studio again. It's such a spectacular place to actually give a virtual talk from.
Yeah, it's nice, and well, we've actually sat down here already for like half an hour talking about all kinds of things, and it is a cozy studio. So well done to the team of Lowlands.community. Thank you for hosting us here. So Stacy, how have you been? You've been busy.
I was supremely busy last year. I forgot that there's a difference between virtual talks and real life talks, so I applied to so much stuff. I was lucky enough to get selected for so much stuff. And then it was only later on that it kind of hit. I was like, oh, this means I'm going to be traveling for like 3 days a week, week after week after week after week.
Yeah.
It was awesome. I'm so pleased to have done it. It was also exhausting, and I apologize to my family. But yeah, no, it was spectacular last year.
You were everywhere.
Yeah.
Like, or at least it seemed that way. And I was at a lot of conferences too. And every conference I was, well, almost every conference I was, it was Stacy. So yeah, it's so good to see that and to see you sharing all that knowledge. But that's not the only thing that you did, right?
No, I completely forgot. I released my book last year.
How can you forget about your book being released? I was hinting.
Yes. Oh wow, no, I think that's one of the things that you kind of like put to your mind. Writing the book was quite a painful experience. It's awesome to do. I learned so much writing it, but it's also so much work on top of the talks and work and everything else. But no, that got released in September last year, so beginning static web app using Blazor. Yeah, I've had really nice feedback on Twitter from that. There's a few people been asking questions, and it's been a lot of fun to also help them and see where I can improve how I write things to make things more easier to understand in the future. But oh yeah, it was tough, but it was definitely an experience that I would recommend to anybody to have a go at.
Because how is it to write a book about technology? What makes it so difficult?
I think one of the things that makes it difficult is things change. So I started this book in December of 2021. I finished it in June of 2022. And Visual Studio changed, Azure changed, The CLI changed for static web apps. It went general availability, and there was a couple of things that you had to do differently. And I think in June I rewrote 20% of the book.
Oh, wow.
New screenshots, changing the way that things flowed, moving things around so they make more sense in the new place. And when you're doing that, I say on top of talking, on top of writing talk, on top of work, I think that's kind of the big thing. It is a job in itself to write a book. And to be honest, speaking is a job in itself, and I have a job. So it was like having 3 jobs in one, and you've got pressure from all of them building up and conflicting with each other.
But the result is there, and people
But the
love it.
result is there.
I've seen the feedback on Twitter sometimes, and like everybody's loving it. What you wrote. So if you haven't checked it out yet, please do so. Shameless plug.
Yeah, shameless plug. Beginning Azure Static Web Apps with Blazor. It's available on Amazon, etc., etc., where you normally buy your books.
Cool. So now about your talk.
Yes.
Because what are you gonna talk about today? Can you explain shortly? Without giving away the whole talk.
Without giving away the whole talk. Well, basically, it's a little bit more about static web apps.
Mm-hmm.
So at a conference I did last year, forgotten which one, I was getting ready for my talk. It's about an hour before I go on stage. And somebody said the words to me, oh yeah, I mean, static web apps, they're cool, but they're just toys, really. You can't do anything with them, can you? Whereas I said, as a speaker, an hour before my talk, a little bit triggered. But it also fired me up to like, right, no, let's do a talk on not how to get started, which is what my book is, which is what most of my other talks are. Let's have a look at a step you can do to bring this into a proper pipeline, into a company. So we're not playing with the portal or anything like that. We're doing everything as it should be done, and prove that it's more than just a toy. It is a serious resource that we can use inside of an enterprise. So that's kind of what I'm going to be doing today. It's less about the code this time and more about CLIs and workflows and pipelines. And if all goes to plan, if the demo gods are on my side, hopefully we have something cool at the end of 50 minutes.
Oh, that would be so great. I'm really curious, because a lot of people just can't look beyond like, oh, this is a very cheap way to host a website of my cat. And like with all the services that now, the paid service that is released around it, the paid tier, a lot of things have opened up, but it's hard to look beyond that.
Yeah.
Because it has been in the stage of like the blog for my cat for a while.
Yeah.
So I'm really happy with the talk. I was excited when you said, I have something new. I'm like, ooh, that's good. So yeah, looking forward to your talk. People pay attention if you have questions. Well, Stacy literally wrote the book, so she's gonna tell more about it. So yeah, please enjoy your session.
Thank you.
So thank you again for watching Virtual Azure Community Day. The chat is here to interact with us. If you wanna grab a screenshot and share that on Twitter or whatever your social network is, use hashtag VACD. Ask your questions for the speaker. We love some interaction. And well, Stacy literally wrote the book, so you can kind of ask her anything. No pressure, Stacy, no pressure.
No pressure.
Take it away.
Okay, well, hello everybody. One question, could I have this TV back on so I can see what's being shared? Thank you. Whoops.
No,
we've lost a second
everything
TV.
is off.
It's fun being the first to, you get all of the technical gremlins out of the way.
Wonder where this one came from, but
there we go. The screen's going on. Hopefully you should be able to, hopefully I can see it. You can all see my screen. You can see more than I can right now. There we go. It's coming back. So, yeah, where are we? Get the right stuff on the screen. Like I say, welcome everybody. Thank you so much for joining me here for this session. Without my glasses here, because I'm kind of reaching that age where I need glasses to see people, but not to see a computer screen. We are going to go today and, like I say, have a look at taking those static web apps getting it out of the toy stage and moving it just a little bit further. Very quick personal introduction before we get started. I'm Stacey Cashmore. I am Tech Explorer DevOps at Omniplan, a financial software company based in Amsterdam in the Netherlands. I've been coding since the mid-1990s, which is why I need the glasses. And for the last 3 years, I still can't believe that I get to call myself a Microsoft MVP in developer technologies. So static web apps. Before I get into the other stuff, I do just want to do a very quick recap on what you get out of the box, because even though it might not be, how do we say this, enterprising, it is awesome. I've got here just a little snippet from a pipeline which is created for you. So for those who haven't done it, Azure Static Web App, you get your GitHub Azure DevOps repo, you go into the portal and you say, give me a static web app. And the portal will make a connection to your repo. It will create a pipeline for you. And without you having to know how this works, which is great for getting started, it will give you a CI/CD pipeline. So as we can see in this repo here, every time we have a push to main or we have a pull request to main, this pipeline's going to get kicked off. Now, what it's going to do, it's got two jobs. The first one is the build and deploy job. It kind of makes sense what it says. It will download your repo, and then it calls this Azure Static Web Apps Deploy action. This action does everything that you need it to do. You pass in your secret so that it can access your repo. You pass in your secret so it can access your static web app resource. It will look in the app location and API location for your code. It figures out what language you have written that code in, will build it, publish it, and then take that and put it up to your static web app for you, check that everything's running, and then swap it so you have near downtime deploys, all without you knowing any of this is happening. Seriously, it is amazing technology. It also, if you're doing a pull request, will actually spin you up an entirely new environment so that you can check your code in a production-like environment, check that it doesn't work differently in production than it does on your machine, which never happens in software development. And then once you've finished your pull request, it goes and cleans up, which is what this second job does, this close pull request. When you close it, it goes in, it runs the action close, and it just cleans up your resources, which is good, because in a static web app, you have limited staging slots that you can use. But you do have the issue here of the fact that you have to manually create the static web app in order to get that repo. What happens during the deploy? When you're getting started, it's superb. Everything happens for you. You need to know nothing. If you're doing this inside of an enterprise environment, maybe you do want to know just a little bit. So we want to improve that. The other issue is it has the link from the pipeline to your static web app resource itself. And well, if I'm using infrastructure as code, how do I get that available? So what we're going to do today is we are going to build a pipeline. We are going to create all of our resources. We're going to deploy it. And hopefully, if I don't talk too slowly, we're also going to assign a custom domain to that so that we can run a pipeline and get our website live with no interaction from us unless it all goes horribly wrong. Happens occasionally. We'll see what happens here. We'll work with it. So first thing I'm going to do is open my repo. And this is currently contains my API, my client application, a couple of DLLs that I need to run it. It's going to be a to-do app. You'll see it running in a few minutes. And it's got just a couple of tests, which not enough, but enough for the demonstration at least. We're going to open code. And I'm going to turn caps lock off so I'm not shouting at you, and code's going to open in the wrong window, of course. And what we're going to do is create our workflow folder. Now, we're working with GitHub today. So the way that we have to do this is create a new folder called .github/workflows. Any YAML file inside of this workflow, if it's a valid workflow format, will be visible inside of GitHub and we can use it. The first workflow I'm going to add, we're going to add 2 today, is going to be for our infrastructure as code. So I'm going to add a new file here, and we're going to call that iac.yaml. Then we're going to give it a reasonable name to start with, and I've got some snippets here that I'm going to bring across because you probably don't want to watch me for the next 50 minutes do typo after typo. But don't worry, I'm going to explain what they do as we go along. So we're going to give a name to our pipeline so that we can easily recognize it inside of GitHub, create and set up SWA infrastructure. And I'm using a workflow dispatch trigger on this one. That means this doesn't run automatically. I only want to do this when I make a change to my infrastructure or when I create my infrastructure. I don't want it firing off all of the time. Next, we need some environment variables so that we can control how we're deploying what we're doing. I'm using 3 environment variables to name the resource group, to give a name to the static web app, and also to set the region that I want to run it in. Now, I was reading a blog post at the end of last week. There are now repo variables that you can use instead of just repo secrets. And when they go general availability, I will probably be losing this part of my pipeline and actually putting it on the repository itself, because it means that we can more easily share things. It makes it more flexible. But right now, I'm trying to use what's in general availability, so this is still in my pipeline. Once we have the pipeline, the next thing that we need is a job that actually runs. Now here we're only going to have one job in this pipeline. Ensure that the SWA is created. We're going to run it on Ubuntu latest. And the first action that we need to do is check out our code. And you know what? I don't actually want submodules, so I'm going to change that to false. So this gives us access to the code that we want to use. Second thing that we're going to be doing is logging into Azure. And we need to do that, obviously, so that we can create the resources that we want to create. Now, you can see I'm using secrets.azure credentials here. I am using repository secrets for most of my settings that I need in my SWA, and also my login details so that the pipeline can access my Azure resources. Next up, the actual creation of the static web app itself. So here I'm going to be using the Azure CLI, and I'm just going to be running an inline script. And number 1, I want to create the resource group. Now, this command is idempotent, so if you run it multiple times, it's not going to crash on you. It's not going to cause things to go boom. So it just means that we know that we have a resource group that we can deploy to in the right region with the name that we want. We're going to use that in the next step. And that next step is actually going to be the creation of the static web app itself. Now, there's different ways that you can do this. You can do it using a command line. I'm going to be doing it using a bicep file today. So I actually want to just step outside of this file for just 1 second. And I want to show you the bicep file, which is going to create our application. So we're going to add a new file on the root, call it main.bicep. And I have what I think is the simplest possible bicep file to create a static web app. We have the name of the static web app, the location, and the SKU that we want to run. This properties object here, you can use to control a lot of things inside of the static web app, but I don't want to go too deep into that today. I want to focus on getting the pipeline working, so I'm just using all defaults. I am passing in 3 variables into this bicep pipeline. I'm passing in the location, which I am defaulting to the resource group location. I'm passing in the name that I want to give my static web app, and I'm passing in the SKU, but I'm also defaulting that to free. So unless I override it, it will create this on the free tier. Back to the pipeline then, and we need to call this. So after using the AZ group create, we're then going to use the AZ deployment group create. AZ, I am not speaking English today. This is going to run this bicep template inside of this resource group. And you can see we're passing in the parameters for the SWA name. We're not passing in the SKU or location. So it's going to take the location of the resource group and it's just going to create it on the free tier for us. Last but not least, the application that I'm going to be showing you today is a to-do application. And if you are authorized and logged in, it's going to save your to-do list to a Cosmos DB so that you can read it back later and it's not lost every time you hit F5 on your browser. In order to do that, I need some settings inside of my static web app to allow access to that Cosmos DB and set up the database name and the container name. Really easy in the portal, and to be honest, also really easy on the command line. For this, we're using AZ static web app in order to run this command, and we can set our app settings using this function. So we need to give it the static web app name, we need to give it the resource group that's going to be running, and then we just need the list of settings that we have. So I've got 4 settings right now: the Cosmos endpoint, the key for connecting to it, the name of the container, and the name of the database. And to be honest, that's kind of it. This is all that we need to do in order to actually generate our static web app using the pipeline. So let's make a push here. So add IAC. We're going to push this up to my repo. And then if I can find the right browser window, we should be able to see that if I refresh this now, we get our workflows at the top. And if I go to actions, I get this create and set up SWA infrastructure workflow that we've just created. Now this is a fun part. If this fails, my demos are going to be really interesting for the rest of the session, so everybody keep your fingers crossed. Let's run the workflow and see what happens. Just check that that actually comes up and doesn't give us a YAML error. I'm on about 50-50 for YAML errors when I do this. I've had so many pull requests setting this talk up that say, language that I'm not going to use on this stream, YAML, as a reason for why I'm pushing yet more code up. I don't know, is YAML a thing you either hate or love, or is it just a thing that everybody loves to hate? It's one of the two. Stockholm Syndrome. So whilst we are running that pipeline, that generally takes a couple of minutes to run. Bang. We are going to have a look at how we're going to create or how we're going to deploy our application, because once this workflow is complete, we're going to have a static web app available to us, but it's not going to have anything deployed on it. That's going to be our second pipeline. But before I show you the pipeline directly, I want to show you the command lines that we're going to be using to run this. So number 1, inside a close quote, every time I do the run through for this demo, I forget this step. Inside of my application, I want to put something on the main page that shows you where we are in the flow. So right underneath my header, I'm just going to add a div saying deployed by CLI. That's going to change the pipeline, and it's going to change, hopefully, the pull request before we finish today. Then on our command line, we're going to be using .NET to do all of the building. Remember, in the default pipeline you get out of the box, this is all taken care of for you. We don't have that available to us. So I have some tests. So let's run our tests and make sure that nothing's broken. I only have tests in my API right now. I should really have tests everywhere, but it's enough to get the idea. So I have 2 tests and they both passed. Woohoo! Once I've done that, I can start to deploy my application. But actually, there's one more change I need to make before I can do that. I said that that default out-of-the-box action that we're using does lots of things. One of the things it actually does is change the code that you upload to your static web app. See, a static web app can work with lots of different technology for the API setting. When you are building it using the standard or the out-of-the-box action, it actually checks what language you're using, and it sets up the Azure function that runs inside of your static web app to be using that same technology. If we're building this ourselves and pushing this ourselves and just uploading the files, the static web app doesn't actually know what it's supposed to be deploying, so we need to tell it. Now, in order to do that, let me just bring this page in here. Ignore the fact that this is in Dutch. I apologize for that. It doesn't matter how many times I tell Microsoft I want to see Microsoft.com in English. It always takes my location and overrides the language for me. But what I want to show you, you can actually see without being able to speak Dutch. And that is this list of runtimes that are available inside of an Azure Static Web App. So we can run .NET 6, .NET 6 isolated, .NET 7 isolated, that's what we're using today, Node 14, 16, 18, Python 3.8, Python 3.9. But we need to let the static web app know which one of those we're running so it can provision the correct hardware or the correct infrastructure. And we do that by putting this .NET 7 isolated inside of a configuration file in our client application. So let's do that now. It means going back into code. And we need to go to our www root folder, which just gets published and copied to your static web app as is. And at the top of this file, we're going to tell it what platform it should be using. So we're going to put the platform object in there. And like I say, the API runtime we have, .NET Isolated 7.0. Once we have this in place, now we can start to actually do all of the things we need to do to get the published code available to it. So first up, we're going to publish a client. This is going to take just a couple of seconds because it has to optimize the WASM files, etc., etc. Generally takes like 10, 15 seconds. It knows I'm in a live demo, so maybe the computer's going to be nasty to me. No, there we go. That's not too bad. And then we're going to do the same for the Azure function. Yes, 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 yes. Next step, we can push it up to the static web app. And in order to do that, we need to use the Azure Static Web App CLI. Now, this started out as a Node.js server, which before it went into general availability, made it so easy to be able to develop static web apps locally. Before it came about, you had to put all sorts of boilerplate in your code. So your application knew if you're running locally, then it would go to one URL for your API. If you're running in Azure, it would go to another. Once this CLI was available, or that was a thing of the past, it pretends to be an Azure Static Web App running locally and sorts all of that glue out for us. So we run it the same here as we do inside of Azure. Once it went to general availability, way more functionality associated with it. One of them is deploying the static web app. But before we do that deploy, I do just want to show you this app working locally so you can see what it is that we're going to push up. So we have this SWA start, and that is going to take the files from my dist client folder, my published files that I'm about to push up to production, and it's going to give us a local version of the application. There's my deployed by CLI, which isn't strictly speaking true because it's only running locally right now. And this is what we should get to Azure. So show SWA CLI. We can save that and we can say, yes, I've now shown the SWA CLI. We have a to-do that's finished. So let's kill this. And then we're going to use the second step that I was talking about, and that is the deploy. Now, before we run the deploy, shall we check whether or not we actually have infrastructure to deploy it to? Look at that. We have created and set up our SWA infrastructure without using the portal. Let's check it's available. And we should have, if we refresh this screen, an ent demo resource group with an ent demo SWA. And we have a red coast URL. I adore the names that they come up with for these URLs. And we have that. Your static web app is live and waiting for your content. So we had the first step for infrastructure as code. We can create our static web app on the fly each and every time we need to without going through the portal. So to deploy to it, there's a few things that we need to do. We need to know, or we need to get permissions to deploy to the static web app. Inside of the flow, I showed you that it's got that secret that gets added by the portal. we don't have that available because we don't know what the static web app is before we start. It's just created by that infrastructure as code. But with the AZ static web app command line, we can actually extract that. Is that readable at the bottom of the screen? Yes. Okay. So we're calling this secrets list, and we are looking for the properties API key. If you use this, remember to add the -OTSV at the end, otherwise you get really interesting format in your variable. We're going to run that, and hopefully that's going to come back in not too long and give us a token that we can use. And then we can just use that token in our deploy. So SWA deploy, the API location, where are we getting our API files from, the distributed files, those published files, remember. The same for the client, that's going from the client www root folder. We're using that SWA deploy token that we had previously, and that should allow us to get access to the right resource and upload it. And I actually think that my notes are wrong here because I don't think I need these last two. The deploy token should be enough. That goes up to Azure, finds out where we need to go to, and as you can see, it starts to upload it. Now, this generally takes about 30 seconds or so, so fingers crossed that that comes up soon. But while we're waiting for that, let's have a look at how we can do this inside of a pipeline and get it running automatically. So we're going to go back to our infrastructure as code, and we're going to create a new pipeline because I don't want to put this one inside the infrastructure as code. This is a separate pipeline that does a different thing. So we're going to call that build and deploy app.yaml, and then we're just going to give it the same trigger that we saw in the default pipeline. We have a push to main, and we have pull requests, which are opened, synchronized, reopened, or closed to our main branch. One other change which you may have noticed there, I don't want this to run if I'm making a change to my infrastructure, so I am ignoring that specific path. When you redeploy to your infrastructure, you don't need to redeploy your code, so it's pointless running this pipeline at that point. So we still need a couple of environment variables here because we need to know the resource group and the name of the SWA itself. Like I say, hopefully in a couple of months, this is going to disappear, and I'm going to be using repo variables in order to run this. And then we have jobs. Now, eventually we're going to have 2 jobs in this flow, 3 jobs in this flow. Right now, we're just going to start with 1. Build and test, and I'm going to abuse it a little bit in the beginning to actually do the deploy as well. So I don't want these submodules here either, so we'll take away those. So when we have a push to main, or when we have a pull request, which is anything but closed, we want to build and deploy our application. We want to get our code from our repo, so that's the first step. Second step is we want to set up .NET, and I'm running .NET 7 here. I don't want pre-release in this because this is just all production-ready code. And once we've done this, then we can use those 3 command lines that you saw me using, the .NET test, the .NET publish, in order to get our application out. So let's add those. So we're going to test our app, and if all the tests pass, we can go woohoo, and then we can publish it. Publish the client, publish the API, and we have our code ready for deployment. For the actual deployment, we've got to do a couple of different steps. First one is we need to get hold of that token, and we're going to do that in exactly the same way that we did it on our command line. We are going to log into Azure using those Azure credentials that we used in the IAC pipeline. And then we're going to call this static web app secrets list and get that into a variable that we can use in different steps. Then we have to do something slightly different to what we do in the pipeline, and that is we need to add this mask. This is a really important step. If you don't add this mask to your secret, then you are going to display information in the logs that you really don't want to be displaying. So this is an important security step, making sure that we mask this secret so it doesn't appear. Once we mask the secret, then we use this SWA secrets output or the GitHub output to get the SWA secrets available inside of another step. Interesting one here that I found when I was running through this and trying to get my demo code working. If you output these secret, or if you output this variable, you can also use it as a job output, and you can use it in different jobs. If you add the mask to the secret, that no longer works. So this step has to be inside of each job that you want this secret to be available in. And now we've got the secret, we can actually deploy our application. And we're going to do that using the SWA CLI, the same as we did on the command line. So first up, we're going to install Node. And then once we have Node available, we're going to install the static web app CLI. And then we're going to call exactly the same function that we were using locally. We have the SWA deploy, passing our client www root, our API that we published, that deployment token that we got from the previous step, and something that I forgot to mention when running it from my command line, this environment variable for production. That's right, we are hard coding it to production right now. I said that that default action will create your staging environment. We're going to be doing that in just a few minutes. But this first run that we're going to be giving it, it's only going to run to production. And this is the first step in our pipeline. So let's push these changes up to GitHub. And deploy workflow. And you can see I've done a typo there. This is why I work with snippets. Commit and sync, push that up. And then we'll check that that's running before we go back to our command line. So if we go to our actions, hopefully, hey, look, we have one and it's queued. Hopefully that's going to start off soon. In progress. Let's see if that one works for us. Back to our command line, and we can see that the deployment succeeded. We can see where it deployed to. Oddly enough, I must have done something odd when, oh, I didn't deploy this to production. I accidentally deployed this to a staging slot. So this is kind of a spoiler for later on in the talk. We have a preview slot available that we can see our code. We open this up. Here's our application deployed by CLI. We're still running on this red coast, but you can see that I have this preview flag in here. Oops. You get the idea at least. That pipeline's still running, that pipeline's still running. That's going to take like 2-3 minutes to run. So while that's running, let's have a look at how we can get these staging environments inside of our pipeline. Now, you just saw, if I forgot to put the environment flag on the end of a deploy, out of the box, it goes to this preview location. But if I'm running multiple pull requests, I don't want it all to deploy to the same preview location. That's going to really annoy two people if they're maybe got pull requests running at the same time. So we need some way of getting this out there and specifying exactly what preview location it's going to go to. So let's go back to our pipeline. Now, if I'm deploying something, I want to be able to rerun that deployment step. Say I deploy my application, it's all working beautifully. Then I add a change. Something in that change doesn't quite work as I expect it to, and I run a rollback. I want to be able to rerun my deployment step at the last good release to get the application back to a working state. So this is a point where we're going to split this workflow up into 2 steps. And in order to do that, we need to get the code available after it's been built for the next job. So we're going to add this upload published files step, which does exactly what it says on the tin. And then we're going to create a second job. We're going to put that above the whole deployment because that needs to be in this second job. So deploy to SWA, again, reasonably descriptive. It's still going to run on the push and on the GitHub action event closed. And it's only going to run if build and test succeed because we need that output from the previous step. You can also see the first step that we have in this action is indeed to download the published files on the previous step. Once you have that, this will now work as is to deploy to the production environment, but to deploy to a staging environment, we need to do a couple of different things. One, we need to know whether or not we are deploying to a staging environment. So before we do the deploy, we're going to bring down a step here that just says, hey, if the event name that's kicked off this workflow is push, then I know I'm deploying to production because that's my push to main. If it's not a push, then obviously I'm in a pull request. And so I want to give the environment a name of staging and then the event number, which will be the PR number that you're currently trying to get into the main branch. We're putting both of those into this environment variable on the GitHub output. So this allows us to use this again in a next step. And that next step is going to be this deploy step. So let's overwrite that, and you can see that at the end we have this environment steps.swaenv.output.environment. Now when we run this, if we run it inside of a pull request, we'll get a staging environment. If we run it on the main, it will go to production. But that default action also does something else which is really cool, and that is it updates the pull request. Not only does it create the staging environment, it lets you know in your pull request where you can test your pull request, rather than having to go through the logs of the deployment to find out where it is. And I want to recreate that inside of my pipeline. So in order to do this, what we can do is run a command line that says, get me my environment list. And you can see here, I have two environments for my static web app that I just created. We have the production, Red Coast, blah, 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 and we have Red Coast Preview Rest Europe 2. The fact that it contains the name of the environment helps us figure out which host name we need to use. So inside of our pipeline, we can run a step that does this for us. Again, we need to do this after we've deployed, so we have that new staging environment. We are going to be querying the output of that command line that I just showed you to make sure that the host name contains the environment variable that we used for the deploy. And we are making that available in an SWA host name environment variable that we can use between steps. I'm also echoing this to the log file just so that I can see it easily if I want to take a look at the log files. The last step here, we have an update pull request step that's using the GitHub script, and that uses markdown format to add a comment to my pull request. So I'm adding a header of staging environment updated. I've got a test here pointing to the host name that we've just extracted from the command line. And I'm also saying who caused this redeploy to happen, so the actor inside of GitHub. Then we use a GitHub REST command line to create this comment. This confused me in the beginning because it's saying on an issue, create a comment. It's like, I'm not on an issue, I'm on a pull request, but it will talk to the pull request as well. And this will run our staging environment for us. So that's how we create our staging environments, but we still need to do our cleanup. So we have one last job to add to our pipeline before we go forward. And that one last job is going to be our cleanup job. So if we're on a pull request and that pull request is being closed, then we're going to run the AZ static web app environment delete to make sure that we can delete the staging and then pull request number that we're running. You may notice I am deploying using the SWA CLI, and I'm deleting using the AZ static web app script because, well, AZ static web app doesn't do deployments at the moment, and the SWA CLI doesn't do cleanup at the moment, so we kind of need to mix and match the two of them. I hope at some point they kind of reach parity and you can just pick one tool. We'll see. So now we've got this, we can push it up, but this is for a pull request. So I want to actually see this working as a pull request. So I'm not going to push to main. I'm going to create a branch for this And I am going to commit my new pipeline to the branch. And I'm also going to change this to not deployed by CLI, but to deployed by PR. When I push this up to production, I forgot to say deployed by pipeline. Never mind. So let's check this in. Add staging steps. We're going to push that up. We need to push the branch. And then let's see what we can do inside of GitHub for this. Okay, now the deploy pipeline, that at least ran successfully. Yay. Let's reset this. And now we have our CLI up and running as we expect it to be in production, again, all via the pipeline. So I'm not doing anything inside the portal. We'll go and have a look at pull requests. We can see that add stagings had recent pushes. So let's add that to our pull request. Let's create a pull request here. This should hopefully in a second fire off that pipeline again. There we go. And that should now create that staging environment. So while that's running, there's one last thing that I want to show you today. And that is the custom domains that I was talking about. You see, whilst it is cool that you get this URL out of the box, it makes it easier to name your static web apps, say, compared to, say, an app service plan or web app, where you have to have a globally unique name for it because it's part of the URL. That's great because you know what the URL is, but it's not great because you have to have interesting naming conventions to stop collisions happening. This one is really easy for the naming convention, but the URL is not necessarily fantastic. So we are going to push up a custom domain here and get that, again, out of the infrastructure as code and make sure that it works. Again, back to our infrastructure as code pipeline. And once our app is deployed, we're going to add some extra steps to make this work. Number one, we need to give it another environment variable, and that is, what domain do we want to run to? Now, the domain I want to run to today is Azure Community today, so we'll just go for ACD. And then we can use that in the pipeline. First step that we need to do, we need to get the host name. We need to know what static web app we are going to be adding a custom domain to. And we're going to be using that same AZ static web app environment list in order to do this. Only now, rather than checking the host name, we're going to be checking the name of the environment, and our production environment is always default. So we're going to be getting that out of it. Next step, well, we kind of need to update our DNS so that we can add some information to join up our domain and our static web app. Now, this is going to be different for each provider. So I'm not going to go too in-depth with this, but I just have a little app that updates my DNS provider with the variables that I need, and hopefully that's going to make this pipeline work. I'm on about a 75% hit rate for this pipeline working, so working first time at least. We'll see what happens today. Last step, we need to add, if I can get my mouse in the right place, we need to set a host name on our static web app, and we need to set that for the domain that we're going to be running at. Now, I'm going to be doing acd.stacy.cloud today. So this is going to try and set a host name. It's then going to go off and try and connect the two things together, make sure that DNS records are correct. You can do this on an Apex domain. It's slightly different, and I don't have time to show you today, but I'm going to be writing a blog post about that in the hopefully not too distant future. So keep me honest with this one if I don't do it in time. And once we run all of these, hopefully we should get our domain. Now, I want to push that up. Add custom domain. Commit and push. And then we need to kick off that pipeline again and hope that it finishes in time, because I'm almost out of time here, so let's hope that this bit at least finishes. I got 10 minutes left. This is going to work. Do you like the confidence? So look, so our add staging steps is working. I wonder why that's running twice. That's odd. That shouldn't be running twice. I've made a mistake somewhere. But what we do have is this workflow again, and we can run this workflow and get that up and running. Let's check I'm running the right workflow file. I know why it kicked off the second one again. I'm an idiot. I have committed my code change to the staging environment and not to the production environment. Damn it. But we can get around this. Let's go back. Woo! Go back to our actions. We can fix this. Cancel this because we don't need this one to run. And instead, what we're going to do is run this, and we should be able to run it again. Our staging environment. Haha, we'll cheat. So hopefully this is going to kick off. Come on, you can do it. You can do it. And hopefully this one has the right workflow file. I'm really pleased I checked the workflow file. Otherwise, you'd have seen a very confused Stacy trying to figure out why it wasn't doing what it's supposed to be doing. Okay, do we have our deploy done yet? Yep, we have a deploy finished, so we can see that our staging steps is done. We go to our pull request and have a look. You can see that we have this GitHub Actions bot has added something to our pull request. I can open this, and here is my staging 1 environment created for us, linked to the pull request. And when I close the pull request, which I'm not going to do yet because I don't want to jinx that other workflow, it will run through and then delete that environment as well. You're not going to get to see that today, but please trust me on this. Right, how's our other workflows doing? This is the fun part because now it's a little bit of a waiting game because this can run in like 2 minutes and this can run in 10 minutes and you don't get to see it finish. DNS records are always interesting. You never quite know how long it's going to take to read correctly. So what can we do in the meantime? There's one last thing that I'm not going to go too in depth with because I don't have the time to go really through it. But there's one last thing in this application which is not really compatible with the workflow that we have. And that is the way that you get roles assigned to a static web app. Now, if I go into this role management, I can invite users into my application, grant them roles, give them access to everything. Now, I can do that in the pipeline. Where are my notes? But it's kind of a little bit interesting. So where are my, I've got a command line I want to run. That would be lost. It's wonderful when you get everything really nicely organized and still get lost. But I have this command, AZ static web app using the AZ command line again, and I can invite a user. I can say what authentication provider we're using. I can say what role they have. I can say what domain we want to run this against. So you know what, let's actually give this one the right domain rather than just leaving it as a to. So we want this one. Delete this bit. Make sure that I clean this up just a little bit nicely. And this is going to generate me a link. And this is one of the reasons why it's not suitable for the workflow that we have right now. Because this link, if I just log in with my Twitter account, it doesn't activate the link. I actually have to come in here and paste this link directly. Now, you don't want to do that to your users every time. And then it's still wrong because apparently I've copied the wrong thing. Trust me, this works. But you don't want to do that every time you run your pipeline against a possible unknown environment. So this isn't really going to work. The other issue with this is it generates a user ID for you, and that is unique for every static web app. So if I accidentally delete my environment and recreate it, all of those user IDs no longer work and my database is full of orphan records. What we need to do instead here is use custom authentication. I'm not going to go through it with you, but it's worth taking a look on the MS Learn documentation to have a look. That gets around it because then you have a known user ID and you control the roles that your users have. It's not done inside of the static web app at all. And I can see a horrible red cross. And that's a horrible red cross because it didn't pick up the DNS name. Never mind. I am going to make sure this runs. I'm going to put it on Twitter later and make sure that this environment is available for at least half a day to show you that it does actually work if you kick off the pipeline again. So let's just rerun our failed jobs and we'll put that up later. That, in a very fast whirlwind, is how we can take our static web app, like I say, out of the hobby box and actually use it inside of a pipeline which is recognizable as a real production pipeline and get things working, as we want to do in production. If you've got any questions, let me know. I'm on Twitter. I'm on Mastodon, which you can find from stacy-clouds.net. All of the links to where I'm available online are for that. Quite happily answer any questions. And that's me done. Thank you for joining me.
Thank you so much. Well done. That was a really, really nice talk. Hopefully getting people out of the, hey, look, this is my first blog of my cat stage. It's actually quite versatile. It fits way better in, I don't know if it's enterprisey, but more professional software scenarios. And it's good to see that. I asked on the chat, are you now ready to use SWA in production? And the answer was no.
Okay.
So maybe it should be in the next book.
Yeah.
But there's a lot of things I think that people, because this is of course a very compressed overview.
Yeah.
And you're the queen of demos, like, you know, juggling everything around quite fast. So where would people normally start when they want to take the slow pace?
I would say if you want to take the slow pace, then just start by playing with it on the command line. So that AZ static web app and the SWA CLI, using both of those, you can get comfortable with what happens when you run the different commands here. See what happens, see how you need to use them. Really, if you are just getting started, then create it in the portal, get that default pipeline, and there's enough documentation, I'll put a link to that on Twitter as well, on how you can actually customize the default pipeline to still allow you to build your own application, to test your application, and use your files to upload. I've already got a blog post on that. I will link to that blog post.
Good. Shameless plug.
Shameless plug. Using that default pipeline and just like you say, that first step, one step at a time. The reason why I do it this way in this demo is just because it is very versatile. It is a very awesome little GitHub action. And it's not a little GitHub action. It's a huge GitHub action. But it's also still really opaque. Even if you are using it with your own code, there are things going on in there that I think you'd rather have more control over in a professional workflow. You don't need it to do all of the guessing of what it needs to do. You want to tell it, do this, do this, do this, do this. But changing it in the first instance, it's how my blog is actually published. It uses that first step edited pipeline so that I have control over how my app's built, but I still trust that action to do the deploy.
Yeah, but that's also where, like, normally when you are in a real life scenario, that's where the magic happens. That's where you do all the checks. That's where you integrate. That's where you, in the end, it all comes together. Yeah. So learning that as a basic next step.
Yeah, that is a wonderful place to start. Absolutely. It's and if you see how you can use that action, that actually gives you quite a nice insight into what is going on behind the scenes in the static web app, because you have to do the control over your application at least a little bit without going full-fledged, getting security keys and everything else yourself, but still getting the, oh, right, okay, so it deploys a function for me, but it actually does have to know what function it's deploying. It's not just magic that goes on in the background. It is told what to do, and you learn, let's say, step by step, deeper and deeper.
So it's not, if I would rephrase it, it's not a magic black box. It's a moving box, and you just open it up and you get
Yeah.
more insights in what's actually happening.
Yeah, that's a nice way to put it.
Yeah, cool. So that would be the next step. Dive into the CLI. It's not scary.
No,
it didn't look scary or intimidating.
It's really not that scary at all. It's I think anybody who is experienced with Bash or PowerShell, they're going to find it so easy. Anybody who is still getting into that, there's a couple of bits you have to do, but it's a nice one to get into. It's not too scary.
Great. Well, it's not scary, folks. And well, you're going to share all the links, and you're just one message away. You're always quite responsive on the socials.
DMs are open if you don't want to put it live on Twitter what it is. So yeah,
cool.
It's quite happy to help.
Well, Henk, who's doing the production, was already like waving, like, "Hey, you should stop chatting." So I take that as a hint.
Yes.
I want to thank you for being here today and sharing your knowledge. Hopefully the next book will be about the enterprise situations with SWA, but no pressure.
No pressure. No pressure at all.
And enjoy your current book. Thank you so much for being here, and yeah, hope to see you around at one of the many conferences.
Hopefully. Thank you for having me.
Thank you so much.
Thank you everybody for joining.
Yeah, keep watching. We are having more talks coming up. Also, the folks in Denmark started their broadcast. So if you look at the website, there's now 2 live streams happening. So you are now able to switch between the talks. But I would recommend you to stay here, because we have an awesome talk by Bart Lanui coming up. Hello and welcome again at Virtual Azure Community Day, live at azureday.community. And if you're lucky you found us on YouTube, then welcome. So we have a whole day full of technical talks around modern day development using cloud technologies, namely Azure. And well, our next guest is an international guest, all the way from Belgium. It's Bart. Bart, welcome here in the studio in Utrecht. And yeah, thank you for being here. You've been MVP for a long while, I noticed.
I think about 7 years now, yes.
Yeah.
And thank you for having me.
Well, thank you for submitting the talk. We really liked it because what you're going to talk about today is about not developer productivity per se, but you want to keep security in the back of your mind.
Yes, exactly. I've been in IT for about 15 years, most of them being a consultant. So you see many projects, many different clients, and every single time security is one of the things they struggle with. And often we as developers, we don't like doing security. So that's at the back of our mind. And my intention today is to bring that forward a bit and tickle people and tickle their mind to think about security. Then we're going to cover a lot of topics, not in depth because security is very broad, but I want to tickle the people, their mind, so they can think about it.
Yeah, because what triggered me a little bit is like productivity and security in one sentence. I think that a lot of people are like, there's a lot of talks about shifting left to security, but this is the first time I noticed somebody saying productivity and security in one sentence. So how would one think about that?
It's all about taking away the big steps. And the first impression of what somebody talks about security, it's too hard, it's too difficult, and we have to get to know the basics. And once you get to know the basics, it's part of your daily job, and you're going to start working with it, and you will keep being productive, and you won't think about security as a big step anymore.
So it's maybe the unknown
Exactly.
that scares people a little bit.
Exactly.
Fear is never a good thing.
No.
Thank you so much for joining us. Yeah, we're going to learn all about it. So we're heading well into the time. So please take it away. Thank you so much. And for you, if you are watching, please do send out a tweet or a toot or whatever social message using hashtag VACD. Share that you're watching, share the fun, and feel free to ask questions during the talk and in between. We are online and here to interact with you. With that, I want to say to Bart, take it away.
Thank you all for joining today. It's a very impressive stage. I remember my first virtual talks back in 2020 with COVID starting at my own home office. But when I came in here this morning, it was very impressive. So thank you for letting me come. Thank you all for joining. Who am I? My name is Bart Lanouille. Like we already mentioned, I have been a Microsoft MVP for quite some years already because I like to share some knowledge. That's what we're going to do during the lunch here in the Netherlands as well. I like to call myself a technical architect because still from day to day, I'd like to write some code, be hands-on, know what I'm talking about. And you can find me on Twitter at Bart Lanouille. What's not on the agenda today, that's the typical thing that we think about when we speak about security and as a developer, that's securing our application with authentication authorization. I hope you're all doing that already, so we're going to skip that. And what we're going to talk today is the challenges that you will see as a developer in an organization, mostly with enterprise software, but also with smaller applications, and the battle between developers on one side, and then IT and the CISO on the other side. So we're going to talk about taking shortcuts, the credentials, access control, and networking. And certainly, if you look at the bottom ones, things that we as developers typically hate. But we'll try to take that away. Why do I need this talk? Well, first of all, we have to acknowledge that there is always a security risk. And often we as a human being are part or are even the actual risk. And that's what's often forgotten. Also, it's important to know that no company is small are large enough to not be at risk. It doesn't matter the size. If you have some data that's valuable, then you might be at risk. We can do our best to minimize that potential risk. And now, if you see these bullet points, you will say, well, Bart, you're being Captain Obvious. We all know that already. Do we? Let's see at a few cases from last year. The very first one, we're going to start with Microsoft, one of the biggest companies, software companies. They know about everything about security, and they try to help us with security. And even they were a victim of social engineering. It only took maybe a few seconds from a single employee to leak their credentials, and part of their code base was stolen by one of those groups. But it's not always social engineering. Often it's a technical problem. If we look at crypto.com, they had a faulty two-factor authentication architecture, and about $30 million were stolen by hackers. By now, it's only worth half of it, 15 million, but it's still a lot of money, and you don't want that to be stolen. But sometimes it's not a big architecture thing. It can be very small as well. If you look at Flexbooker, that's a company that takes care of COVID vaccinations and their bookings in the United States. They apparently run on AWS, and they had a misconfiguration, and that resulted in a breach of several million users. And not even 2 months later, after they went through all their configuration with AWS, apparently there was even a second breach, again a misconfiguration, which resulted in another 19 million records leaked. So human errors are often the fault. And the final one, already mentioned on a previous slide, leaky secrets. In the end of 2021, Twitch and the known streaming platform had to come out because one of their secrets was leaked. And once you have the keys to the castle, you can do everything. 3 months later, Samsung and Nvidia and two more big companies had the same issue. In the case of Samsung, almost 7,000 secrets were found in the code base. That was open in the wild for some reason. And you would think if Twitch, Samsung, Nvidia, three big companies come out, people know that it's a risk, they will tackle it. Well, 7 months later, Toyota had the same problem, also a security breach, data breach, because of a secret that was posted on GitHub. No, if you have any secret in your GitHub repositories and it's in the public, it will only take a few minutes, and people will be using that secret maybe to mine crypto on your cloud subscription or steal your data. So the question might be, will you be next, or even when will you be next? Because we can be pretty sure that if we have something valuable, that we will be a target at some point. And hopefully we can do our best to protect against a breach. So often, if you look at enterprise companies, you will see there's someone called a CISO or someone taking up the security role. And the first thing that they might do if they see all those news messages, let's lock everything down. Because if we lock everything down, then there can't be any breach. Then, of course, you have other people in the meeting room. And first one might be from finance, and they will say, this will just cost too much if we have to lock everything down. Then IT will say, it's too much work to lock everything down and to secure it. And of course, we developers will say, if we lock everything down, then we can't do our job. Because we have no more the typical admin access that we had in our early on-premise days, where you have a single account and you can hop on all different servers and just do our job, debug something, deploy something, write a SQL query, do it in production, because that is the fastest way to fix something. But maybe not the most secure. If you look at these three topics, let's first tackle the first one, the cost. Because if we look at security, it's trying to find the balance between cost and risk. At the left side of the spectrum, we have the cost for trying to implement all security controls to make sure that the potential risk is very small, but then you have a real widespread of things that you have to do. For a small size company, and we once did that exercise, and we already came up to several millions to take actions to make sure that the risk was very minimal. You can't take it all away, but you can try to minimize it. On the other side, we say, I don't want to spend that large budget because we're a small company. Then there's of course the cost of a possible data breach. Either trying to fix it. If we look at, I come from Belgium. In December, the city of Antwerp had a problem. It took them more than a month to recover from that data breach, and they calculated that it costs them at least a tenfold trying to recover from it and trying to bring everything up again, compared to what they would have paid just to get out of the ransomware. So the cost of a security breach, not only the IT actions, but maybe also the legal actions could be very high. So we will try to find the optimum in the middle, to have a decent size of security at a reasonable cost. How do we approach it? Well, there are many angles, of course, and it all depends. I have been a consultant for many years. It all depends what kind of business you're operating in. For instance, if you're a bank, typical banking applications that we know, they are very secure by design, because you don't want people to hack into a banking account and get rid of all your saving money. On the other side, maybe you have a simple cooking recipe application. It still has to be secure. You don't want anyone to change your recipes so somebody gets sick or even worse. But trying to recover from that, or the protection needed on that application, is a lot smaller. We have a public website, and it's all in the open, very reachable, compared to maybe a closed-off factory floor. From the outside, it's not that easy to get in, but even people visit your company floor, they could bring in a USB stick, so security still has to be top of mind. What data do you capture? Do you have any person identifiable data, names, addresses, maybe credit card information? If you start leaking that, of course, it's very sensitive and dangerous. Company secrets that you don't want to get out. But maybe on the other hand, like in a cooking recipe app, you have public available data. The data being breached is not that much of a risk. It's more protecting it for that they don't change it. What's your mitigation process? In the case of our recipe app, we could simply restore our database. If you look at a bank, you will want to prevent at all costs that someone gets to banking accounts and get money out. What's the monitoring process you have in place? Typically, through studies, we've seen that it takes almost a year between the actual breach and finding out that you're breached. So trying to bring that window down to a smaller period in case of a breach is very important as well. So we'll have to put some monitoring into place. And if you look at all these different approaches, what you will typically do if you start a security exercise, you will try to identify the threats and assign a likelihood, the impact, and the cost. And with the complete list, with all those measures, you can start ordering them and see where we will spend our money and what might be just too costly for a very small impact. You might skip that, and then it's of course to management to decide on that. They have to acknowledge that they still have a small risk, but the cost to fix it might be just too high. Very important as well, you have to coach each team in your organization, because security is often a human problem. So you have to coach them on the threats they can impact and be impacted by, so they can report them or help preventing any security. We've spoken shift left. It's often a thing that you can see with security, with DevOps. It counts here as well. Security is certainly not an afterthought. It should be part of every single phase in your software development lifecycle, and you should think about it as soon as possible. If during the analysis phase your product owner already makes the list of the potential threats, then the architect can design towards it, the developer can develop, and you have a tester testing all those threats as well. If you take security as one of the last things in your process, then it's not thought about, and then you might it might be very easy to find a few loopholes into it. So bring it forward in your development lifecycle and think about it as soon as day one. The use case that we're going to use to show a few of the things that we can tackle as a developer or an architect as a typical website. Like I said, a banking application already has security top of mind. They probably have a big security team there, but every single organization should think about security. So we're going to use a very simple website for API. Since we're talking about Azure, we're going to host it on Azure as well. What we're going to need for it today is a simple app service, and we're going to try to connect to a SQL database and a storage account. Nothing too fancy, but even with this very simple approach, you will see there are a lot of points where you can poke into the security of our application. What did I set up? Like I said, very easy, a simple API with a Swagger UI on top of it. The typical file new project. So we have a weather API to make it to expand it a bit. I also have the historical weather. The historical weather gets data from the storage account. The other one will go to SQL Server. If I switch to the code, two simple APIs, nothing too fancy. The first one, I get my connection string, and then I will use my connection string to open a SQL connection, execute a query, and then you will have a round trip to your SQL database. For the query execution, since I don't want to have the complexity of actual data and building a data model, I have a simple query, select one. It's not even hitting a SQL table, but select one is more than enough to do the actual round trip to SQL Server. So if at some point in your application you want to build health checks that you know that all your dependencies are up and running, for SQL, simply use select one. You don't have to know which tables are in there. It will do the full round trip to SQL Server, and it will check, is the connection open, can I reach it? So that's an extra tip next to security. I simply return the data, the typical approach. And then my second endpoint, again, a connection string, but now for a storage account, I open a blob container client using the default SDKs, nothing fancy here. If necessary, I create my container, I get a CSV file and just stream back to the API. No fancy code, very simple, nothing can go wrong. We're going to cover several points, and the very first one is security keys. Like I've showed with the cases before, security keys, once they get into your source control, they're very easy to find. You have the key to the castle, you can do everything. So what does a developer say? I promise I won't commit my security key to source control. Well, that's something very easily said, but my alter ego wrote some code for this demo, committed everything since it was working, and what do we see in source control? Already my security key. It's very easy to be forgotten and to be checked in. And then you probably, in your team, you might say, there's a difference between environments. I want to have my connection string to easily connect to a dev environment to test things out. I want that to be very fluid so it can be productive. And maybe sometimes, if you have to debug something in production, you're going to change that key, but you won't commit it. I promise. There are solutions for that as well. Since we have our config file or app settings file already in source control, any change that you touch that file will normally be committed if you commit it and you don't pay attention to it. There's a command, git assume unchanged, that could help you out here. Works perfect until a new team member didn't run that command on his or her computer and commits the key after all. So what we're going to do, we're going to take the secrets out of our settings file, and we're going to let the CI/CD tooling fill it in during deployment. For the local development story, well, you have a problem. There are no more keys. You're going to have to solve that. The actual resources, if you want to use them, an Azure Service Bus currently not available as a simulator or so we have to connect to them. So we still need those connection keys. How are we going to do that? Still some questions to be answered. And once the secrets are deployed by your CI/CD tooling, be it Azure DevOps, GitHub, any of the ones available, they are still available to read after deployment by devs and by your IT team or anyone who has access to the resource. How so? Let me quickly show you. So I have my API already hosted on Azure, on an Azure website. You take the same domain name here, and you add SCM, just before azurewebsites.net. And what you'll see, you will log into a Kudu console. Very handy. It gives you a debug console. You have several tools. You can take a dump out, so to help you debug. Certainly a useful tool that you might be using in case of emergency. But the debug console not only gives you a debug console, it also gives you access to all the files. So if we go to the site, www.root, here we have an app settings.json file. Let's edit that, and here are my secrets. I can not only see them, I could even change them. So anyone with access to the resource, and a typical organization, that's about anyone in IT, and all the testers and everyone, they can see those resources. So if any of those users, their account gets hacked, you have a big problem. So what's the next step? You might already know the service. Azure has something called Azure Key Vault to store your secrets. So we should store all our secrets, but not only application secrets, also certificates, anything that you want to be stored securely, you can put in there. But then we still have the story, what about local development? And if we have a new resource, Azure Key Vault, doesn't my application, my app service, need a key to access the Key Vault? We still have the problem there. Well, for local development, there's something called Secrets Manager. A Secrets Manager will store your secrets in your user profile. It's not completely secret. Someone with access to the user profile can still read them, but it's already much better than put it into source control. If you look at the Azure part, once it's deployed, we have Azure Key Vault, and we're not going to use a key to connect to Key Vault. We're going to use managed identity. What are managed identities? Of course, the next question. It's a security principle in Azure Active Directory. Since we're using Azure, we're using all the benefits of it. And you have two types of managed identity. There's a system-assigned one, and that's part of the actual resource. So my app service will have an identity, and I will use that identity to connect to Key Vault. In case you're building a microservice architecture, good or bad one, and you want a single identity for all your serverless functions, app services, Kubernetes clusters, because you don't want to manage them all, you can create a user-assigned one, use that one, and assign it to Key Vault as well. So what we're going to do, we're going to give the Azure resource itself an identity and authenticate with that identity against Key Vault. So let's switch to Key Vault, service in Azure. As you can see here on the left, we have keys, secrets, certificates. With my secrets, I have my connection string for secure storage, the storage account, the same for SQL Server. Does it have to be connection string with username and password? Of course not. You can go even a step further and use managed identity to connect to those services as well. But this is a first step. Now, we have a managed identity on my app service. And if we go to access policies, you can see here my application, which is the actual app service, only gets permissions to read secrets. My own user can do about everything, but this single app service or any code running in that app service can only get the secret. This was the way how to do it until very short. Now you can also use role-based access control to use that as well. So if we go to the role assignments on the resource, you can see here on top again the app service, and now it has a role of Key Vault's secret user. So we have very granular access to only secrets in a Key Vault. So I mentioned role-based access control. What is role-based access control? Well, you give a user a certain role on a certain resource. The concept, very quickly, it's a security principle. So that can be a user, a group of users, an application, or a managed identity, user assigned or system assigned. Then, of course, we need the scope. On the bottom right can be your a whole management group. That's a combination of multiple subscription. You can go down to a subscription, a resource group, or the actual resource. It's a good practice to try to be as low as possible to give very granular access. Then, of course, we need to define the role, and you have a role definition. If you have used Azure before, you most likely already know the top 3 ones: owner, contributor, reader. But every single resource has a very long list of more granular rights. You can create your custom roles as well, but with the built-in roles, you can already do a lot. If you're going to look up about the concept of role-based access control in the documentation, often they will say use the least privilege principle. Try to drill down to a single resource. If someone needs access on a single storage account, don't give them access to all storage accounts or all subscriptions. But Bart, there's a difference between environments. I want full access on my development environment, and maybe in most organizations where I typically come to, in the beginning, they also have full access on their production environments. Well, if we give everyone full access on everything, why do we even start with security? So we're going to have to lock things down. A possible structure or approach that you can take is shown on the screen here. In production, in my opinion, you should maybe see the resources, but you should not have access to actual data. So, for the storage account, SQL Server, you shouldn't even need access. You can approach them through your application because the application is tested secure, or maybe you have some tooling which is also tested secure to approach that. If you run SQL queries on a production SQL Server, one day you will mess up. We have all done it before. Just don't give anyone access, and it won't happen. If you go down the chain, previous environments, staging, test environment, the same. You can see the resources. Normally, you shouldn't modify them. Maybe to help testing, you can give someone access to the actual data, but it depends if that really improves the testing cycle. For development, you could say, yeah, I want full access, but even there, my approach is just give them reader access as well. Maybe a contributor on a research group so they can do some things, but often I even go down to reader there as well. Data, again, the same. Why do I drill down everything or lock down everything? Devs and anyone in a team shouldn't have write access on production resources and not have read access through going outside of the boundaries of your application either. What often happens is that you have a production database and you're going to restore it to previous environments because we need a valid environment or as close as possible to production to test. Well, as soon as you start taking that data out, you have again are opening up for security breaches, data breaches. So if there's any data in there that's personal identifiable, it should be never restored, or it should be cleansed first before you restore it to previous environment. That's an approach I typically take with organizations I visit. And then, of course, you have what if in case of support. If you need actual write access to a resource to change something to data, we're not going to give you full rights out of the door. We're only going to give it right in time. And for that, there's something called PIM, Privileged Identity Management. Again, part of Azure Active Directory. This time you will need a premium P2 license, so the most expensive license, because often security comes with a cost. The organizations that help you build software know that as well, that they can charge for security, but it helps you in the long run, and the cost of a breach often is a lot higher than the cost of preventing a breach. What does PIM do? It gives you elevated access to a resource just in time. You can enforce multi-factor authentication when somebody tries to get that access. If necessary, you can even put a justification approval process behind it. You can have access reviews, so you can see who can actually access the resource through PIM. And maybe the most important part, you have notifications when that person elevates access, and you have a full audit log. So if someone tries to get access to your resource, you get a notification, you know who does it, when it happens, so you can have a trail at all time. That's much better than giving anyone full-time access to that resource. So we're going to open up the door just in time, so somebody can do an action, maybe give them a window for 2 hours to do the things that are necessary, and after that, access or the role-based access control rights fall back to typical the reader. The third one topic we're going to cover is the pitfall of great tooling. We're happy to have great tooling. If you look at Visual Studio Code, but also other products like maybe Rider, there are plenty of them out there. They all help us to be productive, and that's what we like, to be developers. Someone who hasn't done it before, the screenshot that is shown there. I've built my API in code, right-click publish. I will create a new publish profile here, publish it to Azure App Service, Windows. You pick the one that you want to deploy to. Skip API management, but because who cares about security, right? We create a publish file. You simply hit this button here on top, and within a few minutes, all your code is live in production. That's being productive, right? Even today, at the companies that I come to, they use this every single time to go to production. It's opening up for problems. Yeah, Bart, you want to lock down production, I understand, but there's a difference between environments. I still want to do it for staging, for test, for dev. Yeah, maybe not. Friends, don't let friends right-click deploy. Only do it during demos. Use Azure tooling for speed during research, proof of concepts, but build and deploy should be done with automated pipelines. Most of you probably already know the concepts of CI/CD workflows. You have a piece of code, you will build it, you will run tests against it, and if those tests are successful, you have an artifact, you put that artifact aside, and that's versioned. Then the deploy part will take that artifact, deploy it to an environment, maybe run some extra tests against it, and only change the configuration. I'm not going to say change keys, because keys are already stored in Key Vault, and we're only going to change the point where we deploy, and that point knows which Key Vault to use for all the secrets, and we're not going to change those anymore. But Bart, there's a difference between environments. Why else would we set up all those environments? Well, because you keep nagging about environments, you can have them. But before I give you even an extra environment, security-wise, every single environment in your release pipeline should be considered as production. We don't want our secrets in source control, not for dev, and certainly not for production. We don't want to break production by hand because we give access. We're going to limit those role-based access control rights. And we're going to prevent breaking production by CI/CD, because the pipelines that we're going to set up, every single environment will have their own security principles to deploy only to that environment. And we won't reuse the security principles of a pipeline either, because we're all developers. We have one pipeline that works, we copy that for test, we copy that for staging, and maybe in one of the steps you forget to change the actual resource. It could be that your test environment is deploying to production or vice versa. By using different security principles, you take that away, you will have a failing build, but then you will see that there was an issue copying your pipeline. You will prevent lateral breaches by limiting role-based access control. So someone who has access to maybe development certainly can't try to mess with data in production. And we will prevent non-production data breaches by, if we restore, that we will cleanse our data. A short resume of the things that we already seen. And then, and that's from reality, developers start saying, but then I can't work, I need to try out things, I need to do research. True. Development, you have tools like ChatGPT that can already do nice things, but we still have our value. We still have to research things, try things out. And for that, I give you yet another environment, because you like environments. You can get a sandbox environment from me. A sandbox environment is a place where you can do everything that you want to. Maybe you should put some cost management on top, that it doesn't cost too much. The great news is if you have a Visual Studio subscription, you already have your own Azure subscription. Simply go to my.visualstudio.com, find the Azure blog there, activate it, and depending on the size of your subscription, you will have $75 or $150 every single month where you can try out everything. If that's not enough, then the company can set up a sandbox environment as well. And what you see on the picture here, we have our sandbox and subscriptions at the bottom right. There's a management group on top of there to group those. It might be a good idea to put some special policies, role-based access control in place, so you separate that from your production environment. Maybe prevent creating resources in Brazil, because those are very expensive. Sorry for everyone living in Brazil. And then maybe the final question is, if we try out things, we need maybe a new app registration. Do we put that in our main Active Directory, or do we set up a sandbox Active Directory as well, so the developers can play around? Depending on the size of the company, how you want to manage it, it's certainly a viable option. So we still get your tools, you still get your playground, but not where actual code that one day goes to production is deployed. The next point, we have some principles in place now. We know that we shouldn't store credentials in our code base. We know that we should limit our role-based access control. So we have those things covered, but we still have some open windows in our architecture. You're probably going to ask, what are those security holes that are still left? When we were on premise, you had something in place by IT, that big firewalls. You have an enterprise LAN on the left, internet on the right, 2 firewalls in between, and a DMZ in the middle, where you host some websites that should be available from the public. If everything was set up correctly by IT, then internet couldn't go to the enterprise LAN, and that everything was secure. The cloud has the same. We should do or try to do the same. If you look at our solution, we left quite a few windows open. I put some red crosses on there, and you're going to ask, what are those issues that we left open? I already showed you the Kudu console for the application. If maybe before I'll show you the other problems, I'll run the application from Visual Studio, our little API. Because it wouldn't have been a developer talk without running it. Let me quickly try it out, the API. That's what Swagger is good for. And you see, I hit a breakpoint or an exception. Cannot open server, SQL dev security requested by the login. And the client IP address where I'm sitting now can't access my resource. That's a good thing, that you can't access your resource. SQL Server is one of the few resources where this is done by default. But of course, for demos, it's not as handy. So let's quickly solve that. Microsoft did a good job. Everything networking related you will find under networking. It's very easy. And by default, if you set up a SQL Server, public network access is disabled. Of course, if you want to load in some data from home and do some demos, you will enable that. And they even made it easy. At your client IP address, save. If I would now run my demo again, everything will go through. I will get my data out. Success. But you see a problem coming up here. I just added my client IP address, but tonight if I get at home, I will have to look at these timestamps that are luckily added to know which one is which. Apparently, this morning at the hotel, I added one as well. There's a don't delete, but I can't remember why. There's a home IP address, but with a whole team, I'm not sure which one. And there's an office IP address in there. So we see this list will grow a lot longer over time. Often, people don't clear up those IP addresses, and often we don't have a fixed IP address either. So we're poking all little holes in our network security. But at least SQL Server has it by default already on. If you look at Key Vault, similar networking, allow public access from all networks. Same goes for storage account. So, as you can see on my site, networking-wise, every single resource has public access. Now you can say, Bart, SQL database doesn't have a cross, and that's secure. Well, that's mainly because it's a resource, sort of container on our SQL Server. The security is set on the SQL Server. First, networking-wise, similar storage accounts, if you put a container below that, and that would be very similar. So let's have a look. Let's have a look at cloud networking security. Azure Virtual Network is our primary component there. Then, of course, we have PaaS components, resources that are shared, the storage account, SQL Server. That's not something that we deploy ourselves. It's deployed by Microsoft. It's shared. So if we have our database, our own SQL Server on shared infrastructure, then we will need something to securely pull that into our network. That's where private link and private endpoint come into place. Once you set that up, Microsoft will themselves block access from the internet. So the resource is accessible from your own virtual network, no longer from the outside. That's for SQL Server, Key Vault, and all those PaaS components works the same way. And once everything is securely in a VNet, of course, you will have to expose it to the outside. And then we are looking at Azure Firewall, front door, application gateway, API manager. And there are multiple options there as well. API manager, the name says itself, it's for APIs. But again, look at what you need. Front door is typically global, application gateway typically regional. There's a nice overview on the Microsoft Docs site that tell you what to use for which use case scenario. HTTP and non-HTTP. Plenty of choices. If you look at our very small solution in a secure networking solution, you typically have your app service in the middle in your VNet. You see on the top and the bottom our shared PaaS components. We're going to access them through a private endpoint. So those are now secure from the external network. We put API management in front of it because we have an API. Our website itself, we're going to host on static web apps. Stacy showed us the power of that. So we're going to use that as well. And then we go finally expose it with an Azure front door. Put some Azure Active Directory in front of it for authentication authorization. Looks like a nice picture, and it does work. Also looks like a very expensive solution. If you have typically an app service running, access those resources, SQL Server, DTU based maybe, it's 100, 150 euros, already decent size, can bring it down to even half of it. If we add in API management, front door, all those resources, and take the networking parts, you will easily up your price by a factor of 10, 20, even more. So that's very expensive. Again, Microsoft knows, but not only Microsoft, all cloud providers know that security is important. They need dedicated machines to set that up. You will pay for those dedicated machines. There's also a dev problem with security. We want to be productive. If I lock everything in a single network, you can't reach it anymore. And the case is that you want to go to the Kudu console, maybe download a log file, and you can't do it anymore because it's all in network. You can't deploy manually anymore, which is very good, but you can't deploy through CI/CD anymore either, because the hosted agents, be it on GitHub, Azure DevOps, Bitbucket, any of those platforms, those are in the public network as well. there might be an option to put a single hole in your firewall so they can come through, but then we have some holes again, so that's not the ideal solution. What the solution here is, you will have, or you will need a self-hosted virtual machine, build machine, a container. If you Google or Bing for solutions there are plenty of them to bring down the cost of that as well. But that machine has to be inside of your virtual network. And then the second part, in being productive, we can't verify our change anymore, the SQL data, other things, because it's inside a network. And one of the first things you might see someone trying to upload or download some files from blob storage, same problem. So you have to get into that network. Microsoft already has something in place, Azure Bastion, which is a jump host that you can access through the Azure portal. So you already have the security of the Azure portal. Then go into Azure Bastion, you get inside your network. You can maybe set up a VPN, a client VPN, or from your office, a peer-to-peer VPN. There are express routes and just site-to-site VPNs for that. Or you can use Azure DevBox as well, which is in preview. And if you have been doing a consultancy and you get at a client where they give you a 6-year-old laptop to work on, then you will be happy to have an Azure DevBox. You can scale it up and have a decent development machine. But again, of course, the bigger you go, the more you will pay. So these resources does cost some money again. As mentioned before, security is trying to find the ideal balance between cost and mitigating your risk. So will you build that solution that I showed, the networking solution, for a simple app application? Probably not. It's simply just too expensive. But if you look at more enterprise applications, that's one of the things that we often do. And then the final one, the hazard of procrastination. We're all developers. We love procrastination. We love doing things at the last minute. You probably or hopefully are saying right now, Bart, we believe you, but we're working with Scrum. We have to deliver features first, and we will do security, right before we go live. We should know better. When was the last time you did underestimate the complexity of something you don't do every single day? And security is something we often don't do every single day. When was the last time you did finish a large project without bugs, important, on time, and had enough time spare to implement something extra as complex as security? And when was the last time you implemented a major change the week before a release and didn't regret it? We've all been there. I've been a developer as well. I still write some code from day to day. We love to take our shortcuts, but it bites in our behind. Security is not an afterthought. We've covered it before. Pull it up front in your development lifecycle because it will help you to deliver secure software. Quick conclusion. I already gave one in the middle because those aspects are just too important to miss. Define your security needs of your project as soon as the analysis phase. If the product owner already says this is a potential risk, or you bring someone from the security team in, it's very useful. Fine-tune those needs according to the cost, or you won't build a complete secure network solution for a simple app recipe. Implement the security measures as soon as possible, so it helps you, and you can test them out from as soon as day one. You don't have to do it as an afterthought. Coach your teams how you work in a secure way, and get the help of experts, both internal in your organization or external as well. I'm not smart enough to do everything about security. Maybe some of you are, but it's always good to be challenged to get the help of extra experts. What we haven't covered yet, because of the sake of time, there are plenty of tools to help you here. Monitoring, both during implementation and after going live. If you look during implementation, SAST and DAST tools, static analysis tools, during CI/CD, Git hooks to prevent key commits, options there as well. Once we go live, if we look at Azure in particular, There are tools like Azure Defender, Azure Sentinel that help you out. The resources, Microsoft has done a great job on the documentation. In the last several years, if someone asks me where can I find more, I typically point them to the Microsoft Docs, Microsoft Learn, because those resources are just so good. Cloud adoption framework for Azure. It's a proven approach for cloud adoption. Security is a big aspect of it. Once you go to the cloud with your organization, certainly have someone look at that as well to get you started. And then the third one, Azure Architecture Center, which has hundreds of architectures. And I quickly wanted to show that one as well to conclude. Simply browse the architectures. You can see right now there are 846 results. And if you put secure in here, there are 451 architectures that already give you a head start to get your help started. You can see here, DevOps for AKS, hybrid networking, plenty of those. Have a look at them. You don't have to reinvent the wheel. Use those to get started. And then certifications. Some companies need them for their partnership, but in my opinion, use the learn part of the certifications to learn the technologies. If you know the right technology to do the right job, you will already do a great first step in building secure software. As for developers, that's the Developer Associates, the AZ204. If you want to go an extra step further, there are plenty of security-related topics as well. And with that, I would like to thank you. I hope that those 5 topics tickled your mind, that you're going to start thinking about security. I'm always available on Twitter. You can find some of those topics more into detail on my blog as well. And thank you for joining me.
Amazing. Thank you, Bart. That was really, really a good talk. And what struck me is that people can actually start working on security themselves and they do not need to do a lot of effort. It is not a very high lift to get started. That's what struck me the most in the beginning part of your talk. It's all like, actually, it sounds like working in a more secure manner actually saves me time, and I'm being more secure at the same time. Why don't people do this?
Because they might be afraid of security. It's such a broad topic, and it takes a bit of effort in the beginning, like using or taking the secrets out of your configuration. If you don't know that those tools are available and you can't do it, you won't do it. You need someone to tell you it's available. And once developers know that it's available, they will start using it, and it will feel like their second nature, and it will be easy. But it's again finding out what they have to do.
And look at the architecture doc.
Exactly.
Because those are amazing.
They are amazing. The docs in general, but also Architecture Center, they are amazing. They help you out to get started.
So if somebody's gonna think of, hey, I'm gonna deploy a new application, we're gonna need a new architecture, that would actually be probably the place where people should start to get secure from the get-go.
Exactly.
Awesome. Well, thank you so much for being here. I really appreciate it. I hope the people at home love this talk too. And it will, of course, be online, like all the talks for this day. We're going to go for a short break before our next speaker. Stay tuned. Thank you. Hey, welcome at Virtual Azure Community Day. Thank you for being here. We're live from the Netherlands, here in a beautiful studio in Utrecht. And I have a new guest here, and that's Eduard. And I was listening to the previous talk, and that was continuously about, but Bart, I have multiple environments, and I was thinking of your talk to make the joke, but Eduard, I have multiple multiple cage clusters.
Mhm.
But no, thank you for being here.
Yeah, no problem. I like it.
Yeah, I'm so happy to have you. And the topic that you're gonna talk about is about actual doing containers,
Mhm.
doing Kubernetes, but made easy
Yep. I
and
don't know
simple.
Kubernetes.
Well, I think that a lot of people don't really know Kubernetes.
Exactly. That's my point.
Yeah. Would
Yeah.
you argue that people would not all need Kubernetes?
Um, well, first of all, the entire container technology the question is using containers mandatory or not? And the answer is always, it depends. Because there are a lot of great services available in Azure. So why should you use containers anyway? But if you go for a container technology, then the question is, do I need Kubernetes, yes or no? And basically for production environment, most of the times the answer is yes. But Kubernetes is very complicated, and not everyone is interested in learning that technology and having all the skills to control everything that you need to provision and maintain a Kubernetes cluster. And there's a fairly new service in Azure called Container App. And that's what my session is all about. And in that session, I explain a way easier way of running Kubernetes under the hood, but don't have to learn all the nitty-gritty, complicated switches and knobs that you can twist in Kubernetes.
I'm delighted. Can't wait to hear more and learn more about that. So I'm not going to ask you all the questions that you're probably going to handle in your session. So yeah, take place.
Thank you.
And good luck with your session. Like always, if you have any questions, you can leverage the chat that is conveniently at the left or right side of your screen somewhere. It's with all the lines where you can type. And without further ado, here's Eduard telling us more about container apps. Take it away.
Yeah, thank you. First of all, I would like to notice that again we're in a virtual conference, but what you don't see is that in the background there's a lot of people working to get this conference up and running and doing a lot of effort. So please use the chat and throw a word of thank you in the chat. The organizers are reading along, and that will make them smile. And with that, let's go to the container part of my presentation. And my presentation is called Kubernetes Made Easy, because I think that Kubernetes is fairly complicated, as I already discussed with Susanne. And I want to make Kubernetes easier for more people to control and to use as a service in Azure. So the agenda for today is, first of all, I'm going to explain a fairly new service called Azure Container Apps. What Azure Container Apps is, how environments work, and how you can use it to accept HTTP traffic for your services, or maybe different traffic. And there are a lot of tools that you can use in Container Apps. And so I'm going to walk through all these technologies throughout my presentation, but I'm also going to demo how I get a certain environment done from the moment that I start developing the service all the way up until it's deployed in the cloud environment. So now a little bit about me. My name is Eduard Kells. I'm from the Netherlands, and from the Netherlands, I'm a cloud solution architect at 4.net. And everything is out there. So please, if you have any questions and you don't feel comfortable asking those questions in the chat or whatever, then please notice all my handles are on the bottom right of the shared screen. On the bottom left of the shared screen, please contact me, ask your question if you like. So with that, running containers in Azure. Now, you should see a container as a, if you compare it to a physical container, as a sea container that you see on the boats, then you can compare that with a container, with a software container. So you have this container, not actually physical, but there's a container and you put your software inside it. And the nice thing of this container is that as soon as you plug the container in, it will and it operates, you can plug it out, bring it anywhere, and then plug it in again, and it will still work. So it brings you the ability to move containers to certain different environments, plug them in, and if the container is correct, it will still work. So in theory, if you don't like Azure, you can go to AWS. So plug out your container, move to AWS, plug it in, and it will work. But not all the times, by the way, because there's you probably have some integration in your container left and right that you need to take care of when you bring your container from one environment to another. So running containers in Azure, there are a couple of flavors that you can use in Azure to run your containers, and you see 3 of them, the container instances and web apps all the way on the left, and all the way on the right you see AKS. Now the difference is with container instances and web apps, they are fairly simple because you can just bring your container to that service, tell the service to run your container, and it will run your container, but that's about it. You have not too much control over your container. Scaling is fairly difficult. And all the way on the right you see AKS, which is Azure Kubernetes Service, and as we already mentioned, this Kubernetes is very complicated. You have a lot of knobs to dial, and there are a lot of things to control, and you have to know what you're doing to get that cluster up and running, and you have to maintain it to keep it up and running. Now, as you see, there's a gap in the middle, and this is where Container Apps steps in. So Container Apps sits somewhere in the middle because it's still fairly simple to control and fairly simple to provision, but under the hood you do run Kubernetes. So you do take advantage of the Kubernetes cluster and all the things that comes with Kubernetes, but you don't have to have all the knowledge of the Kubernetes cluster to control it, because there's now a new abstraction layer called Container Apps that makes this controlling this environment fairly easy. Now, I would like to go and encourage you to follow this URL. It's bit.ly and then Virtual Azure Community Day 23. This is the year, obviously, because this link will bring you to a service that I created. And with this service, I would like to monitor your current experience with containers. And it is this environment. And when you follow this URL, you will end up on this page, and it will ask you a question. Have you used containers before? And there are 5 different kinds of answers. One is nope. The other one is a local machine. Yes, I used containers in the cloud. I run containers in production, or I am a Kubernetes guru. So I will go ahead and go for the production vote. And hopefully, yeah. I see already votes coming in. I see some local machine votes, and I see the majority run containers in production. And there are some cloud options coming in. All right. I just want to get to know my audience a little bit. All right, I see some votes coming in. Now I have the majority says, okay, I did some containers in ooh, no, we're switching. Okay, so nobody says no, I didn't do any containers, and nobody says, okay, I am a Kubernetes guru. Everyone is somewhere in the middle, which is exactly what I'm looking for. Now I have a different question. If you used containers before, so if I'm correct, your screen will now change with the different questions. If you used containers before, then what technology did you use to run those containers? And that is mostly for this question targets Azure. So it's non-app fabric, web apps, container instances, AKS, or a different service. And I see AKS and container instances. Only 2 votes came in, so we will wait just for a couple of minutes, maybe seconds. All right, it stays the same. So the answers on the technologies are AKS and container instances. Oh, and I see a lot more flavors here. Other and none. Okay. Nice. Okay, so now we know that there are people working with containers. There are not too many people working with containers in cloud environments, and if they do, they mostly use container instances, AKS, or a different service. All right, nice to know. Keep this demo in mind, and I will continue the presentation. So now there's this new service called container apps. Now, what is a container app? Again, a container app is a way of controlling Kubernetes under the hood. And a container app relies on a container app environment, which I will tell about in a bit. So when should you use container apps? You can use container apps when you want to deploy API endpoints, hosting background processes and applications, handling event-driven processes, and running microservices. And especially the last 2 bullet points, I think that's where container apps start to shine. Because if you have microservices running in a cloud environment, you always have the challenge of having the services to communicate with each other. So you need some kind of messaging system. So then you go for a service bus or event grid to make sure that the services can communicate with each other. Now, container apps comes with Dapr, and Dapr is a sidecar mechanism that you can leverage to take that stress away. For example, if you want microservices to communicate with each other, you can use Dapr to immediately make a call to a different service in your microservices environment without having to have an additional service. I will show Dapr in a bit. Now, I also mentioned a container app environment. Now, the container app environment is an environment that lives around all your container apps. So this environment ties all the bits together. And when should you create a container app environment? Well, there are a couple of things that you need to keep in mind because in theory, if you have multiple container apps, it is possible to create a container app environment for each and every container app. But probably the container apps have some kind of cohesion that in the end will create your entire application. And if that is the case, then you want these container apps to live in the same environment, because then they are visible, for example, through Dapr. So if you want to communicate with Dapr from one service to another service, then both these services need to live as a container app in the same environment. So when we make this a little bit more visible, the dark blue area around all the container apps is the container app environment in this case, and there are 2 container apps that live in that container app environment. And a container app can have 1 or more revisions active at a time. And in a revision, you have replicas, which you can use for scaling. So if some service is under pressure because there's a lot of traffic, for example, it can scale out, make more replicas, and a replica will run 1 or more containers. So this is basically what a container app environment and container apps look like in a cloud environment. Now, let's go and dig into the Azure portal, see what the services look like in Azure. So I have a couple of resource groups, and these resource groups all form the polling application that you all used to cast votes on my questions at the beginning of these sessions. And for the remainder of this session, I would like to show the entire container app environment and the container apps, how I created this environment, and how I deploy the environment into a production ready environment. I will zoom in a little bit. And this Polestar integration production North Europe and is my container app environment. And when I scroll through this environment, you can see that it already comes with Dapper components that I configure. Again, I will handle Dapper in a bit. It contains certificates, so you can upload your certificates in one central environment before you use it. You can use custom DNS. So this is for wait, this is new. I didn't see this. All right, so you have DNS suffixes. I think this is for custom domains. And then obviously you have your apps, and these are all the container apps that live in this environment. Now, it is important to understand that when you create an environment, you are going to have to choose a certain virtual network that environment lives in. And if you don't choose a virtual network, then the container app environment will create one for you. So there's an advantage here, because in the previous session you saw that a virtual network is important for protecting your services from the big mad internet world on the other side. So when you want to protect your services, then a virtual network is the first step. And with container apps and with a container app environment, that first step will be taken for you. So again, you can bring your own virtual network and tell the container app environment to integrate in that virtual network. And if you don't, then the container app environment will create a network for you and run that under the hood. So you don't have to control that network services if you don't like to, because the environment will do that for you. So now if we dig into container apps themselves, now we have seen the environment. There are also container apps that live in that environment, and maybe you want these services to be available for the outside, for the public internet. And there's a setting called ingress that you can use to configure how your service must be available for the public internet. And there are two flavors here. One is limited to the container app environment. So this is, again, if you don't provision your own VNet and have the container app environment do that for you, then if you choose this setting, services can communicate with each other within the container app environment, but not services from outside the internet cannot reach your container app. Then there's a setting limited to your VNet. That means basically the same, but then in your own VNet. So every service inside your VNet can access the container app, but everything outside the VNet cannot. So the service won't be available for the public internet. And the third option is from anywhere. That basically means the public internet, everyone on the public internet can reach your container. Each and every container app has a property called secrets. And you can compare the secrets to key vault secrets, but you should not rely that heavily on the secrets of a container app, because you don't have that much control over who can access those secrets, who can set those secrets and whatnot. If you really want to use secrets, and again, in the previous session, you saw that there's a thing called managed identities. So please use managed identities or user-assigned identities to connect to different services, but sometimes you simply cannot go around secrets. So if you really want to use secrets and you want to use secrets in a production environment, then still I think it's a good idea to use the Azure Key Vault instead of using secrets in container apps. But also in this case, sometimes you need to use secrets of a container app. So please know that if you want to use a secret, you don't have an Azure Key Vault available, then this is the way to store secrets. So don't use any text or something. Changing secrets can be done on the fly. It doesn't affect the running environment. It doesn't start a new instance, for example. So it will not impact any existing running revisions in your production environment. Now Dapper. Dapper is huge and amazing. Dapper is an abbreviation for distributed application runtime, and it runs as a sidecar. So as a developer, you don't really have to know what happens under the hood, because the technology of Dapper will attach to your system. And it will understand what your system needs to do, and it will handle accordingly. And it's really magic. So there are a couple of components that you can use, a couple of Dapper components that you can use in container apps. For example, caching, this messaging mechanism, storage, but also intercommunication between the services that live in your container app environment. And Dapper will take care of the resilience. So for example, if you want to communicate from one service to a different service, and the initial request fails for whatever reason, then Dapper will take care of retry mechanisms and the service breakers and whatnot. So you don't have to do that all manual. Then there's Kida. Because container apps under the hood run Kubernetes, there are very sophisticated ways of scaling your container apps in your cloud environment. And Kida comes out of the box, and Kida stands for Kubernetes Event-Driven Autoscaling. Now, what is that? I already mentioned, if you have a microservices environment and you want these services to communicate with each other, one way is to, for example, use Dapper and make a direct call to a different service. But that would make one service dependent on a different service. And sometimes you simply don't want that. Sometimes you have a certain process and you want to distribute that process and make that happen in the cloud. And once the process is done, then you get back to the user and say, hey, I did, for example, an import process or whatnot. I am done. And when you want to create that, then a messaging mechanism, for example, the service bus or event grid, are good tools to use in your Azure environment. But now let's assume that a lot of messages come in, for example, on the service bus queue that you need to handle, and your service cannot handle that. Then you want to scale your service out. And this is exactly what Kida does for you. So you can configure Kida to monitor, for example, a certain queue in a service bus or a topic or event grid topics. And it will recognize the work to be done on those queues, and it will scale the service out to multiple replicas. And when all the work is done, it will scale these services back in, making sure that you don't pay too much money for a scaled out environment. So it is really flexible. Now, there are two ways of scaling your system when you run container apps. The first one is Kida, and the second one is HTTP traffic, because Kida doesn't monitor HTTP traffic. So if you have a service that accepts HTTP calls, you can also configure your container app to scale depending on the amount of requests that come in. Now let's dig into the Azure portal again and see what the container apps look like in the environment. So what you saw is this polling application that you guys all casted votes on in the beginning of this session, that in the basis contains of 4 different services. One service is a user service, and the user service is used to identify each and every one as an individual person. So once you hit the website, the front end will make a request to the backend. That is the user service. It will generate a GUID so it can identify you as an individual. Then there are 3 different services. One is a session service. And the session is, in this case, the entire Virtual Azure Community Day session for this Polestar application. And in that session, I can configure multiple questions. So I fired 2 poll questions to you. One is the container technology question, and one is the have you ever used container session. So basically, in a session, I can group multiple polls. So one service is the session service. Now there's a poll service. And in this poll service, I can configure questions and possible answer options. And the 4th and last service is the vote service. And the vote service consists of a container app that accepts votes and a function app that will process votes in the background. And then in the end, there's one reverse proxy that will accept all incoming traffic and redirect the traffic to the corresponding service. So, for example, let's dig into the poll service. This is a container app that lives in the Polestar integration production North Europe environment. So that is the container app environment that I already showed you earlier. So all these services that you just saw live in the same environment. Now there's a couple of properties here. You can see that this one already exposes a URL, but if I follow that URL, you will see that it is not available. And that is because the ingress is set to only accept traffic from inside the container app environment. This is the secrets tab and with the secrets that I already told about. And as you can see, I don't use any secrets because secrets are evil. So if you don't have to use secrets, don't use secrets. And if you do, then please use the key vault. And if you really cannot use the key vault, then use secrets here. But for most of the services, managed identities are available. So please use managed identities or user-assigned identities if you can. Then this ingress, this is where you decide what type of traffic you want to accept. And in this case, I do accept HTTP traffic. So the ingress is enabled here. And as you can see, ingress traffic is limited to the container app environment. So this service accepts traffic, HTTP traffic, and it will redirect HTTP traffic to port 80. And this is the port that on my container that is exposed. So it will accept HTTP traffic and it will redirect the HTTP traffic to the container that lives inside this container app. But again, it only accepts traffic from the container app environment. Now, there is a setting for continuous deployment. You can hook container apps up with GitHub if you like, and then GitHub will fire an action, and from there you can automatically deploy any changes to your container app environment. I do this, but manually, and I will show you how I created the GitHub actions together with infrastructure as code to deploy this entire environment. Now, custom domains, obviously you want some services to be exposed to the public internet. And with custom domains, you can give them a nice name and hook your own domain on it if you like. Now, with Dapper, you can leverage the components that come with Dapper inside these container apps. Now, I don't use any special components for this service, but I do have Dapper enabled, because if you have Dapper enabled, you already leverage the ability to communicate from one service to another. And Dapper uses the service discovery in Kubernetes to make sure that you target the correct service. So the only thing that you have to do is make a call to a certain app by name. And as you can see here, this app ID, in this case, the ID of this application is Polestar-Pols-API. So from within my container app environment, I can use Dapper to make a call to HTTP and then the name of the service, and then a certain port, in this case port 80, and then Dapper will make sure that that HTTP request will end up on this specific service. And in this case, I do accept HTTP traffic. You could also go for gRPC if you like, if you want, for example, binary data. Then this gRPC may come in handy. And a couple of buffer settings, but I'm going to skip those for now. Then there's identity, and this identity is a managed identity. You can turn it on and make sure that this service appears as an identity in your Active Directory, so you can give it permissions or grant certain roles to it, so it is capable of accessing resources that you like. And I use this because in my central environment I have Azure, the Azure Configuration Service and Azure Key Vault that contains all the configuration for my containers, and I need to access those services, and I use this managed identity to make sure that I use this identity as for role-based access to make sure that I can access those services. All right, and finally there's revision management. So there are two different strategies if you want to roll out new revisions. One is single, so all my services in this environment are set to single, and the second one is multiple. And the difference is that with single there is only one revision active at a time, and with multiple you can have multiple revisions at a time. And what you see in the background here is this grayed out traffic. It says the current active revision receives 100% of the traffic. And what you can do is create a new revision. If you have the revision mode set to multiple, create a new revision and then change the percentage of traffic that ends up in the first service and the percentage of traffic that ends up in the second service. If you have an HTTP endpoint ingress enabled for your application, you can also use this label and then target a specific revision because this label will end up in the name of the URL of the revision. So then there's containers. Again, a container is a piece of software, and a piece of software needs to be it's an image. So and this image needs to be stored somewhere, and somewhere in a public place that this service can fetch the image from. So in this case, I use the Azure Container Registry. And in my pipeline, I will build and compile the container. So then I end up with the container image, and I will upload that container image to this registry. And I will tell the container app that it needs to pull the image from a Azure Container Registry, and then this specific registry, and then I tell, okay, this is the name of the image that you need to pull, and this is the version of the image that you need to pull. Then with environment variables, you can configure your container. And there's not really much to see here because all my configuration is handled by the Azure Configuration Service. So the only thing that that my environment variables contain is the link to the Azure App Configuration Service and the name of a local storage account that I need to store data in. And again, this storage account is accessed through managed identities. Now back to the scaling rules. I already explained that there are two different ways of scaling your application. One is HTTP traffic and one is SCADA. Now this service is a HTTP service, so I have a HTTP rule configured, basically stating that if there are more than 30 requests per second, then you need to scale up one replica. If I go back to my container app environment and then apps, and then this votes from container app, this is again a container app that lives in the same container app environment, but this is an Azure function. And this Azure function has a function that is triggered by a message on a service bus queue. So this service can be scaled with Kida. Now, if I go to the same scale tab, I see a event-driven rule right here. And with this event-driven rule, I can say, okay, I want to scale in a custom way. This is the connection to my service bus queue. And I want to scale up if the amount of messages on the votes queue exceeds 20. So if there are more than 20 messages on the votes queue, the service will scale up and deploy a new replica. And if the amount of messages then drops again, it will scale the service back in. All right, so now you have seen the entire environment. This is a visual representation of the environment. So again, there all the way on the top right, there's this user app, a sessions app on the below that, then a polls app and a votes app all the way on the bottom. Those are the four services that I need to host the poll environment. But then I thought it was a good idea to have a gateway app, which is basically a reverse proxy to handle all the incoming HTTP traffic and redirect that traffic to the service accordingly. And that is where I use Dapper. So I want to show what I did. And this is a Node application, and I didn't know Node before. So this was a nice... Oh, this is the wrong service. Oh, hold on. This was a nice experiment for me. I used GitHub Copilot for most parts of the creation of this service, because again, I didn't know any Node. Reverse proxy. Oops, sorry. Yeah, there we go. So this Node app, in my container and app environment, I exposed this Node app to the public internet. So this service accepts requests from the public internet, and you see that I have a couple of routes configured, and each and every service that I want to target in my container app environment is represented by a certain route. So let's, for example, go to the sessions route, and that basically means that everything that every request that ends up to my service/sessions will be handled by this service, and you will see that it redirects the traffic to a certain target URL. But this target URL says, hey, you need to target the Dapper sidecar. Now let's go ahead and investigate what this Dapper sidecar does, and I will zoom in a little bit. On line 9, you will see that it will target localhost and then a certain port, and the default of this port is 80. And it will also target a certain service name, and the default of this service is Polestar Session API, but it's, in the end, the name of the service is configured by configuration. This is the name of the Dapper application ID, and this is the port that we target. So what happens is right here, I will redirect the traffic to a certain service, and I will add a header. You need to target an application with a certain Dapper ID, and this is the name of the Dapper Dapper application ID. And what happens if you run this, for example, on your localhost? It will go. Your request will end up on localhost and then port 80. If you run this in a container app environment with Dapper enabled, then Dapper will kick in and will see, hey, you want to target a certain Dapper application ID. I will go ahead and use service discovery to see if I can find this service in your container app environment, and I will target that service instead. So this is really magic. You can use so again, if I go to my container app environment and then to the Dapper tab, so this means that you can use this poll start votes function name to redirect traffic to this specific function. And that is all that happens in this reverse proxy. The only thing that I do is use service names of services that live in my container app environment to target the services from the reverse proxy. All right, next up, I want to show how I deploy the entire environment in Azure. And to do so, I think it's important to have a different project that lives completely separated from all the applications. And this different project is a infrastructure as code project, and I use Bicep for infrastructure as code. And this will deploy my entire. I call this an integration environment. So this will deploy my container app environment, so it's ready to receive all the containers that I want to host in that environment. And as you can see, there are a couple of parameters, and I'm going to skip those. I'm going to go ahead and dig into the integration, because this is where the magic happens. So all the way on the top, this is my container registry, and this is where the containers end up once the build process for a certain container is done. So this entire project is hosted in GitHub, and I use GitHub Actions as a CI/CD mechanism. And in GitHub Actions, I will go ahead and compile my system and create a container image. And then I will upload the container image to this container registry. The only thing that I have to do the only thing that I have to do when that is done to deploy the application is to tell the service there is a new version of this container. Go ahead and grab that container image and run it. Then there's this Azure App Configuration service that I need to be able to configure all my services. And obviously, all the way on the end, I use Log Analytics and Application Insights. You can hook Application Insights into your container app environment. So when something went wrong in your container app environment, you can go ahead and look into Application Insights or in your Log Analytics workspace to find what's going on. So that's a really nice way of handling errors. And obviously, each and every container hooks into the same application insights, so I can log and send metrics to that environment if I like. Now, this one is very important. This is the deployment of the container app environment itself through infrastructure as code. So it's fairly simple. You give it a name, and then all you have to do is make sure that this Log Analytics workspace is attached to your environment. Now I use Azure Web PubSub to make sure that I can handle real-time traffic for the polling mechanism. There are a couple of secrets here. Well, this is basically all configuration values that end up in the Azure configuration service. So, for example, there's a service bus for handling votes. And if services want to connect to this service bus, then they need to have the name of the service bus, and this name of the service bus is configured in Azure App Configuration so that all the services can access it. Now, if we dig into a certain application, so this is the integration environment. Now let's dig into a container app itself, for example, the Votes API. This one hooks into the environment, and as I already mentioned, I use GitHub Actions to deploy everything. So the first job that happens in the GitHub action is this versionize job. I use semantic versioning for versioning my systems because I think it's really nice to have control over the next version of my system and make the version number predictable. And this is where the magic happens. So I will log into to my Docker container, to my container registry in Azure. I will build the containers, and the version of the container comes from this versionize step. So it needs the versionize step, and the output of this versionize step is the new version of my container. And I also built a container with the version latest. And both of them are uploaded to the container registry. This is, I'm going to skip this part because this one is specific for the function, which is basically the same. It builds up a container with the name function. This is the function app that handles all the votes. And now this publish bicep, this is actually publishing my container app environment using bicep in my production environment. So what happens? It will. Oh no, sorry. This is the publish bicep. Sorry. Need to skip to this one. This is where I deploy my environment to my production environment. So I log into Azure, and then I deploy infrastructure as code using this command. So that is AZ deployment to a subscription, create a new deployment, and then name that deployment on a specific location. And now the deployment itself is also handled in using infrastructure as code. And that is this function app. No, this is again, that is this container app. So this container app tells infrastructure as code, so the Azure Resource Manager, to create a container app in my already existing container app environment, and then go ahead and download a container image from my container registry, and then the newest, the latest version. So what happens if this container app already exists? Now there is one small problem with container apps that currently exists if you run the revision in a single mode, and that is that you're currently running revision will go down. Your new container image is downloaded before it starts. So you have some small downtime there. And I know that the team is currently working hard on it to get rid of that downtime. So be advised, if you run this revision mode in single, then you have some downtimes if you deploy in this way. If you have if you use the multiple strategy, you can already deploy the new revision next to your currently active revision, and then transfer the traffic from one revision to the other, and that will reduce the downtime. So one important thing is that here in this template you see this container section, and this container section contains a resources, and this is the resources that you actually use to run your container, and it consists of a certain amount of CPU and a certain amount of memory, and this is what you pay for. So if you want to have a heavier if you want to host your container on a heavier resources environment, so more CPU, more memory, you obviously pay more. Now, the advantage of a container app environment is this scaling part. You can scale your environment and each and every container all the way down to 0. And if you have 0 containers running, then you pay 0. But you have to keep in mind, for especially with HTTP with containers that accept HTTP traffic is that you have some startup time. So if you have a service that runs that accepts HTTP traffic and is scaled back all the way to 0, and a request comes in, then it takes up to 10 seconds for the container to start up and process your request. So sometimes it's not that smart to scale back all the way to 0. On the other hand, if you have background processes that handle messages on a queue, for example, that people don't necessarily want a request for at that time, then for those services, it's a good idea to scale back all the way to 0, because if they're not doing anything, you don't pay anything. And as soon as a message comes in, then SCADA will make sure that the service is alive. It will process the message and scale back again when nothing is to be done. So with that, I want to conclude my presentation, and again with this link. This link, well, you can also scan the QR code, by the way. This link will bring you to my GitHub repository with a search query that will bring you to all the repositories that I use to create this entire solution. And then again, thank you for your time. Thank you for listening. Thank you for joining the Virtual Azure Community Day. And make sure to reach out to the organizers and thank them, because they put in a lot of effort to get this conference done for you. So yeah, let's go.
Thank you so much. That was a delightful presentation, and it brought so much more clarity into is this another black box solution? How flexible is it? Can I use it in production? I think that we can see already that there is a very good use case for this. But how to determine if you're starting now a new project? What are you gonna do? Are you gonna use AKS, or are you gonna use container apps? What would you advise?
Well, the story is that if you're already familiar with AKS, then the bridge to AKS is probably not that difficult to take. On the other hand, if you're not really familiar with the container environment, then the Azure Container App Service is the service to go, because it's fairly simple to understand. There's not a lot of complicated wheels and knobs that you need to twist and tweak to get your environment up and running and to keep it up and running. And both services under the hood run Kubernetes. So if you end up in the situation that you run with Azure Container Apps and you hit the limits of Azure Container Apps and come to the conclusion that you still need the AKS service, then you can, because they still run the same environment under the hood, and you can migrate one environment to the other.
Is there an easy way to do that migration, or is it more manual labor?
At this time, it's manual labor. I asked the question to the team, is this going to be a button that you can, okay, bring me to AKS? The answer was not yet. So I think that's promising, but yeah, I'm not sure if this button is going to be there, but that would be really powerful.
We want that button.
Yeah,
that would be so cool to have a button, like because it kind of makes sense. Your company is growing, your knowledge is growing, you're getting more into the containerization, but at some point, and I think that the talk after this one will dive more into it, but sometimes you just need that extra functionality and the customization of the behaviors of your application infrastructure. So it would be really good if people could like ease into that, but it's already doable with some manual.
With some manual labor and put some effort in it, and you can get it done, because in the end it's containers, and you can grab one container, pull out the plug, bring it somewhere else, plug it in, and it will run.
Is this the is ACI still, Azure Container Instances, still useful?
Yeah, but the problem with Azure Container Instances is the scaling capabilities. So if you end up in a situation that you need to scale out, then you run into problems with ACI. So yeah, it is a thing. it still is a thing, because this one is all the way on the left in the spectrum of the beginning of my session. So it's one of the easiest way to run containers, because you can just throw a container at it, tell it to run the container, and it will run it for you. But it has some limitations.
Awesome. Thank you so much. If you want to learn more about it, scan the QR code, or otherwise we'll put the link in the chat. Thank you so much for being here.
Yeah, it was fun.
In our little studio. It was good having you, and well, hope to see you around.
Yeah, hope so too.
Thank you.
Bye.
And of course, stick around while we make some adjustments to the studio for our next speakers, and we'll be back in a few minutes. Hey, welcome to Virtual Azure Community Day. This is your virtual live Azure event, community event with speakers. We're doing multiple sessions, so around this time, hopefully France has started as well. So if vous talkez français, then you can go. That's not French. No, but if you talk French, then there's a French spoken track now as well, and we're broadcasting live from Denmark. But you're currently watching the track live from the Netherlands in Utrecht in our lovely, lovely studio. And I have two guests here. Somebody from Microsoft and somebody from Solo walked into a bar. I always wanted to say that. It's funny. So last session was more about like making it more obfuscating Kate's even more, adding another abstraction layer with container apps. But you're going to dive a little bit deeper. What if you're using Kubernetes and you want to, well, add extra functionality, you want to expand your application, then you at some point will need sidecars.
You do need a service mesh. That's the whole idea, and that's one of the reasons why I joined Solo.io recently, is because, as I say, I'm on a mission to install a service mesh into every cluster out there. I believe, I think it's very well established that the service mesh is a very convenient add-on for cloud native applications, right? So you kind of you may think you don't need it, or you think it's an overhead, but the advantages it brings and the small overhead, the small price you pay, it justifies the investment in terms of cost and computing power that you need. And today we're going to talk about a way to even reduce this footprint, this cost associated with the service mesh.
So it's more basically talking about leveraging the power of a service mesh, but then in a better way.
Yeah, with less friction and less waste, which is what everybody should try for, right?
Yeah, a lot of people. I don't know about you, but a lot of people I talk to when we talk about this is like, yeah, but it's so much work. It's a hassle. Where we're already happy that we came this far, and now we just need add another layer of complexity, actual adding extra knowledge. So what you're gonna talk about is gonna remove that friction.
Reduce
The friction. Reduce.
Yeah. Everything is worth it costs a price, right? So everything that we do has an impact on complexity and cost. But there's some cost benefit consideration, and I'll make a case that it's probably very worthwhile to invest some time and some CPU cycles into a service mesh.
Yeah. Okay. And also, if you already have a cluster running, Istio service mesh installation is just a couple of commands. Like it's very simple. So the notion of that it is really hard to install is not really the case.
Is that maybe the fear of the unknown?
I think so. Yeah, I definitely think so. Yeah.
So you are gonna show us also a demo. You told me backstage. You told me it was quite experimental.
Yeah. So Istio service mesh, the standard release is very stable and a very good way to install, to have a service mesh running on your Kubernetes cluster. However, the one we are talking about today is the service mesh in the ambient mode, and that one is way less uses way less resources. It's a sidecar-less model, but that is currently an experimental. It's currently an experimental version. So yeah, we just want to show that it works and that you can use it. However, it is for production use, we will recommend to wait a couple of releases until it's a stable version.
Where's the adventure in that?
Yeah.
No, all jokes aside, I'm really looking forward to that, and looking forward to that demo because nothing is cooler than experimental stuff, I think. Yeah. Looking forward to your talk. Good luck.
Okay.
Thank you.
Thank you. Should I start?
Yeah. So again, thank you for watching Virtual Azure Community Day. If you want to share anything on the socials, where are you in the world? Where are you watching? Are you enjoying this show? Do you have opinions on service mesh, experimental stuff? Want to cheer on for the demo? do so using hashtag VACD or leveraging the chat on our website, azureday.community. Take it away, Alessandro.
Thank you. Thank you very much. So we've been invited, thank you very much, because it's our first time and at Virtual Azure Community Day, and I would like to thank everybody for trusting us. Today we're going to talk about service mesh and a special variant of one of the most popular service mesh, which is Istio. So please bear with me. What we're going to show as a disclaimer, of course, these are not exactly production ready stuff. So it's going to take some time to mature. That as everything, once even Kubernetes was a beta, right? So no fear there, and just bear with me and come into the adventure. My name is Alessandro. I run the Dutch Kubernetes meetup. So I've been doing Kubernetes for some time, and I just joined, well, a couple of months ago, a company called solo.io. You can ask me anything about it later. I need to switch screen? Yeah. So clearly. Oh, yeah. Okay. Yeah. No. Wait, let me
Can you do it?
All right, sorry for the misunderstanding. So yes, I'm Alessandro, and I'm joined by Mark. He's also he works at Microsoft. Of course, we started this to talk about these things together a few months ago at the meetup, and somehow we really like these ideas, and we like to talk about it. So if you don't know service mesh is a very popular addition to Kubernetes, of course, but it can also be extended to virtual machines and other non-cloud native workloads. It's an idea been around for quite some time. Among the service mesh, of course, there's not only one, there's many on the market, but there's one that kind of emerges like the leading service mesh in the community and in the markets, in the industry, which is Istio. Istio was born out of Google project, of course, like many other things, like Kubernetes itself. Then, of course, donated to the Cloud Native Computing Foundation. Recently donated to the Cloud Native Computing Foundation. So we are talking about a project that has open governance, is of course open source, is based itself on open source, open governance, and another very popular graduated project in CNCF, which is Envoy. Envoy is one of the most popular proxies out there, one of the most efficient, one of the most adopted. So the foundation is very solid, it's open source, and Istio itself is extremely solid, extremely well received and adopted by many customers in production. So you can look it up. It's now a CNCF project. So recently, of course, like in around September timeframe, this new mode of deploying Istio was born, called ambient mesh, and that's what we're gonna talk about today. So this is not, unfortunately, we don't have that much time to talk in depth about Istio, what is a service mesh. Of course, we'll be happy to have other sessions about it. But in short, a service mesh is an add-on, something that you add to your workload, so you can leverage what service mesh can bring to the table. So the most classic model for deployment of a service mesh is the sidecar model. If you have read the Brendan Barr's book called Design of Distributed System, you may know, or if you already work with Kubernetes, you may know there's this pattern called sidecar. So this is the classic service meshes out there leverage the sidecar model to inject a proxy into every workload. Namely, in Kubernetes, of course, it's every pod gets its own sidecars, because a pod is a construct that can be made of multiple containers. And so Istio leveraged this capability of Kubernetes of having admission controller and a mutating webhook to actually modify your workload definitions, your pods definitions, by adding an extra container to it. It's all nice and well. What can this container do? This container really runs Envoy proxy, so it's just a very low footprint proxy that sits next to your workload, to your application, and hijacks the traffic in and out of your pod. That's done by classically through reprogramming the IP tables in the pod namespace, right? So that's the whole point of this talk, is to show that there are other ways to do it. So once you have every application injected with the proxy, now you are able to do interesting things, right? So all these proxies, of course, are managed and programmed by a control plane. So in Istio, this used to be a plethora of multiple services. So Istio control plane used to be distributed service system, but now it's been consolidated into one binary, also written in Go, like many other things in Kubernetes. So the Istio D is the process running also in your cluster that manages the configuration of the proxies that live next to your application. So what this all brings to you, right? So it brings to you observability. So you can measure, you can collect metrics out of the proxies for every single pod, every single application, collect them and show it and use them to reason and to understand more about your workloads. So Envoy proxy is a very granular collection of metrics, and of course, like get the numbers of requests, the numbers of rejection, all the HTTP codes that comes out of your application, all the requests. That's one big reason to adopt service mesh, is to have a better view inside your application. Another things you can do with having Envoy proxies, having sidecars into every pod, is to enforce security. So security policies. Those can be, for example, policies that dictate which service can talk to which service, over which port and over which path. If it's a HTTP request, you can secure and lock your workloads more granularly than just network policies. So these are something that people tend to confuse together. So of course, like if you don't know network policies, these are also extension to Kubernetes that controls the layer 4. We call it the layer 4 because it's all about the TCP layer. So which IPs can talk to which IP. So it's really at the TCP IP layer. So network policies are very common, probably enabling every cluster you use. You can control which service can talk to each service, but based on their IP properties. Service mesh allows you to build on top of that and go up to the layer 7, where you can actually reason about application networking security, as in you can tell that which application and which service account that application relies upon is able to talk to which other service and over which port and which protocol and which path, for example, for HTTP requests. So observability, security, and of course, like managing of the application is another big reason to adopt service mesh. So this is the classic reason why service mesh is preferable, right? So as we discussed before, surely there is a price to pay. There is more complexity, and we'll talk about how to scale down this complexity. But it's something that I personally like to have into every cluster I manage. I like to know what's going on. I like to know the error rates, and I like to know per workload. I like to be certain that communication between my pods are secure. So one thing that I didn't mention, of course, being able to have a proxy for every pod let you establish mutual TLS between those workloads. So this is another big reason why adopting a service mesh is preferable. It can keep your sleeping at night. It can give you peace of mind. Is that the proxies can establish a two-way secure communication between each other. So no more unencrypted communication between the proxies, but the control plane can manage and inject these certificates in the proxies and make sure that these proxies, every time they talk to each other, the communication is encrypted by this certificate. This is why it's not great, right? So sidecars are great until they're not, right? So they've been serving us for so long time, and for most use cases they're pretty okay, pretty lightweight, right? So and then they don't add too much complexity. But of course, when you scale up and you start to have hundreds and thousands of workloads per cluster, then you can feel that that this becomes a problem. So this is actually what happens, and this is taken from a great blog from Jimmy Song, a very famous picture. So this is actually what happens when this sidecar proxy is injected in your pod and starts to hijack, starts to intercept every connection in and out of your application container. So you can see that there is a bunch of IP tables that needs to be programmed and changed. So this is actually another container that is injected in your pod, which is the init container. So that prepares the IP tables. IP tables are extremely popular mechanism to, well, it used to be, well, the original function was a firewall, right? So intercepting and managing connections to a Linux box, to a Linux machine. Of course, now they expanded also into Windows, and they can do many more things, like make some smart decisions what to do with specific packets. And in this case, the Istio proxy, the sidecar proxy, use them to intercept the traffic and then redirects all the traffic to itself. And only if, after evaluation of this, talking about the application networking policies, then only then forward the traffic to the application. So this is great. It works, just maybe too difficult to understand. I mean, also I struggle understanding this complex IP tables rules. So that's why from the pain of managing all these sidecars, also the actual impact on your wallet. Because imagine, so all of a sudden you enable service mesh in your cluster. You don't need to enable it all of nothing, right? So you can start to onboard your application in service mesh slowly or at your own pace. So because the service mesh usually is enabled per namespace. In this case, when a namespace is tagged with a particular, I think we also, that's what we do in the demo. When we tag a namespace with a specific annotation, the namespace starts to become, the workloads in that namespace will have the injection enabled. So, but even then, you can imagine now you have a workload made of, for example, 100 pods, which means 100 containers, and then you enable service mesh, you jump up to 200 containers because every single one needs a sidecar. So all of a sudden you double the amount of containers, double the amount of complexity. Those containers, of course, the sidecar, the Envoy proxy, they do consume some resources, so you end up with like oversizing your clusters because you just want to have these nice features of service mesh. Can something be done about it? Let's see. Is the whole point of Istio is to reduce cost, simplify your operation, and of course, like, also improving performance. And we'll dive deep into this in a moment. So, what is service mesh? What is ambient mesh? On the left, you see the classic model with a sidecar per pod. Now imagine you can combine these sidecars into one proxy and run it per node. That's all you need, right? So that's all what is necessary. So all these pods living on the same node, they can actually have their communication, their traffic intercepted by one proxy, and that proxy will serve multiple applications. So this is something that kind of strike the minds of the people behind ambient mesh, behind this new mode of operation, was to reduce the complexity by aggregating the proxies into one. So instead of running multiple proxies, running one per node that can serve multiple workloads. Only, of course, the workloads tagged and that needs the proxy. So also, as I explained before, the proxies per node, they serve both the function of layer 4 proxies and layer 7 proxies, right? So they do perform two functions, right? So forwarding packets, of course, at the TCP/IP level, but also making decision about the application layer and what application can do and what cannot. So imagine if we can split these two roles into the node proxy, what we call the proxy, the data plane, and a new proxy, we call it the waypoint proxy, dedicated to perform layer 7 decision, layer 7, enforcing layer 7 policies. So this is also a way to reduce complexity, because you can split the roles and the responsibilities into different proxies, all based on Envoy, of course, but just different, very different in their roles. So this is how it works, right? So we take all these proxies, so we don't inject anything into the pods. Makes it much easier. First of all, you have to consider that injecting the act of manipulating a pod definition and adding a container will force that pod to be restarted, because there is no hot injection of containers in a pod, at least not possible for now. So those pods needs to be restarted, which will incur some downtime, make some people uncomfortable to restart the pod. So it's something that we look forward not to have to do, right? So instead, you deploy a ambient mesh, so Istio in ambient mode. Then all of a sudden, there's a daemon set that deploys a layer 4 proxy based on Istio, on Envoy, on every node. And then that proxy will get the traffic of the tagged workload into itself, and will communicate with the other layer 4 proxies on every node, making a mesh of communication. Now, if a workload is also a layer 7 associated with it, an application policy associated with it, then, and only in that case, that traffic will go through the L7 proxy. We call it the waypoint proxy. So if you don't need layer 7 forwarding, then you're not going to use it. You just a pure communication encapsulation of your traffic between the layer 4 proxy between the nodes. So that's why you save resources, because you only use it when you need it, and you save complexity because you drastically reduce the number of containers or processes running on your nodes. So not only you can, of course, still obtain mutual TLS between the applications. So sure, it's not done between sidecar proxies, but it's done at the Z tunnel, which we call the layer 4 proxy sitting on every node. So those Z tunnel, which are just pods, right? So they are just daemon sets pods running on every node. They will establish mutual TLS between them. All the certificates are still managed by the Istio control plane. So these are all, you can normally, I mean, at least for development in our demo, of course, we rely on the internal certificate authority, but you can choose to have an external certificate authority, use Cert Manager, or rely on Active Directory or HashiCorp Vault to create those certificates authority and those certificates that will be injected in your zTunnel or your corporate CA PKI infrastructure. So these tunnels between the zTunnel will convey the communication, the traffic between the workloads running on each node. While the layer 7 is performed by a separate proxy that again sits on the nodes and needs it, sits on the node that actually run the workload that needs to be secured via layer 7 processing. And while when you don't need to, nothing's gonna pass through that waypoint proxy that we call. So this is how we visualize it, of course. So this Istio still configuring the Z tunnels and configuring the certificates, making sure that things are running smoothly, and there is a of course, like the Z tunnel is aware of which workloads they need to be forwarded through the proxies, and that's how we work. So, and we'll talk about what is this tunnel, how does it look like. If in the case that some of your workloads are actually in need of a policy, so application networking policies, or with layer 7 policy, then, and only in that case, the Z tunnel living into each node will, instead of directly sending the traffic to the Z tunnel on the other side, they will use the waypoint proxy to perform those policies, to apply those policies. So this all done very transparently. The waypoint proxy is actually makes its decision based on the SPIFFE identity of your workload. What is the SPIFFE identity? So every workload in Kubernetes, of course, has a service account associated with it. That service account represents the workload identity. So what that workload can perform, and the identity of their workload is really their service account. So based on that, based on the service account of your workloads, the waypoint proxy will make a decision. So you can limit what a service account, and conversely the workload associated with it, can do by just creating these rules and this waypoint proxy. Internally is another CNCF project called SPIFFE. It's topic for another talk, of course, but it's all internally a representation of those identities. So this is how internally works. So of course, like, it would be not very efficient, or not a lot of improvement if every zTunnel would need to open a new connection for every connection that those workloads needs to establish. So that's why there's this. It leverages this mechanism, which is really part of the HTTP protocol. It's the HTTP base overlay network encapsulation protocol based on HTTP connect. It's a verb in the HTTP protocol. So the tunnels establish one connection, and they reuse the connection to send traffic over. That connection is of course like secure, but kind of the traffic is kind of multiplex inside the connection. So that means that there is no need to reopen new connections. There's no need to waste cycles of computation or network connections by reopening for every new connection that your workloads want to establish. So there's one connection between between all the tunnels, and your communication goes through it. You don't need to. You don't see all of this when you're running. Of course, it is all internal working of the Z tunnels. But it's very interesting to understand it. It's very at least I'm an old school network guy, so I like to understand how my traffic goes around in my clusters. So if you want to know more, and this is where of course my affiliation comes in, because we like more people to understand these ideas, right? So the more people know this, the better, because it's the future. We wanted to talk about what is gonna happen. 2023 is probably gonna be the year you will see a lot of this concept, a lot of these new ways of thinking about service mesh maturing and becoming more and more popular. We have an academy, so there's free trainings out there. We have an ambient mesh workshop where you can actually get your hands dirty and try it out, how ambient works in real life, or at least in some test environment that we spin up for you whenever you need. So with that, I will leave the floor to my team friend, Mark.
Yeah.
So thank you.
Hi everybody. So I will do the demo for today, and yeah, what we want to show you today is actually how Istio works in ambient mode. So let's start. A few pointers. The demo. Wait, let me quickly set it up. So the demo that we are going to do today, you can do yourself. I will show quickly where you can do that. We will leave links eventually. So the demo that we're going to do today can be found at codingkitties/Istio ambient service mesh tutorial. So yeah, if you want, if probably something goes wrong today with the demo, and then you can follow it in your own on your own pace, and then hopefully it will work. So that's a nice thing. So let's quickly set up everything for the demo. Ooh, most. Yes. Okay. So I've installed on my machine. This is an Ubuntu machine, and basically I have here a kind Kubernetes cluster running with Istio installed in ambient mode. So to give an idea of the Kubernetes cluster that we have running, we have here the Kubernetes cluster with all our pods. So basically, here's a demo application is running on this Kubernetes cluster, and this Kubernetes cluster consists out of 3 nodes. So here right away comes a very important concept. Because we are running Istio in ambient mode, we only have a mesh, so an Istio service mesh per node and not per pod. So previously, you would have per pod, you would have for every pod a mesh running. So with all your network processors and such, all your add-ons. But now, because we have now we have Istio in ambient mode, only a single mesh is deployed per node. So as we can see, we have here 3 nodes, so we should have then approximately 3 Istio nodes running, meshes running. Sorry. So we can validate this by checking our resource of Istio. And as we yeah, so as we see here, we see that we have 3 nodes running. So 3 Istio nodes. So basically our meshes corresponding to our nodes of our cluster. So that is already a huge improvement compared to the previous version of Istio. And yeah, you can already suggest that this will increase performance of your Kubernetes cluster, will better resource handling, and just overall a better experience. Well, this demo we want to show that Istio in ambient mode is similar to Istio, Istio as we all used to it. So we can do, for example, we are now going to show we can do network processing with level 4 and level 7. And we can, for example, also do some common use cases such as installing an add-on in our service mesh. So let's first show that we can do some network layer 4 processing. So one very important part of that is, for example, mutual TOS. So to prove that that is running in Istio ambient mode, we can we can load up the certificate. Let me quickly get that for you. Keep in mind, I'm doing this demo live, so it can fail. It is Istio ambient is in very experimental version, so it can fail, but we will try. Let me get the detail. So let's check the certificate that is running on the ctunnel. So here we already see. So as we suggested, like Istio ambient Istio service mesh in ambient mode as mutual to TOS enabled by default. As we can see here, we can load up the certificate, and we are now sure that the service-to-service communication is done via mutual TOS. We can also do layer 7 processing, so that is also really cool. So let's look how we so layer 7 processing is done via a waypoint. And to show that the waypoint is running in Istio in ambient mode, we can do this. And here we see currently our waypoint running. So when we, for example, now call from one service to the other service, we do a request, we can know that it goes through a waypoint, and we can do the level 7 network processes, network policies. So that's really cool. And let's now do the last part of the demo. So for example, what a lot of people do with Istio Service Mesh is install add-ons. One very famous, very popular one that people a lot use is Kiali, the Kiali dashboard. Basically, Kiali dashboards allows you to track the routing of the requests through your cluster. So for example, if one service calls the other service and that service calls the other calls another service, then we can track which route the request will go. So that's really cool. It's more like an observability dashboard. Well, it's really easy to install, but I already installed the add-on for the demo purpose. But let me quickly show it. So as we see here, we see here that we have already the Kiali service installed. Installation of this add-on is the same way as you do it with normal Istio service mesh. And to get access to the dashboard of Kiali, we can quickly do. We can quickly go this. here we have our Kiali console that basically monitors our cluster. So this is Kiali dashboard running in Istio and ambient mode, and then we have our cluster here. And let's select our namespace. So here we see our nodes running. Basically, our nodes and our pods running into it. And if we now, for example, do a request from one pod to another pod, we should see the request route, that, well, the request trace of that. So here we went from, we used the sleep pod, and we called the product page pod. And if everything is correct, we should see. Oh, I think I have to. Yeah, I think it's not showing up, so that's a bummer. Okay, well, this this basically, as we pointed out, that yeah, Istio in ambient mode, Istio Service Mesh in ambient mode is quite experimental. It somehow does not show the request path, but it should be. So as we pointed out in the beginning, if you try to do this demo yourself on the GitHub page that we showed, hopefully it will work for you. Today not, but yeah, that's the thing doing with a live demo. So yeah, that was our presentation, and I hope everybody learned a lot from it.
Thank you so much. And there were plenty of warnings of this being experimental. So no hard feelings. It was really, really cool. And yeah, it was so nice to see this. Well, hello.
Hello, back.
Welcome back. So people can get started using the GitHub page that you shared.
Yeah.
So from a scale of 1 to 10, how difficult is it to actually get started? It looked quite simple, but obviously you've prepared it quite well. So
Yeah. Shall I first answer? Standard Istio Service Mesh is really easy to install. Like for example, on the documentation pages, you can find everything. It's just a couple of simple commands, and you have Service Mesh running on your cluster. In ambient mode, it's just a bit more difficult because it's experimental. Things will change. They also warn a lot. They make a lot of warnings that, hey, this is experimental. This probably does not work. We have these systems that don't work. So yeah, I would not recommend to run any production cluster in Istio Service Mesh in ambient mode, but Istio, the standard release, is amazing.
but it sounds kind of like this is the right moment to start learning.
It's always the right moment to start learning.
Exactly. We can't stress that enough.
Definitely, it's
Yeah.
it's a good moment to start learning all things cloud native, and Service Mesh is we believe is going to be even more popular in this year.
Okay, I've turned on my microphone. Okay, so that was not disruptive at all. Thank you. Now I lost my thought there for a moment. I was going somewhere with this question.
Learning.
About learning, yes.
Okay.
Oh yeah. So now is obviously a good time to learn, which is of course, always the case. So what knowledge would one need to gain before getting started to this point? Because like what a lot of people do is like walk into the candy store. Oh, it's cloud native. There's so much shiny tools.
This reminds me of we were discussing with a colleague of mine, Marino. What we noticed is that a lot of people enter DevOps, enter cloud native without really the good foundation of networking. I've been learning things for a long time. So first thing I learned was like how a TCP packet is made of, and what retransmission means, and all the very basic networking foundation. And we feel like the new generation of DevOps don't have this basis. So
No.
I would suggest you go really slow and learn all the intricacies of the Linux networking stack, what the network namespace means. That, of course, it's probably things that you will not need in your daily job, but it gives you really like the feeling what is really going on under the hood. So you can install these things, and you can install Istio, Ambient or not, and it works. But you get all these Envoy proxies. You can actually go in and see what they do with the packets, right? What they do with the network connection. That's for me is like an all-time geek. I really love to have this this way to look inside what's going on. But yeah, in the normal day-to-day operation, you don't need to see. But it's good to it's reassuring to have this visibility into the kernel. We haven't talked about the BPF today. Of course, there's a whole new thing on.
You can spend an hour on that, probably.
You can spend more than an hour. We also have courses and workshops about the BPF. It's becoming the de facto standard to mangle and to manage connections in Kubernetes, outside, in general, wherever our Linux kernel is involved, and by the way, also the Windows kernel, also implementing eBPF. So everywhere there is a connection, there is a network connection, you may soon enough find a eBPF program that can do something about the connection, like collecting metrics, doing security. So this is also, we haven't talked about it, but this is also part of the future of the service mesh and in general, like networking in Kubernetes.
Okay, so it's good to hear that where it's going, but it also reminds us all, hopefully, to go back to the basics and actually learn what is networking, learn what is networking under Linux or under Windows, and really understand more what is actually that technology.
Yeah.
Because we're all moving like to the right-click deploy thing.
Yeah.
It was mentioned a few times today. That's not the real world. Running an application does not only depend on your compute.
Yeah. And for me, like I'm quite new compared to Alessandro. So for me, if I would deploy my applications on the Kubernetes cluster, I would just deploy them and would not really think about, hey, how does the service-to-service communication, is that secure? Is there a TLS connection? Nothing like that. And basically, when I started with Istio Service Mesh, of course you read about it, and then you learn really quickly that just installing it already allows you to have pod-to-pod connection in a secure way. And it's just a simple command. It's just installation, and then you already have that out of the box. So for me, that was a really eye opener. Like, hey, there's not really that much of a hurdle to install this on your cluster, and it improves your structure so much. I think yeah. And then from that point on, you go like, oh hey, let's install some add-ons or do some level 7 network processing policies. Yeah, it's all pretty cool. So yeah, that's how I learn. But,
that's amazing to hear, because that is a realistic scenario, of course, and you need to start somewhere.
Yeah. So I think yeah, for me, as Alessandro was telling, like every Kubernetes cluster needs to have a service mesh. Me like working daily with Kubernetes cluster and making new ones on the fly. Like there's no need to not include a service mesh. Like it's really easy. So yeah, I think that's great.
Cool, but not the experimental one. Don't,
no.
don't,
as
don't.
We saw in the demo.
Don't do the bleeding edge stuff.
As we saw in the demo.
But
like,
learn. Start to learn it, because it's worth it. Okay, thank you so much for being here, for sharing this. And yeah, if you're watching this, do try out the workshop yourself. Take all the time you need and learn networking. and learn networking.
Thank you.
And learn networking. Okay, thank you so much, and yeah, hope to see you again.
Thank you for having
Yeah,
us.
thank you very
Bye,
much.
folks.
Bye.
We're gonna go for a short break before our next speaker is here already. We're gonna move some stuff.
Hey everyone, welcome back to Virtual Azure Community Day. Small switcheroo of hosts. Hi, I'm Mark Duiker. Suzanne has now a well-deserved break. We still have like 5 sessions for you. That's quite a lot. First, one longer session, and then 4 shorter sessions. So we're gonna start about with Erwin. Hi, welcome.
Thanks, Mark. Happy to be here.
Great. So, what have you been up to lately?
Well, in the beginning of the new year, I've started to do a few of these sessions again.
Mm-hmm.
So this time remote, and there's also another session coming up in real life. So that's always nice after the whole Corona period, in which we had to do it all virtual.
Yeah.
So I'm really glad that that's all starting up again. Yeah.
That's great. Yeah. So how's work at Experience? Because we were like very briefly colleagues at Experience, but like maybe for a couple of days only, and,
I mean,
and then I left.
When I came in, you left like 2 days ago.
Bad timing.
I thought it was me, but
No, definitely not.
Yeah, that's all fine. Doing nice assignments with our clients, doing all cool stuff on the Azure cloud. So yeah, it's all perfect there.
I'll give them my regards next time you see them.
I will.
All right. So I would say, get ready for your next session, all about networking. It's very nicely ties in with all kinds of other sessions we have just seen.
Yeah.
And also personally for me, I'm going to learn a lot because it's really one of my weaker points, networking and security. So I think I'm going to learn a lot.
All right,
So
cool.
Feel
Sounds
free
good.
to take the stage.
All right, thank you.
All right, and yeah, while Aaron is preparing his slides and the session, I mean, will there be some demos as well?
Yeah, lots of demos.
Oh,
yeah,
excellent.
yeah.
Okay,
I'll be switching all the time.
Oh, excellent. Yeah, okay. I love some live demos, although we've also seen that these things can go wrong when you're doing them live. But yeah, I'll be praying to the demo gods that all goes well. All right, I think we're almost ready to go. Good luck.
All right, thank you, Mark. And once again, welcome. Thanks for joining me in this session. And we're going to talk for the next 15 minutes or so about networking on the Azure platform. And mostly about networking on the platform as a services on Azure. How do you use networking to protect Key Vault, SQL databases, storage accounts, and all those kind of things? So before we dive into the details of it, my name is Edwin Staal. Like Mark mentioned, I work at a company called Xspirit in Hilversum, which is not too far from the studio today. But I actually live in a town called Assen, which is up in the north of the Netherlands. And I'm an Azure architect and a DevOps consultant for Xspirit, helping our clients with all things in the Azure cloud, amongst networking. So in the Corona pandemic time, when we couldn't do public speaking, etc., I decided to write a book with also Eduard Kelhorst, who did a session this morning, and Henry Bain. We decided to write a book on Azure infrastructure, and especially using Azure infrastructure with Bicep. If you want to know more about that subject, then this book might be for you. All right, let's dive into the subject of networking. The first time that I worked for a client and actually had to do something with networking was when I worked for a company that was building a SaaS product. They were building a business-to-business e-commerce platform, and they wanted to allow their customers to use their credit cards to do payments. And when you want to support credit card payments, then you also need to comply with one of these standards out there, which is called the Payment Card Industry Data Security Standard. And this nice little graph that you see here on the screen is actually a diagram that I grabbed from the documentation by Microsoft, in which they explain how to actually implement a design, a network architecture design that will comply with the particular standard, and they actually have blueprints and whatever, so you can easily deploy that and see how that goes. And what we see in here is that there's multiple layers of defense in place between the actual user coming from the internet and your crown jewels on the right, being your storage or your SQL or maybe your secrets in a Key Vault. And there's all sorts of layers in place in terms of networking to ensure protection between the public internet and the stuff in the backend. And in the session today, we're going to see a lot of those services in Azure in place and being used to build something similar like this, but then in a bit of an easier smaller example. So the demo I'm going to build up today uses the architecture that we see here. So what we're going to do is that we're going to use a SQL database, which obviously stores a bit of data. And that's being read by an API, which runs on Azure, on an Azure App Service. And what we want to do is that we want to ensure that just that Azure App Service, the API, can actually access that SQL database, but no one else can, at least not from the public internet. We want to shut down the public access to the database. And then we will host another application, our front-end application, which also runs on an Azure Web App. And we want to ensure that that front-end application is actually the only application that is allowed to connect into the API. What's important to note here is that the application, the front-end application running there on the app service, is a server-side application. Shutting your API down from the internet obviously doesn't work if you have a front-end application running in the browser of your users. So this is a front-end application running inside of an Azure App Service. And we're going to see how we can ensure that just that app service can actually connect into our API. And we're going to use different services to get that to work. But you might be wondering now, if you shut down your API from the public internet and you also shut down your database from the public internet, then how do I still get into that as an engineer to do deployments, but also do migrations and updates in the database? So there's various ways to still be able to get into those resources over private networking, and we're going to talk about a few of those solutions today as well, which will involve, for example, a VPN connection, DNS, etc. So this is the whole flow that hopefully will work at the end of this session. All right, networking obviously all starts with a network. So the first thing that we need to do is actually create a network in the public cloud. And in Azure, that's called a virtual network. And a virtual network allows you to have your resources in the cloud talk to each other over a private connection, using a private IP address. So what you can do, you can create a private network. And within such a private network, a VNet, you can create subnets. So we have a virtual network, which we can divide into smaller groups, which we then call subnets. And when you create a network and when you create these subnets, you need to think about the IP addresses that you want to use within those networks. And as we see on the screen here, there's a few IP ranges that you get to pick from when you decide on which IP ranges you want to use. Those are all the private IP address ranges that we agreed upon to only use for private use and not on the public internet. So depending on your need and basically depending on the amount of IP addresses that you need, you can pick either one of these three ranges and then use those as your IP range. And when you start setting up your network, you need to think about how many IP addresses do I need now, but also in the future, so you can create your network having the right amount of IP addresses. Not too much, not too little. You can change the amount of IP addresses in a virtual network, but it becomes a lot harder when it's actually in use and IP addresses are in use, etc. And it becomes a lot harder to move around and make things grow. So you need to think about the number of addresses you need upfront and do proper design. What's important to note also here is that when you create a subnet in Azure, then Azure needs from that subnet at least 5 IP addresses for its own use. So it needs an IP address to do some DNS assignments, etc. It needs a broadcast address, etc. So that means that if you create a subnet, which would normally have 64 IP addresses, you now end up with 59 because Azure needs 5 of its own. So you also need to take that into account when you design for your network space. Another thing that you can do with networks is actually couple them together. So imagine you have 2 networks. Then you could actually create a connection between those 2 networks, which we call a VNet peering. And that would allow you to connect into resources from one network into the other. So that might be useful, for example, if you have multiple teams, they can then own their own network. But if they still need to connect into each other over a private level, then you could create a VNet peering between those 2 networks, which would allow those 2 teams to connect to each other over a private backbone. There's two types of VNet peering in the Azure cloud. There's the virtual one, the virtual network peering, and there's also the global virtual network peering, which, as the name implies, would be used when you do global stuff across regions, where the normal peering is used if you just stay within the same region. To do global VNet peering, there's a cost aspect involved, obviously. You need to cross regions. All right, so let's move into the first part of this demo, which is that we actually need to create a virtual network to start with. Let's head over to the Azure cloud, and not nu.nl. And let's see what a virtual network in the Azure cloud actually looks like. So I've already been upfront creating a few resources, which we can use during this demo. So if I scroll down, then you see already a SQL server. There's already things like application insights, there's the app service plans, etc. And last but not least, there's also two virtual networks that are already created. So let's open up one, and let's see what we can actually configure on a VNet and what it actually looks like. So probably the most important thing on a network is its address space, which defines which IP addresses you actually use within that particular network. And here you can see that I picked this particular range, which gives me 256 IP addresses. Then, within that global range on the virtual network, I can create these smaller groups called subnets, of which you see two in this particular example. And those also have their own IP range, which obviously has to be smaller than the range of the whole VNet, because they have to fit within the global VNet range. So you can see that these two VNets actually have less IP addresses available, obviously, than the 256 that we saw before. All right, so there's a lot of other stuff that we can actually configure on a VNet. Most of it goes beyond the scope of the session today. One thing that I do want to touch upon is DNS. The service, obviously, that does the resolving of IP addresses by domain names. And by default, you can just use the one that Azure provides you. But later on in this session, we will see that in some cases you actually need to configure your own for good reasons. But we'll get to that in a bit. All right, before I get back to my slides to introduce the next step, let's very quickly have a look at the applications that I've built. They both are very simple, just for the purpose of this demo. This is the UI that we will use. A .NET Core MVC application running on an app service. And there's obviously also an API that just returns a bunch of data in a JSON format. Nothing special, nothing fancy. All right. So the first thing that we want to do here, we're going to start, if we look at this demo architecture, we're going to start with the database, lock it down, and then move our way to the left. And move and go on from there. So the first thing that we're going to do is lock down that database to ensure that no one over the public internet can access it, and only our API will be able to get into the database. And we are going to do that by use of a private endpoint. And a private endpoint is a service in the Azure cloud that allows you to reach a PaaS offering, a platform as a service offering in the cloud, over a private IP address. So it means that I can now go to my database, to my key vault, to my storage account over a private IP instead of over the public internet. And for most of the resources in Azure that you can use a private endpoint with, you can choose if you want to only enable access over the private endpoint, or that users can also simultaneously still connect it over the public internet. That's a choice that you can make. The benefit of a private endpoint is that the traffic obviously stays within the Microsoft network. So it's secure, it's faster, and it's more reliable. Another benefit is that private endpoints can also perfectly be used over a peered network, so from another network, and they also perfectly work from on-premise environment. So you could have a database in the cloud that you reach from on-premise over your VPN connection, for example. That all perfectly works and is often used in migration scenario. So the private endpoint can be used on a lot of services in Azure, as we can see in this list. All right. So we're gonna now focus on this particular part of the demo, let's add a private endpoint to that SQL database to make sure that it's locked down from the internet. We're gonna go to MySQL server, and we're gonna go to the networking blade of that SQL server. And do note that I'm going to the SQL server and not to a particular database. So it means that any database that we host on this particular server can be accessed over this particular private endpoint. So I obviously have to give that thing a name. And we're gonna say that we wanna have this thing in Western Europe, because that's where I run all the stuff. We hit next. And then you get to pick the target sub-resource for your private endpoint. Where is your private endpoint gonna point to? And since I came from the SQL Server blade, it's obviously gonna be SQL Server. Then it will ask me which virtual network I want to use, in which network and which subnet should this private endpoint get its IP address. So I'm gonna use the API network, and I'm gonna put it in the subnet, which is called default. Then we can continue and go to DNS. And they will now ask me if I want to integrate with what we call Azure Private DNS, a private DNS zone. And you can imagine that now that I lock down this database from the internet, I also cannot use any public DNS anymore to access this particular server. But you still want to be able to use DNS and not connect over a IP address, right? IP addresses might change, and you don't want it. So it asks me if I want to integrate with a private DNS zone, so I can actually still use DNS while using private addresses. And I obviously want that. All right, let's hit next, and let's hit create. All right, so this deployment might take a while. So we're gonna come back to this in a bit to see what was actually the result here. But this is actually the first step that you need to take if you want to lock down your SQL Server. The second one is to go back to the networking blade of the SQL Server, and then on the public access page of it, say that you want to disable the public network access. Because by doing that, we also disable this particular checkbox down here at the screen. And this checkbox is what normally allows your app service to just connect into your SQL database, because you've just allowed all resources in all Azure environments, not just your subscriptions, but all Azure resources. And we obviously no longer want that. So we're gonna hit disable here, and we hit save. And that's right in time, because also the other deployment was done, apparently. So my private endpoint was created, so I can actually go into the private endpoint. And one of the interesting things here is that I can also go into the DNS configuration for that private endpoint, and I can now see that there is a DNS name actually pointing to my private IP address. And that's important, because then that means that if you switch from using the public connection to a private connection on a SQL database or on a storage account for that matter, or on a Key Vault, you don't actually have to change any connection. Your application, your web application, will just continue to run, because it can still use your default connection string like you were used to. You don't have to change that. You can just use the original one that you were used to. All right. Well, with that being in place, if I now go back to my API and I refresh that, it might sometimes take a while. I might need to come back to here later on. But this should actually now, in a bit, give me an error telling me that I'm no longer allowed to get into the database over the public connection. But like I said, it might take a while for the firewall changes to kick in. So let's go back here in a bit. Because what we've done now is ensure that our database is locked down from the public internet. So the next thing that we want to do is ensure that the app service that we use, our API, is still able to connect into the database. And we're going to use a technique called the app service VNet integration to do that. And with the app service VNet integration, what you basically do is you give a subnet to your app service, and your app service will then run from in that subnet. And all its outgoing traffic will then flow through that subnet into any resource you try to connect into. That's an important distinction to make. It's only for outgoing traffic, only for the type of traffic that we try to use today here. There's two flavors of VNet integration. There's again a regional one, just like we saw with the VNet peering, and there's a global one, which allows you to connect into subnets and regions, subnets in other regions than the one your app service actually runs into. So the last benefit that you actually get from putting your app service in a subnet is that subnets can have something we call a network security group, which is basically a list of allow or deny list of traffic you want to allow in or out of that subnet. And since my traffic now goes through my subnet, which can have this allow or deny list, I can also deny a lot of traffic going to the public internet, for example, that I no longer want to allow out of my application to prevent data being exfiltrated onto the public internet by a faulty package, for example. All right, let's see what that looks like in the Azure portal if you want to enable that on the app service. Let's go back to the API, to the app service of the API. If I go to the networking blade of that, then we will see all sorts of features here on the Azure app service, and today we will see a few of them. The one that we use now is called the VNet integration. So let's go in there, and then we can say add VNet, and I get to pick a network that I wanna use, and I get to pick a subnet. And now there's something interesting going on here. You see that my VNet actually has two subnets. It has the default one, and it has the app service subnet. But you already see that I'm no longer allowed to use the default network, which we just used 5 minutes ago for the private endpoint of the SQL database. And that is because the Azure App Service wants a VNet for its own, because what actually happens is that you delegate this particular subnet to the Azure App Service. So you give it to the Azure App Service, and the Azure App Service is then the only thing that can actually run in that particular VNet. So when you design your network, you also need to think of these scenarios. You need to create a separate subnet for an app service because it simply needs one. And there's different services in Azure that also have this sort of limitation that they do require a subnet of their own. So you need to think of those scenarios up front as well. All right, let's pick the app service, and let's add it to the VNet. Let's also see quickly in between if this actually gives an error. Might be that quick. That was too late already. All right, let's see if this actually worked by going into the console of the Azure App Service, run a particular query, and see if the address that I get back from this particular command actually is the private address instead of the public one. And it is not. This also, again, might take a little bit of time or actually get stuck. Let's do it again. It sometimes takes a bit of time before these networking changes kick in and actually do come into effect. No, still the public one. All right. We are going to move on to the next section of the demo. And we'll do this again when we get back into the Azure portal to see if it then actually does work. All right. So the next thing that we want to do is move on in our architecture and ensure that the UI that we have, the front-end application, is the only application that's allowed to access our API. I could have used, again, a private endpoint. Put that front-end application of us in a network and use a private endpoint towards it, towards the API, and use that for its communication. But there's also another service in Azure that we can use in these type of scenarios, and that's called a service endpoint. So a service endpoint basically provides a secure and direct connection to a service in Azure. So in the example that we see here in the image, on the left we have a virtual machine which runs in a VNet, or in a subnet in a VNet, I should say. And it tries to connect into an Azure SQL data warehouse. And it doesn't do that over the public internet. No, it doesn't do that over a service endpoint. And what's important to note here is that the SQL data warehouse itself isn't in a network. It's not in the same network as the virtual machine is. It's now using the service endpoint to connect into that SQL database warehouse. And that works because on the subnet in which that VM lives, we have said that we want to use the service endpoint towards that SQL data warehouse. And what then actually happens under the hood is that in the virtual machine now knows of a better, more optimal route into the SQL data warehouse instead of going over the public internet. So that's a different way to connect into services in Azure. And then the benefit of using a service endpoint, apart from a more optimal connection, a more optimal route, and staying within the Microsoft backbone, is now that the service I'm trying to connect into, I can restrict access to. So on the SQL data warehouse, I can now say, I only want to allow traffic from that particular subnet to be allowed. Although that SQL data warehouse isn't in that same network or isn't in a network at all, because the traffic is coming over a private endpoint into that SQL data warehouse, I can limit traffic just to that particular subnet. And that's exactly what we need in the particular in our scenario today. So we're going to see that in a bit. So service endpoints can be used on quite a few services in Azure as well. The list isn't as large as for the private endpoint, but it's still quite a lot of services that you can connect into in the cloud over a service endpoint. All right, so let's see if we can now fix the first part, and that is ensuring that the traffic from my app service, from my front end, actually goes over a service endpoint into my API. All right, we do that by going to our UI, and again we need to put that UI into a VNet. We're going to use VNet integration again, which I've already done, because it sometimes takes a while to come into effect, as we've seen on the API. So I've already done this one up front. If we click on that, then we get a bit of details on the network that I've used. It's a different network than the API. It's also a different subnet. And the enabling of the service endpoint is something you actually do on a subnet, which is right down here. And as you can see, I've already enabled that for Microsoft.web, which is the app services in Azure. And as you can see, there's quite a list of things that I can also use service endpoints to connect into these type of services. So what this will do, under the hood, the app service now knows of a better, more optimal route into the Azure app services instead of going over the public internet. And the enablement of a service endpoint can take up to 15 minutes. That's also why I did it up front instead of here live, because that would just not have worked. It might take a while to kick into effect. All right, so that is then just half of the solution. We've now ensured that the front-end application uses a service endpoint to connect into my API. But my API still allows access from everywhere around the globe. So let's fix that part. And on an app service, they've called that access restrictions. And access restrictions are basically just a list, a priority ordered allow deny list that controls the network access to your application. So you can say that you want to allow access from a particular IP address, or want to allow access from a particular virtual network, which is what we're going to use today. Or you can actually also use what we call a service tag. And a service tag in Azure is actually a list, a combination of IP addresses being used by a service in Azure. So you could say, I want to allow all Azure App Services to get into my application using a service tag, for example. But we obviously today want to just allow our front-end application to be able to get in. Let's go back into the portal. Let's go back to my API. Let's again go to the networking blade. And we now need this feature on top here, which is called the access restrictions. And if we scroll down a bit, then this is the place where we can add these allow deny rules. So let's call it UI. I need to give that a priority. And this is where I get to pick the type of traffic that I want to block or allow. And this time I want to use a virtual network. So again, I need to select the network. I'm going to select UI because I want to allow traffic from it. And it already selected the app service subnet in which my front-end application lives. I can be a bit more specific in terms of HTTP headers and filtering, etc. That the application should send along, but today we're not going to do that. So I'm going to add this particular network rule, and I'm going to hit save. And it's going to warn me for the fact that if I do this, it's also then directly going to block public access to my application. And what we'll see in a bit is that now that I added my custom rule, the service itself changed its default rule into a deny. So only traffic coming from this particular subnet is now allowed, the rest is being blocked. So if I now go into here, you now see a forbidden, because I'm no longer allowed to go in. If I try to refresh my UI, then this one should actually still work, although it does take a bit of time. Which also might be because, again, kicking in networking rules takes a while. All right, while that's spinning, let me explain another thing here. You might have noticed that I've now changed this particular rule on the main side of my Azure App Service, which is the thing that your users actually access when they go to your app service. But an Azure App Service also has an advanced tool side. It's another URL that you can log into and look behind the scenes of your Azure App Service. See which files are stored, go through a bit of logs, use PowerShell to run a few commands, etc. So there's a service behind it that you can go into to do a bit of debugging, etc. And as you can see, that site also has its own set of rules. So you can also block the admin panel to say you only want to allow traffic to the admin panel coming from your Office IP address, for example. Or if you use VPN connections, only allow the connections to come over a VPN address instead of allowing the public internet to go there. And you can also say that you want to have the list exactly identical to the public one. That's also an option. All right. This one's now giving an internal server error, which is not exactly what we want. It's always the demos, right? All right, let's see where I'm at. Let's do a quick scan.
I'm not sure I understand.
Siri is not going to help out here today. All right, let me quickly go over a bit of configuration to see if this actually is correct. This kind of looks correct. This seems to be okay. Let's head back to my API. I've had in the past that I've injected the app service into a VNet, and then they hit save, and it said okay, and it actually wasn't okay. So let's see if that's the case here today. It doesn't look like it. Let's see if this is all looking fine. It's in the API network, it's in the app service subnet. All right, that all looks good. This one actually does say forbidden, which is also good. For some reason, today this doesn't work. All right, in terms of time, we're gonna continue. All right. So what should have worked by now is that we have a SQL database that's only, and you actually saw that part kind of working, only actually accessible from our API. And the API, as you've seen by the 403 forbidden, should now only be accessible by my front-end application. You might be wondering, now that we've seen the private endpoint and the service endpoint in action, which are two services that can be used in some scenarios for the same purpose, what is actually the difference between the two, and when do you actually want to use what? So I created a little list to go over that. So what's important to note is that when you use a private endpoint, you actually create a connection onto a private IP address to just your instance of that platform as a service offering. So it's a private IP address into your SQL database, whereas a service endpoint is a route to the whole of the SQL Server PaaS offering in Azure, not just your instance, but just a more optimal route into all the servers in Azure. So a private endpoint is used to go to a particular instance of yours, whereas the service endpoint will send traffic from your VNet to the platform as a service offering. A private endpoint can be used within Azure, but also from on-prem into Azure. Like I mentioned, you could connect to a database in the Azure cloud through a VPN connection. But a service endpoint is only usable from within Azure, only from VMs or app services, etc., within Azure into other services in Azure. A private endpoint is also a bit more difficult to set up. There's a lot of more stuff involved, like DNS, etc. And what you especially see in larger environments is that you often don't get to manage the private DNS zones, for example. But when you do create a SQL database and add a private endpoint to it, you do want the DNS to be registered somewhere. So you need to put a bit of automation in place to get that to work. Or you need to get permissions on the private DNS zone that you might not own. So it's a bit more difficult to set up than like you've also seen the service endpoints, which is just basically a checkbox on your subnet. And you don't need to own the service on the other side. You don't need to own DNS, etc. So it's a bit easier. But for both goes, the traffic remains on the Microsoft backbone. And so for both goes that you get a more optimal, more performant route into the service you want to connect. All right. One other feature, networking feature that I want to tell you about today is the use of the NAT gateway in Azure. So imagine the situation that you have an Azure App Service and that you connect from your Azure App Service into a third-party service, like a payment provider or something. What you then quite often want to do is give that payment provider a list of your IP addresses and make sure that only you are allowed to connect into that particular service. But if you ever looked at an Azure App Service and tried to figure out the IP addresses that an Azure App Service can use to connect into some other service, that's quite a huge list of IP addresses. And those IP addresses are not just used by your app service. Those IP addresses are also used by Azure App Services of other clients. So by giving that list to a third party, you have allowed your application, but also potential applications from others. And that might not be what you want to do. So luckily, there's a service in Azure that you can now use to route your traffic over to the public internet to ensure that you always have a static outbound IP address that is just used by you. And one benefit that you also get from this, which you might have encountered using an Azure App Service, is that depending on which service level of the app service you use, you might quite quickly run out of the number of ports that you are actually allowed to use outbound. And by using a NAT gateway, you can dramatically upgrade the amount of ports and IP addresses that you can use. So if you ever run out of ports, this might also be a way to get out, or pay more for Azure App Service, or fix your application, because it's almost always a kind of a bug in your application, which might be hard to fix. All right, let's go into the Azure portal and see what it actually looks like. I already created the NOT gateway up front. So it's a pretty simple service actually. It doesn't require a lot of configuration. What you do need to do obviously is give it a public IP address, which will then be used to connect outwards. And you connect your NOT gateway to a particular subnet, and then all traffic coming out of that particular subnet to the public internet will now use this NOT gateway to go out. So let's see if it actually works. Let's try to remember this particular IP address. Now let's go into my UI. Let's pick the right one. Let's go into that admin console that I just talked about. If it actually loads and shows me the button. There we are. Because we want to go to Advanced Tools, and then we click here and go to the Advanced Tool pane. You need to log in again. And this is that admin management pane that we just talked about when we talked about the access restrictions. So this is where you can find your logs and all sorts of stuff. But you can also go to a debug console and actually get a PowerShell console into your Azure App Service. And if we use that and run a bit of PowerShell, then that returns the exact IP address that we just saw on the NOT gateway. So this is now my outgoing IP address for this particular app server. But if we go back to the networking blade, and we scroll down a bit to the outwards traffic section, then this is the list of IP addresses that are normally used for outbound traffic. So you can see that's quite a list. And as I mentioned before, this is not just your application. This is being used by others as well. So that's quite a huge benefit, I would say. All right. That concludes the first part of the architecture that we wanted to build. But then we come back to the question of, okay, now we've been locking down the API and the database. How do I now, as a developer, still get into the database to do a bit of debugging? Or how do I actually do deployments into the Azure App Service? Because when you lock down the admin side, you also lock down deployments over a public address into an Azure App Service. So if you do that, you need to figure out another way to get into the services. One way to do that, as a developer at least, for manual stuff, is to use Azure Bastion. Azure Bastion is a service that you can use through the Azure portal, for example. And that allows you to log into a virtual machine in the Azure cloud using an HTML5 based web client. So you don't need to enable remote desktop protocol. You don't need to enable SSH on a Linux machine. So you don't need to open up those ports to the public internet. But it uses an HTML5 client in the Azure portal, which then connects underwater into your networks, which allows you then to connect into an Azure VM. So that's a nice and secure way to get into a VM instead of doing it over a public remote desktop port. And since a while, there's also native clients for at least Linux and for Windows to connect into a VM over Bastion. Whereas previously you had to go into the Azure portal and do it through your browser. But there's now also native clients to do that, which is a huge upgrade. But that only kind of works for manual stuff where you want to log into a VM and do your things. But what if you just want to use your local development laptop to actually do your development, or want to do deployments from Azure DevOps or GitHub or something? Then you need network access into these resources. One way to do that, at least from your development laptop, is to use a VPN connection. And use a VPN connection to get connected into the Azure cloud and then go on to your resources, like SQL database for us. But the thing is, all right, let's first talk about VPN for a bit, and then talk about DNS, which is the other service that we will then also need. So in the Azure cloud, there's a few VPN options that you could pick from. And VPN connections can be used from on-premise locations into the Azure cloud, but can also be used between Azure regions if you want to have a real secure connection between two Azure regions. So first of all, there's what we call the site-to-site version of VPN, which allows you to connect an office into the Azure cloud. There's also the multi-site version of it, where you have multiple offices that need to connect in the same region in Azure. Like I said, there's also the VNet to VNet version, where you connect VNets into different Azure regions using a VPN connection. Something that's also obvious, mostly used by enterprises, is what we call Express Route. That's a private, dedicated connection for you into the Azure cloud from your office location. So that's a highly optimal route into the Azure environment. And then still, when companies use Express Routes, they often still have a VPN connection next to that for backup purposes. So if Express Route might go down, although you mostly choose for multiple connections, but if it does go down, you still have the VPN connection to get into your environment. So you can use them side by side. And last but not least, there's also the point-to-site version that you could go for. So instead of your whole office, it could just be a device connecting into the Azure cloud, like your laptop, your mobile phone, etc., using the VPN gateway in Azure. And for all of these options goes that there's multiple ways to connect into the VPN. So you can be using certificates, Azure AD, Radius, or OpenVPN, just what you need. It does depend a bit on the operating system, which options you actually can use. Not all of these options are available on all devices and all operating systems. All right. There's also obviously a lot of third-party solutions in this area, because the VPN stuff in Azure is nice. It does what it has to do, but there's a lot of offerings in the Azure Marketplace that go far beyond just providing a VPN connection. They do a lot of firewalling in place as well, which might be just what you need. So there's also companies like Cato, which I used to work with, that provide you a lot of more details in what's actually happening in your connection and give you much more power than just the VPN solutions in Azure. But again, depends on what you need. All right, but before we can use VPN, there's one more thing that we need to talk about, and that is DNS. Because if something goes wrong, it's always DNS. And that's the same in Azure, unfortunately. So what happened when we create the private endpoint into that SQL database, you also saw me adding that record to the private DNS zone. But the thing is, by default, that private DNS zone can only be reached from within Azure and not from an on-premise network. So if you would use your VPN connection to connect into the Azure cloud, your local machine would not be able to use that private DNS zone and figure out what's the IP address, the private IP address of that particular database. So there's something you need to do to actually get that to work. And up until, I think, 3 months ago, what you needed to do was you needed to create a virtual machine in Azure, in the Azure cloud, a Linux machine. You needed to install a bit of software on that machine so that machine could now act as a DNS forwarder for you. So that means that you, your local client, could send a DNS request to that machine, and that machine would then go into Azure and figure out what IP address to send back to you. But that would mean that you would have to maintain a virtual machine, do the installation of the software, keep it up to date, keep it patched, etc. You probably need at least 2, because if one goes down, you don't have DNS, you have no connection anymore. So you needed to manage a lot of infrastructure that you actually don't want to manage. So luckily, Microsoft came with what we call the DNS Private Resolver, which does exactly the same thing. It allows you to connect into the DNS Resolver, do DNS resolving, and get the answer that you need for stuff that's in the Azure cloud. So it's a new offering that basically replaces the virtual machines that we talked about. It's quite costly, I must admit. If you want to go for a cheap option, at least from purely infrastructure perspective, then still the VMs are much cheaper. But that means that you need to manage them, etc., but obviously also cost a bit of money. So this is a nice addition to the solutions in the Azure cloud. All right, let's have a quick look at what this actually looks like in the Azure cloud. Let's go to a different resource group. And in this resource group, I created a kind of similar setup as in the previous one. I created a database, which has a private endpoint connect to it. And the database has a bit of data. It's registered in private DNS, etc., etc. And it has the private DNS resolver that we talked about, which is hooked up into my network because I've configured an inbound and outbound connection. And I also have a VPN gateway so that I can connect into the Azure cloud from my local machine. And luckily, Azure and Microsoft provide you a nice application to actually connect with your VPN connection into the cloud. You can just download that and distribute that to your users. And what you now see is that it has returned. Let me see if this actually does work. I think it does. What you can see is it returned a few routes. So it now knows that my connection now knows if I get an IP address back from DNS that I want to connect to, which falls in these routes, it now knows it needs to send that over the VPN connection instead of to the public internet. And what's important here is that you also see that my VPN connection now gives me a new DNS server. So I'm no longer using the DNS server from my internet provider or the one from Google that you might be using. I'm now using the DNS server in Azure. And this IP address that we see over here is actually the IP address of the DNS resolver. So I'm connecting into that particular service to do DNS resolving. And that should mean that I now should be able to connect into a database and actually query, not pick the error log, actually do a query on a database that lives in the Azure cloud, which I've locked down using a private endpoint. But as you can see, using a VPN connection and using the private DNS resolver, I can still connect into that from on-prem and do my thing. All right, that's what I wanted to show you today and tell you about networking in Azure. I hope you enjoyed it. If you want to know more, there's also a blog on my website that also talks a bit about networking and enabling some of the stuff. At least the first demo that I showed you today is also available there in a blog post, so you can always find that. So thanks for joining me, and have a nice rest of the conference. Bye-bye.
Great, thanks, Erwin. Please join me for a second. Well, you weren't joking with all the demos. There were a lot of demos, which I'm very grateful of, because it's very good to see. Because it really, I really need the visualization of how everything connects together. But of course, doing it in the Azure portal is, I think, quite different than how you do it maybe at a client, right? Because I expect you have a totally different way with CI/CD stuff. Can you tell us something more about that?
Yeah, obviously. So if we do this for a client, we obviously use infrastructure as code.
Mm-hmm.
I mostly use then either Bicep or Terraform to do the deployments of these kind of things. And we use those tools to do the deployments of the infrastructure and then lock down the resource that we actually can lock down. And one of the things that you also need to think about is then if you lock down your database or your app servers and you still want to do deployments to them, that means that your Azure DevOps agents or your GitHub Action agents and runners still need access into those as well.
Yeah.
So you mostly end up with creating your own custom Azure DevOps agents. There might be containers in the Azure cloud or virtual machines in the Azure cloud, which you can then run in your own network, in your private network, which then are allowed into the service.
Makes sense. Yeah.
Doing the stuff that I showed today in a portal is quite easy, but you need to do a few additional steps if you want to do it all the way.
Yeah, I get it. Yeah. And are these steps mentioned in the book that you co-authored, or?
Some of them are.
All right.
But there's at least a few blog posts on my website that go into the details of creating those Azure DevOps agents and hook them into your network
and
manage them. Yeah.
Okay. Well, I would definitely advise everyone go get the book first, but then also definitely have a look at the blog, because I think there's a lot of learnings in here which are very valuable for a lot of companies here. So
Thank you.
thanks a lot, Erwin. Great.
Right, cool.
Right. We'll now take a moment to prepare the next speaker, Purnima. So we'll see you again in a couple of minutes. Hey everyone, welcome back. We have another speaker here, Purnima. Welcome. When was the last time we saw each other? I think it was not in the Netherlands. I think it was in Romania, I think, right?
Yes, that's right.
The .NET days. That was also very nice.
Yes.
Yeah.
It's
Oh.
good to meet you again.
Yeah, exactly. Great that you're here. So you're combining Virtual Azure Community Days with another conference, right?
Yes. So tomorrow we have another stream from the studio. So I'll be hosting tomorrow while I'm a speaker today.
Nice. Excellent. Okay. And how have you been doing the last couple of months?
It's been good.
Yeah?
Busy.
Mm-hmm.
We had a break for Christmas, and here we are, 2023, and today is my first talk of 2023.
Nice.
And it's my first time at VACD as well, so I'm really
really?
glad to be
Okay,
here.
excellent. Okay, yeah. Well, we're very excited to have you. I would say feel free to go to your laptop, and yeah, we're very excited to hear about your session with GraphQL, and of course, one of my favorite subjects.
Of course.
Azure Functions. So I'm super curious.
Absolutely. Let me see if I can make you more intrigued with my session now.
Oh, you definitely will.
Okay, without
All right.
falling
Well,
down.
she's preparing. If you want to contribute to next Virtual Azure Community Day, always keep an eye out for our CFP. If you can do a session, we're always happy to help you prepare with your session or do some rehearsals, or maybe you want to co-host like I'm doing today. So always feel free to reach out to one of us. All right. I think we are ready.
Sure. Hello and welcome. I will be talking about GraphQL and Azure Functions today. How can you get a GraphQL server running on Azure Functions? That is my topic for the day. Thank you for having me as a speaker at VACD today. I'm excited, but let's not waste any time. Let's get started. Before I start off with the topic today, my name is Purnima Nair, and I'm a freelance .NET developer. I live in Berkshire, United Kingdom with my little daughter who is 8 years old and my husband. I'm a Microsoft MVP for developer technologies, and I'm also an Umbraco MVP. For those who don't know what Umbraco is a .NET-based open source CMS, and I do a lot of work with Umbraco. And non-work me, I'm a mother. I read a lot. I'm also a singer. I am training in Carnatic music, which is a stream of Indian classical music. And that's my Twitter handle should you wish to connect with me. I am not on Mastodon yet. Okay, talking about GraphQL. GraphQL was introduced to us by Facebook back in 2012. So it's nearly 10, 11 years old. So more than a decade old. And Facebook engineers came up with GraphQL as a solution to save their app, the Facebook app, which came out in 2012, which was struggling with draining the battery life of your device, slow startup, lots of bandwidth usage on your mobile device, all sort of problems. GraphQL was what Facebook engineers came up with as a solution. But what exactly is GraphQL? It's a query language for your API. So unlike REST, which is an API in itself, you could say that, GraphQL, a part of it is a query language. So you query your APIs. So straight away there you can see how the control shifts from the server to the client because you're querying your API. And that is part A. There's a second part to it, which is a runtime on the server, which understands, parses, and executes and validates your GraphQL query. And that's a server-side runtime. And all this happens on top of your existing data layer. Your data might be in a database. It could be coming in from a REST API, a third-party REST API. It could be a collection of GraphQL endpoints as well. GraphQL is very effective in acting as a gateway on top of your existing data layer. So it's query language for your APIs and a runtime for fulfilling those queries. And what you get with GraphQL is a single but smart endpoint, because what it does is it takes complex queries and builds the data output for you. And what I mean by that is, if you have a look at my example here, where I query the hero, I'm asking for the name of the hero, and then I'm asking, I want hero's friends as well. But for the friends, I just want the name. I'm not interested in any other information about the hero and the friends. The hero might have an ID field, a description field. The friends might have an ID field as well, but I'm not interested in any of it. I just want the names. And if you see the response that I get back from the server, it's JSON. My query is JSON-ish. But what I get back from the server is JSON. But if you look at the response quite keenly, it's a mirror image of my query itself. So developers benefit from that predictable response from the server. I'm also asking for related information here. I'm asking for hero and the friends. In a typical REST world, what I would get is hero and some IDs for the friends. But with GraphQL, I can ask for related information as well. And moreover, if I ask for something from the GraphQL server, I only get what I ask for. I don't get anything more than that or less than that. So in a typical REST world where the API says, just call me, I'll give you everything that I have, GraphQL is all about, hey, tell me what you want and I'll fetch you exactly that. So there's no data wastage there, which is the reason Facebook engineers came up with this kind of pattern. And as you can see, the client is in control of what they ask for. The responsibility shifts from the server to the client, which is very, very valuable for mobile apps particularly. Talking about Azure Functions and why it is good to have, or why GraphQL and Azure Functions are a good match, as we all know, Azure Functions is a very versatile product offering from Azure. Of course, it leads the serverless computing model. There are servers, but as developers, like I'm a developer, I don't get to see any server management or configuration. But at the same time, I don't need to worry about availability because high availability is assured to me. Azure Functions can scale on demand, so it can take up load and scale. And while all this is happening, I still pay only for my usage if I start off with the consumption plan, which is incredibly useful. And me particularly, as a developer, I can focus on application logic. This is really, really important because GraphQL is an application layer. As I explained before, it sits on top of your existing data. So it doesn't concern itself about where the data is. It acts as the application logic, which is what I get to focus on. That is Azure Functions and what it brings. Talking particularly about GraphQL, we have a loosely coupled client and server with GraphQL. That is by its nature. And that also means that the client and server can iterate rapidly. What we also have is exact fetching of data with no wastage of data at all, which is even more important considering the fact that we are on cloud and we are using a model where we pay only for what we use, which is fantastic. And moreover, we have GraphQL, which is an application layer, which can be useful to aggregate data from multiple sources to a single endpoint. And this is one of the most well-known real-world use cases of GraphQL. You aggregate data from multiple sources, bring that as an application layer, and your clients talk to that application layer. And when you bring the two platforms together, that is Azure Functions and GraphQL, what you achieve is your business layer, which is separated from application layer in the cloud. And we are moving a step closer to the resilient, scalable cloud-native architecture, which is the modern way of building applications these days. This also means that we can benefit from simplified deployments, we can iterate at our own pace, and we are moving towards that modern scalable architecture that I told you about. We need to cover some more GraphQL basics before we move on to the demos today. So we spoke about GraphQL and how it can help you fetch data from multiple sources or even fetch related information. What helps GraphQL at the heart of this is something called the schema. So GraphQL gets its name from the fact that your object hierarchy, the relationship between the objects, that is visualized as a data graph by GraphQL. And you extract parts of that data graph by querying. That is why we have the name GraphQL. And what helps GraphQL achieve this is something called the schema. This is the type system in a GraphQL server or a GraphQL API. And anytime you build a GraphQL server or GraphQL API or even run it on an Azure function, what you're trying to do here is establish that schema. Let's see how and what makes up a schema. So schema is made up of types. The first one is the object types, which is a representation of your object. It can be a person, it can be a vehicle. Examples are many. Then you have your operation types. There are 3 root operation types, starting with queries, which is for reading data. So I can read information about a person or get information about a list of persons or even read about a random person from my API. That is queries. Then you have mutations. As the name suggests, it stands for a change. So it can be inserts, updates, or even deletes. And then you have subscriptions, which is for real-time capabilities. So if you want to have real-time capabilities in your system, subscriptions is a standout feature which you can benefit from with GraphQL. So these stands for pushed updates from the server. So rather than your client polling for information, server pushes the information to you. And these 4 types make up the types of the schema. So schema is all about visualizing and establishing the relationship between your types, be it the object types, queries, mutations, all of that. It visualizes it as a graph for you. Schema doesn't concern itself about where the data is stored. It is all about that data hierarchy and visualizing that data graph. This is one of the key reasons why GraphQL acts as an application layer. One of the key things to understand with the schema and the types is that types are made up of fields. So query types, mutations, object types, subscriptions, they are all made up of fields. And each field has a name, which is the name of the field, a type, which the field kind of resolves to, like a data type, and what is called as resolvers. So resolvers act as the bridge between your field and where the data is stored. So resolvers are responsible for converting your field into concrete data. So on your object type, the fields might be like ID and a name. For your queries, you might have field like get a person or get a random person. For mutations, you might have fields to say add a person, which is exactly what I'm trying to do today. So what you do with GraphQL querying is you ask for specific fields on specific types. So when I show you the queries that I've written today, you will understand what this actually means. It's all about types and fields. This is the simplest way if you ask me to define GraphQL. GraphQL is also a specification, which means that it is like a contract or a blueprint, and there can be implementations which confirms to that blueprint. So this also means that across various different programming languages, there are various implementations of GraphQL which confirms to that specification. When it comes to .NET, because I'm a .NET developer, there are 2 implementations, GraphQL.NET and Hot Chocolate. Both are open source packages. And in my demos today, I'll be focusing on Hot Chocolate. So we'll look at the first demo for the day, which is all around queries and mutations. And before that, we'll need to have a little chat about Azure Functions and the isolated worker process model. So this is an execution mode in Azure Functions, which was introduced, I think, somewhere in 2021. And this is quite different to the in-process model of Azure Functions. With the in-process model, your class library function is a DLL, which is loaded into the memory of the Azure Functions host, which is your runtime, Functions runtime, and it runs within the same process. This means a very tight coupling between your function and the Azure Functions host. But with the isolated worker process, what you actually have is a console app, and the Azure Functions host communicates with your console app. So there's no more tight coupling between your Functions runtime and the functions. What this also means is that you can run your function in a completely different .NET version when compared to the host process. So this was the model which Microsoft came up with when they wanted to support .NET 5 on Azure Functions, because .NET 5 was the first non-LTS version of .NET. And going ahead, the isolated worker process model would be the one used for non-LTS versions. So currently, if you want to build a .NET 7 Azure function, this is the execution mode that you need to go in for. But as far as I understand from the roadmap, this is also going to be the future of the execution mode when it comes to Azure Functions, because once this execution mode achieves parity with the in-process model, there could be a time when the in-process mode could be phased out. But what you get from this execution mode is full control over the function startup. There is no more conflict of dependencies. You get dependency injection. You can inject custom middleware. You can benefit from the ready-to-run AOT, which helps you with the cold start. But overall, for me as a developer, it also gives me that developer experience, because I'm getting to work with the builder, the dependency injection, the middleware, all of that. So let us see this in action now. So I've got an Azure function set up here. So this is an isolated worker process model. It's in .NET 7. And I've got this package called Hot Chocolate Azure Functions Isolated Process, which helps me with Azure Functions and the GraphQL integration. So my API is all about a little get person, around people. So my model for the day is a very simple person Pogo class, which is here. It's got an ID and a name field. So here, there are some conventions kicking in, which Hot Chocolate helps us with. We spoke about types, fields, and resolvers. So in my case, the person class, that becomes my object type person. And all the public properties that I have here becomes fields on that type, and the getters becomes the resolvers. So that is Hot Chocolate conventions kicking in and helping me write as less code as needed to get going with a GraphQL server. So that is the object type. And to provide data and access to data, acting upon data, I've got this repository called person repository, which has a in-memory list. And I've got some methods which act on that in-memory list. Now we can start thinking about my query. That is the GraphQL query operation type and the fields on it. For it, I set up a query class with a few methods. So there's a getPerson method which gets a particular person from the repository, and a getPersons method which gets all the persons from the repository. And the method names here, the getPerson and the getPersons, becomes the field names on the operation type. So if you're thinking about my query, the fields would be called person and getPersons. That is again Hot Chocolate conventions kicking in and getting rid of the suffix, the prefix get or the suffix async. And you might have noticed there's the person repository here injected directly into the method. So this is called resolver injection, and that is one of the best practices when it comes to Hot Chocolate and GraphQL. The reason being your query operation type, the mutation operation type, the subscriptions, all these classes are singletons. So your dependencies would also become singletons if you do a constructor injection. So you have to go in for resolver injection. So having an argument like person repository and marking it as service would mean this particular repository needs to be resolved in the DI container. And you can also have arguments coming in. In this case, the ID comes in from the GraphQL query. So that is query covered. Similarly, we can have a mutation class. This time I just have one method, which is to add a person. I have the person argument coming in from my GraphQL query, and again the person repository injected using resolver injection, which I'm persisting to the in-memory list here. Now we have to wire this all up. As I said, in the .NET isolated process, we get access to the program.cs and a builder. So I have this add GraphQL function extension method, which is given to me by Hot Chocolate, that sets up the integration between GraphQL server and Azure functions. And inside that, I can customize the options. So I'm adding my query type. I'm specifying that this particular class acts as my query operation type. And this particular class, mutation, acts as the mutation operation type. And I have a singleton person repository injected into my DI container. And finally, if I look at the GraphQL function itself, I've got a GraphQL executor here. What happens here is the HTTP request data that comes in, which is like a representation of the HTTP request sent in by the Azure Functions host process, that comes in, and that request gets forwarded to this GraphQL request executor. And that executor takes care of executing the GraphQL query and returning the result to you. But that's not more. If I look here, there's a little bit of thing happening in the route. The reason being, once I have Hot Chocolate set up, what it also gives me out of the box is an IDE, where I can test my queries, have a reference to the schema, etc., as you will see shortly. And having this slug as a part of the route helps with the JavaScript and the CSS of the IDE that comes in with Hot Chocolate. So let's see that in action. So let me bring the project up. Hopefully it runs. So that is 7217. So if I browse to the URL, because HTTP GET is allowed, this is what you see as the IDE. This IDE is called Banana Cake Pop. Again, it's from the house of Chili Cream. That is Hot Chocolate. I have a schema reference here, so I can see my query, mutations, all of that. This is all done by GraphQL out of the box for you, because GraphQL has a feature called introspection, using which it can query itself. So I've got some queries here. I'm not going to dive deep into the writing of queries as such, but I want to get a list of persons here, get their ID and name. I can run that, get the names. If I run the query for getting a particular person, I can do that as well. Now, if I want to add a new person, I have a mutation query here. I have specified a variable called person with the person input type, which is the input type that goes in as the argument to my resolver. And I'm using the add person field, setting the variable value to the person argument, and mutations are generally followed by a fetch as well. So there's a change which goes in, followed by a fetch, which means I can fetch the details of the newly added person. And to send the value of the variable, I'm using a dictionary here in the variables, where I send in the ID 3 and a name. So I can see that in action as well. So that is added. And if I now go and run my query for all persons, I should have the newly added person in there as well. So that is queries and mutations. That is GraphQL Server running on Azure Functions, a little primer. And if you're looking at how the architecture looks like, so you can have your wide variety of clients like browsers, IoT devices, tablets, mobiles connecting to various instances of Azure Functions that will run smoothly. And your backend can be a database, a REST API, GraphQL, which can scale on demand as well. So that is a little introduction to queries and mutations. Let's talk about subscriptions now. So we need to understand subscriptions a little bit here, because subscriptions stands for pushed updates from the server to the client. So clients can say, hey, I need updates whenever a person is added. So in that case, whenever a person is added, the subscription system in GraphQL sends the updates to the client. And for that, just like you have resolvers in queries and mutations, you have resolvers in subscriptions as well. It's that resolver which does that work for you. So the resolver should get the information that a person has been added, and that is taken care of by events that are triggered. So when the subscription or when an event is triggered saying a new person has been added, the subscriber resolver kicks in and sends the update to the client, all the subscribed clients. Typically in GraphQL, that is facilitated by mutations. So whenever a new person is added, it triggers an event saying, hey, I'm triggering an event saying a person has been added. That event is caught by the subscriber. The resolver kicks in and sends the updates. So as you can see, there's a little pub subsystem going on in that place. So in my example, what I'm doing is whenever a person is added to that list, I want to send an update to the client. And for that, I take advantage of a new event that I fire every time there's a mutation, which is called person added. So for this, I have to use an in-process model Azure function, because there's no support for the isolated worker process model subscriptions with Hot Chocolate at the moment. I think that is, as far as I understand about it, it is all due to the lack of clarity where you can have streaming from the isolated worker process model. But what I've done here is I've set up an Azure Functions project in the in-process model, and I have the package called Hot Chocolate Azure Functions installed on it. And I've set up the same exact GraphQL function or the server that you've seen before, that is the person, query, and mutation. But in the mutation class, what I have done is, whenever I persist to the database, there's another little task that is happening. There is something that I send using the topic event sender. So for this, I'm using something called the iTopic event sender, which is again resolved from the service, which kinds of pushes an event or publishes to a topic with a topic called person added. So that is a terminology used in the pub sub world. You publish into a topic, and that is the topic name, person added, and I'm sending a bit of payload with that publishing as well. In this case, the newly added person is sent as a payload. And I've got my subscription class here, which is no different from query or mutation. But in the subscription class, I've got a resolver. And that resolver method has a topic called person added. This actually specifies that this subscriber resolver that kicks in whenever there is something published into this topic or with this topic name. So we are publishing using this topic, so which means that every time there is a publishing happening to this topic, something happens here, this subscriber resolver jumps into action. And of course, the payload that comes in from the mutation, that is captured into an event message, and I return that person back. And talking about the startup, wiring it all up, I again have the add GraphQL function method, but I need the add subscription type and specify my subscription class. And I also need some kind of a provider for my subscriptions, because we are talking about a little pub subsystem here. For demo purposes, the in-memory subscriptions will do, but in real life, we need something like Redis, which can scale and make sure that between your Azure Functions instances, the pub subsystem synchronizes. I will show that to you in a second. And the function is no different. There's the GraphQL executor to which my request data is forwarded to. So in process, let us run that and see now. That should run 7216 here. So I've got the same queries here, but I've also got a subscription called add person. I'm going to start my subscription, and the server it's going to listen to the server. So if I now add a mutation in saying new person added, I should get that information quite readily here. So let's change this to 4, and if I run this again, I get that information straight away here. So that is subscriptions in action for you. And this is how the architecture can look like. You have your Azure Functions instances, which talks to your backend server, again, REST, GraphQL endpoints, database. But you would also have something like Redis, which acts as your subscription provider. So this means that if you have one client connected to function instance A and one connected to function instance B, if there's a mutation coming in on function instance A, the Redis fan out mode makes sure that the mutation triggers the event, and that event is then passed along to all other function instances, and all the connected clients can get updates from the Azure Function instances. There's one more thing here. Subscriptions usually work on WebSockets, but socket connections to Azure Functions is not possible. So you have to use something like GraphQL SSE, which is well supported by Hot Chocolate, to communicate over subscriptions with the Azure Function instances. So what happens with GraphQL SSE is it is a package, or it is a facility that is built on top of SSE, that is Server Sent Events Protocol, which stands for a one-way communication, but long and persistent, from your server back to your client. So it is built on the native SSE protocol. So that is it from me today. That is a quick start to GraphQL over Azure Functions. This short URL will take you to my blog, which I've written about everything in detail. And a big thank you to Michael Stabe, who helped me with the subscriptions and answering the questions on it. Thank you very much. Hope you enjoy the rest of the day.
All right, great. Thank you very much, Purnima. Let's have a brief chat still here. Maybe the next speaker can get ready. This was I liked all the code samples, very clear and concise. Definitely, I haven't touched GraphQL myself yet. I was really surprised that it's already like 10 to 12 years old.
Yes.
I did not realize that.
Yeah,
Okay.
absolutely. It is quite new, but it is gaining traction from what I can see.
Yeah.
Especially in the .NET realm, with MAUI becoming so popular.
Right.
I see this becoming more and more popular and gaining more and more traction. What I've done is scrape the surface of GraphQL today, because once I started learning more and more about GraphQL, just because I liked learning about it, it is so much. There is so much to it than what you see on the surface.
Yeah, indeed.
And of course, there is a steering committee which decides where to go.
Right.
I can talk more about the streaming and differ functionality, which is similar to subscriptions, but hey, on another day.
Another conference, exactly. I'm definitely going to ask you, maybe we can work together on some kind of lesson for Azure Functions University, because I think this flows in very nicely with the stuff that I've been doing so far. So let's collaborate on that.
Absolutely.
All right.
Thank you.
I think we're almost ready. So thank you very, very much, and see you soon.
See you soon.
All right. I think it's time to welcome our next speaker, and that's Esther. Hello everyone, welcome back. We're still setting some stuff up here. Esther's preparing her laptop, but when she's done, then I'll invite you over here. Is the mic working of Esther? Is it all? Yeah.
We'll figure it out.
Okay, perfect. Good to see you again.
Yes, good to be here again.
Yeah. It's nice doing like conference and stuff again, right? So
Yes.
is this the first one of the year for you?
Yes, it is.
Yeah, I think for most people it is. Yeah.
Yeah, and I have to admit that COVID for me was kind of like very nice to be in my own personal bubble.
Your own bubble, yeah.
So I discovered anxieties that I never realized I had going back into the real world and being social again. So,
yeah. And also like going back to crowds, right? So that's also something that I have a bit trouble with. And
especially the first big conference that I went to.
Yeah.
When you were in these large rooms again, with so many people trying to make conversation,
right?
I never realized we were that loud as a community. But definitely is something that I'm growing to accustomed again. It takes some time.
It definitely takes some time, exactly. Yeah. Well, that's why I think this kind of setting is nice, because with this conference, we're like only the speakers and organizers are here on site, so it's quite a nice way of getting up to speed again with the whole conference and speaking gig. So I think it's nice, easy way back in.
Yes. Yeah, and what I loved about COVID too is that everyone only saw this part of me.
Come on.
I figured I had like 2 years to exercise and
don't be silly.
To slim down.
No.
Somehow I discovered that it's not about the whole dieting but just feeling comfortable in your own body.
Exactly.
So that definitely is a gain that
Thank you for saying
a big
that.
plus that COVID brought me.
That's excellent.
Personally, but yeah.
Okay, that's good. That's good to hear.
So I'm all good just being in person on video.
Perfect.
Doing the whole
definitely
hybrid.
Want to compliment also on the t-shirt, because I have it as well, but it's not so in a good state. Mine is really like crumbling off.
Oh yeah,
so
I
need a new version of this one.
I'm very. It's very precious to me because I love how it shows the collaboration instead of I'm gonna age myself now, but instead of the Windows versus Linux discussions that we had in the past, it's now more about how can we collaborate and
not dev versus ops, but maybe something in between.
Just
is that a nice bridge to your session?
Yeah, I like that.
Okay, please go ahead.
Yeah, you want me to hop on over
let's start. Yeah, I'm looking forward to it.
Some cool stuff.
All right. So again, if you would like to contribute at the next VACD, make sure you watch the CFP when it's there. And again, I would like to mention that we are always happy to help in case you want to try your presentation, help you with the CFP itself. We're always there for you. So let's get started, Esther.
Yeah, well, let's get started. Thanks for having me once again. My session is all about, basically my personal journey coming from an operational background to this whole new cool terminology that is now called DevOps. And I wanted to share with you some of the mindset changes that I went through. And hopefully they will help you too in your own personal journey in becoming maybe even the new cloud engineer or just having fun scripting with DevOps nowadays. Short introduction of myself, though you already did a great job. Thanks for that. So I'm just quickly gonna go over this, share with you that I've been around in the community for quite some time, on the job as a consultant as well. But I just love sharing knowledge. So I'm very fortunate to be able to do that through different community programs. Like Citrix Technology Professionals, Microsoft Most Valuable Professional, and also through the Citrix User Group Community Women in Tech Mentorship Program that myself and 2 other CTPs started about 6 years ago, where we're trying to mentor all the women in tech, trying to build a network that gives us more visibility within the community. So if you want to reach out on that, feel free to track me down either on LinkedIn or all the other socials that are out there. And for me, I've been transitioning basically for the last couple of years, focusing more and more on DevOps and cloud automation, using all these cool tools. But basically, that's not all I wanted to focus on today. Because for me personally, one of the things that I learned in my journey is that DevOps is not just all about tools. And of course, my own journey started with that very important question. Is DevOps basically a combination of development and operations, as the definition says? Is it like a 50-50 deal? I wasn't sure when I got started on where to position it. So yeah, I figured, why not just get the bull by the horn and basically use that bullseye to make it more visual. First of all, I did realize it wasn't totally on the upside and definitely not totally on the DevOps side. But from my personal experience, I have to admit that DevOps definitely leans a bit heavier on developer tools and processes than I was accustomed in my operational work. And then, of course, there's also the community. And I love Aaron Parker. He's a great community friend. But seeing tweets like this definitely isn't, I think, helping operations to welcome this whole new DevOps world and DevOps roles that are available. So I was very happy that instead of me being the first to reply, Tobias, another community friend of mine, responded in a very articulate way. I have to comment and praise him for giving this great response. Because I think he hits it right on the nail. It's not like we've never thought about automating our repetitive standard processes or work or workload. But what I love about his response is that last part. We now have better tools. But once again, if we're talking about DevOps tools and DevOps empowering tools, it can be quite overwhelming. At least it was for me, to be honest. So that's why I decided to share with you not just this whole discovery of what are all the tools out there that will help me, but first of all, discover on what processes do I need to adapt. Because I think that's even more important to realize that it does require a mindset change for at least me as coming from the operational background. And to give that a bit more body, I wanted to talk about how at least I approached new projects, especially infrastructure-focused projects, or in my case, end-user computing projects. First of all, we started with the waterfall method for a long time, I think, at least in my memory. And it is a good method for project management, but as you can see, it's all about just splitting up the work in very clear phases. So you first have to present like building, designing the whole environment, the entire infrastructure and all the components in it. And once you have that blueprint ready, you continue to the build phase. And then you start implementing all these cool technologies and making sure that everything works. And then you proudly create your first release. And that's the moment where end users have the opportunity to provide you with feedback. But we all realize by now that that waterfall method could mean that projects could take like a year before they release to production. So that means that you're expecting basically that end user needs or functional requirements do not change within a year. And I have to admit, reality is not that colorful or not that positive for the waterfall method. So I, for one, was very enthusiastic about transitioning to an agile way of work. Because as you can see, it basically means that I'm still going through the same process steps, defining, building, and releasing, but it's short-cycled. So that doesn't only mean that I don't have to worry at the beginning of getting that entire blueprint ready and have it finalized before I start building. No, I can limit my scope to that minimum viable product or the core features that I want to present to my end users. And then I can quickly start into building and releasing and getting feedback. Because one of the things that I learned working in an agile way is that feedback is such an important thing to have, because that's where we actually test if what we're building, if all the assumptions that we maybe unconsciously made during our build and define processes are actually working in reality. So basically, do not be too scared about starting to transition to an agile way of working. I think it can work for you, especially if you realize that it's basically just going through the same processes in a faster pace with a limited scope, so you can actually really focus on getting the job done. And to give you a bit of a visual reference, maybe some of you that did like project meeting or project management courses in the past even recognize some of these pictures. But basically, to compare the two, what you see with waterfall is you first start with that whole design based on the functional requirement that your end user wants to have a swing in a tree. Maybe that first picture even is a bit too much literal, swing in a tree, but okay. What you can see is that that blueprint just found basically its way into the release. And based on that first feedback, where they realized it wasn't actually swinging, they came up with what I call a quick fix. I'm not sure if the tree is really happy with this quick fix solution. But if you're looking at the agile way of working, it's all about starting with just the small functionality. We want to have a way to swing from the branch of a tree. And then, of course, that first release gave us some discussions with security, to be honest, because they basically explained to us that it wasn't really clear which body part was supposed to go in the swing. So yeah, it did make a lot of sense to quickly change the design, rebuild, and basically come up with all these other iterations. Every time asking once again, is this workable for my end user? Oh, do we need to tweak some? Okay, we'll make some tweaks. And what you see, at least from my perspective, is that you have a very, very, very luxe swing as an end user to use. And I think that's way more comfortable than the one that the waterfall method provided. So that's something to think about. While we're talking about Agile and Scrum way of working, the other thing that I had to learn was, well, first of all, the teams have a different structure. You have your development team, product owner, and a Scrum Master, and each has a very clear role within the team. And especially what I love about that development team, it's not just putting a bunch of people with the same expertise or specialism in a group and hoping that they can manage. It's all about being a cross-discipline team. So that also means that we can learn a lot from each other within the development or the DevOps team. And then, of course, there's the daily Scrum. And at first, oh boy, when I heard daily Scrum, I felt like, oh my God, this is like summer camp. This is where we get to create that kumbaya moment at the campfire, where we're all sharing way too much information and feeling all happy with the group. This is me trying to let you see that is not the function of the daily Scrum, because I discovered that it's actually very functional, especially for me. I'm the type of person that gets like the tunnel vision, like the super focus if I'm working on any challenges or any scripting or any code that I'm developing. And that sometimes means that I totally forget to ask for help. And what I love about the daily Scrum is that, first of all, I just give them a quick summary of what I did yesterday. Then I explain to them what the type of work is or what the product backlog items are that I want to focus on today. But the main thing is, every time I talk about what is in my way, it's basically asking for help without asking for help. Because this gives everyone in the team the opportunity to offer help without me asking it. So if I tell them, well, I was trying to figure out this function and it still isn't fully working, and I'm running into these errors, there's the opportunity for the entire team to say, Esther, I don't mean to pry, but I did run into the same error last week. And what worked for me is that I did this or that or whatever. And then that gives me new insights. So it's also very helpful for that creative process within the team. And I think it even makes the team be more efficient as well. But that's just for management. So let's not get too carried away about that. Yes, I still want to focus on the technology. And if I'm talking about my DevOps adventure, it's all about discovering infrastructure as code. If we're looking at the definition of infrastructure as code, it's all about provisioning infrastructure resources, basically in a similar way as software is developed. So what I mean by that is that we're focusing on using templates and scripts together with some orchestration tooling to make sure that all the resources we need for our infrastructure are deployed either in a public cloud or a private cloud. And if we're talking about code, I do want to make sure that you understand that there are basically two types of code that we can talk about: imperative and declarative code. And I created this great way of explaining the differences between these types of code. If we're talking about imperative code, it's all about executing a sequence of commands, basically in a specific order, and you're describing every little step in the entire process. So it's kind of like a step-by-step instructions manual, or what I like to say in regards to that other hobby that I have is it's like following a recipe. And in this case, burgers, of course. So it's all about not just telling you what the ingredients are for the burger, but also how to prepare and combine each and every ingredient in what step to create the sauce that you want on your burger, prepare the meat, and even specifying the specific order in how to build that bun and create your perfect hamburger. So if we translate that back to what is imperative code within infrastructure as code, it's all about using scripts, because each and every script is all about following a number of steps to get to that end result. But still, each and every step has to perform all the actions that you need to make that end result happen. Talking about declarative code, it's way more focused on only specifying the end configuration that you strive for. So it's much more like ordering from a menu. In this case, I just picked, of course, a random hamburger menu. But still, ordering from a menu means that even though I do not care how it is exactly prepared or in what order it's prepared in the kitchen, I still want to be able to specify whether or not I want that tomato on my hamburger, or whether or not I want extra bacon, or maybe only have that burger done medium rare. So there's still enough opportunity to make it custom to my needs, but I only have to focus on that end result. So translating that once again back to code, it's all about using templates. And then it becomes a lot more easier to get started with infrastructure as code, or maybe even service as code, or platform as code. It just depends on what you want to focus on. But the cool part is that right now we have all these awesome tools that give us the opportunity to just provide a template of that end specification or that end configuration that you desire, and they will make it happen for you. So talking once again about those templates, if we're talking about Azure, for instance, there is the Azure Resource Manager. That's basically the heart of Azure and all Azure deployments. So we're usually accustomed to using the portal to make that, to offer or to make the specifications for the resources that we want to deploy. But nowadays, we can also offer a template. In this case, it's a bicep template directly to the resource manager to make the magic happen. Once again, it's just bicep offering the template to the Azure Resource Manager, and then the Azure Resource Manager as that orchestrator basically magically makes the resources configured and all appear in Azure. Pretty cool, right? And once you understand the power of configuration, you can also use that with different tools. It's basically the same idea, making sure that you have everything specified in that template, offer it to your orchestrator tool, in this case it's Terraform in this example, and the end results will happen. So it's not just for infrastructure as code, as I discovered, it's basically opening up the world for everything as code. And I think that's where the next iteration of cloud management is heading. If we're talking in my particular end user computing reference, everything as code is easily translated to infrastructure as code, but also can be applied to image as code or workspace as code. And then it's just about applying the same idea, getting that template from your storage. And as you can see, I'm getting eyeballed now. So I will wrap up for sure. Thanks for that very clear message. And as you can see, it's all about using that template, and then before you know it, these tools actually make sense. And with that slide, I want to say thank you all. Give Hank some opportunity to breathe again, and then wish you an awesome follow-up of the next scheduled presentation. You want me to come back on stage? There's still time?
Thank you so much. Yeah. Well, yeah. Your timing was so perfect. I mean, so natural.
Thank you.
Amazing.
Yes. No clue what I was doing. Thank you for the clear 5-minute break.
Oh, this was really very good. So,
Yes.
but like the last final slide with all of the pictures, you don't have to understand everything, right?
No, and of course it's like a consultant answer to say it depends on which tool applies. But I hope at least with this presentation, I gave you an idea that it's more important to focus on the processes and getting basically that functional requirements clear. And then you can probably find a tool that will save you a lot of work and offer you the opportunity to use that template and then actually only have to specify that end configuration.
Yeah.
So,
Yeah,
that's
and
what I
also,
love about DevOps, so to speak.
Yeah. Do you have any tips for companies who struggle with this, with the whole automation part or moving to DevOps?
Well, if I'm fully honest, it's not only those templates. Of course, there's still scripting involved, or at least some tooling that will help you translate your workflows that you can use to write out each and every process that you're doing. Like Azure DevOps has pipelines that help you easily translate the workflows into step-by-step instructions. So that's kind of like scripting. But I'm hoping that especially those ops engineers that are a bit nervous about having to become a developer or having to become like a programmer, that a basic knowledge of scripting is all you need to actually get started. Because there are enough examples out there that will tell you step by step how to use or offer that template to the Azure Resource Manager, for instance. Oh yeah.
Great. Well, thank you very much. A lot of people will watch this and then take the first step to this DevOps journey, and small steps are enough, right? I mean, you don't need to be a pro like from day one. So just start small.
Just start small, and then,
Exactly.
like I said, just focus on that small scope, and then once you get excited, just start building more functionality to it.
Excellent.
And before you know it, you have all those tools in your toolbox.
Exactly. All right. Well, thanks again very much, and I hope to see you soon another time. And we'll take a small break now for prepare for the next speaker. See you soon.
See you soon.
And we are back, everyone. I'm here with Barbara. Welcome.
Hi.
For joining you. Is it your first conference of the new year, or you were like
It might
dozen
be.
already?
This
Yeah?
might be. Yeah, this is the first one. There are a
Okay.
few coming up, but yeah, this is the first one.
Oh, nice. You have a busy schedule for like the first quarter already, or?
some user groups are already coming up, so that's actually pretty fun to do some things here in the country.
Nice. Yeah. Because you've been traveling quite all over the place, like last year, right? You were
Last
very
year,
busy.
especially in the fall, it was really crazy. I was really lucky. I got to go to so many cool places.
Yeah, that's nice. Yeah.
Yeah.
And we actually met up not here in the Netherlands, but in the US, which was quite
We
funny.
had our first meetup in San Francisco.
Yeah, that was pretty awesome. Yeah, no, but it's good that you're like doing all these presentations all over, and it's nice to see you so active and so busy and
Yeah,
promoting everything. It's really cool.
I'm really happy.
But today you're giving a not your usual kind of session, right?
No, because yeah, I've been doing so much sessions that maybe this is a good time to start talking about sessions.
Yeah, I'm definitely looking forward to this. Yeah, feel free to take your place, and then I'll announce you. So next up is Barbara with Speak Up How to Give Great Tech Sessions. While she's preparing, if you have any comments or whatever, feel free to put them in the chat. And if you feel like standing on Barbara's spot next time, feel free to look out for the CFP and apply for the conference next time. All right, I think we're ready. So Barbara, take it away.
All right. So when you give a tech session, you need some way to start that session. So what I usually like to do is ask my audience some sort of question. So maybe I'll ask them, who here has given a tech session? So people can raise their hands then, so they have a bit of engagement. And I have that engagement, and I get a bit of a feel of what my audience is like. Maybe they are more experienced than I was expecting, or maybe they are less experienced. I can change my talk up a little bit. Now, this is great in person, but it doesn't work that well in virtual sessions. It's always becoming messy, so I never do this in virtual sessions. So virtual sessions, I might start with an anecdote, like I'm doing now. So that's also a way you can start a session. Or you can just start by saying, hey, this is what we're going to talk about, which is also fine. So today we're going to talk about how you can give tech sessions. I've been giving a lot of sessions. I think giving sessions is a great way to share your knowledge. You get to go places, you get to go to conferences, which is really cool to do. And yeah, it's a great way to share with the community. So that's why I set up a session about giving tech sessions. Now, the second thing you do is introduce yourself. You need to tell the audience who you are. Now, you might put your whole resume in here, but yeah, you don't need to do that. What you can do is tell a little bit about why people should listen to you. And that sounds a little bit weird, like you should sell yourself. But you are telling people this is why you should listen to me. So this is why I am capable of talking about this subject. So my name is Barbara Forbes, and in this part I would say that I am the Azure Technical Lead at OGD here in the Netherlands, which is not that relevant for this session, but my company supports me. So that's why I always mention where I work. I can mention I'm an Azure MVP and a GitHub star, which gives you the idea that I've done a lot for the community, so that I'm active at what I'm doing. So that might make me capable of giving this session. This is also where I can tell you about where you can follow me, because if I get more followers, then more people will come to my sessions. So you can follow me on Twitter at BA4BES. You can also follow me on Mastodon, which I actually forgot to add here. So I already did one small thing wrong, but we have to mention Mastodon now, which is ba@4bes.dev. And you can find my website as well, which is forbes4.nl. Now, I've been giving a lot of tech sessions, as we talked about, and I've counted, I'm somewhere above 50 at this point in like 3 years. A lot of those were virtual, but a lot of them in person as well. And the pictures actually here, what you see on the left is the first time that I ever did a session. This was an internal session for my company. I was very nervous. And this was a session where I talked about our visit to Microsoft Ignite in Florida in 2018. And the background picture is Ignite 2019, where I was actually a speaker. So I think that's a really cool part of this. And on the right is one of the last sessions I did last year. It's actually not the last session, but this was one of the better pictures I had to use. So this tells you a little bit about me. So we've talked about what the session is about, we've talked about me, and at this point, it's about what are you going to see. It's always good to have that at the start of the session to set some sort of expectation. Maybe people expected something else based on your title. So this is what we're going to talk about. First, we'll talk about how you can get to give a tech session, because first someone will have to give you a stage. Then how you can create your tech session, and we'll close it off with how you can deal with demos, some tips and tricks. So first things first, we actually need to get accepted to give a tech session somewhere. We need a stage for people to be able to listen to us. So we just need an idea, a title, abstract, and we're done. Easy, right? Now, actually, this can be pretty difficult. I've seen a lot of people stumble on that idea already. They're like, okay, I would love to give sessions, but what am I going to talk about? And I see a lot of people who feel that they don't have enough expertise, maybe. And I can tell you that shouldn't be an issue. Because you can give beginner sessions. They are actually pretty popular. So some sessions on these are the fundamentals, or this is how you can learn to do a certain thing. They work really well as an idea for a session. Another thing that really works well is something you have seen in the field. We love to see people in real life. We love to see the difference between theory and practice and what you have seen. So if you have done something for a customer, or if you had a personal project, these are things you could talk about. So that's also something you could consider as an idea. So when you have an idea, you need to create a title and an abstract. So the title and the abstract is really where you tell people about your session, but more than that, you are selling yourself. You are telling people why your session is awesome and people should come to see your session. So with the title, you can just describe whatever you're going to talk about, but what is making your session different from someone who's talking about the same subject? So it's good to have a little fun with the title. But do remember to always mention product names or specific things you are going to talk about, because often conferences have a search option. So they will search for a certain product or a certain technology, and you want to have that in your title. And the abstract, like I said, it's a short description of your title, but it's also a way where you sell yourself, because you need to sell this session to two different parties. You need to sell it to whoever is organizing the conference to make sure that they pick your session. And you need to sell it to the people who have the abstracts in hand, who have the programs, the schedules, and need to know which session they're going to go to. Because often there will be different sessions at the same time as yours. And you want people to come to your session and not the one from your neighbor who also has a great session, but you want them in your room. So that's why the title and the abstract, this can be a bit weird when you're first doing it, that you have to sell what you're doing and get people excited for them. But it's something you can practice and will get more natural in a while. But it's good to check that. And then we've got our great title and our great abstract, and now we need to get accepted to conferences. And now we find out the odds are against us. Really, it can be frustrating to enter through CFPs, because most conferences have far more people who want to speak than they have speaker slots. And with big conferences, this can be about 10%, where there's 20 sessions and there are like 200 sessions applied. So it's important to remember that. Remember, the odds are against you and it's never personal. It can get frustrating. So it's good to always be aware. It's not personal, the odds are against you. Which makes it even more cooler if you actually get accepted. When you get accepted, or if you want to get accepted, there's another thing that's important, and that is that it helps if they know you. So if they know your name, if they've seen some of your work. And that's difficult if you're starting out, because yeah, that's the paradox. Like, I need to get experience, but I need experience to get that experience. It's a good thing we have something for that, and that is user groups. User groups are often sessions that are performed around a certain subject in a certain area. And it's just the evening and you'll come together in a building that a company supplies, you get some food and then some knowledge sessions. And user groups overall are pretty often, which means they are often actively searching speakers. And they are always happy to give new speakers a chance to start out. So you can get some practice and maybe you are on the Twitter of the user group where they say, hey, this person has done a talk with us and they can take some photos. Maybe it's even on video and you have it on YouTube. So when next organizers of events are looking for new speakers, they can see what you are capable of. So user groups are a great way to start. If you want to do that, find a user group in your area that fits the subject that you are interested in and you want to talk about. Maybe you visited a few times, so you see how it's going, what's going on, and then you can just talk to the organizer, say, hey, are you looking for speakers? And in this case, I always say, the worst they can do is say no. Or they might say yes, and then you actually have to give that session. But we're going to prepare for that in a second. So if you're getting started, great way is to do it in user groups. So now we have been accepted to a conference or to a user group. We are going to tell our story, and now we actually need to create that session. By the way, I always create the sessions after my abstract is accepted. So I have a bunch of titles and abstracts that I put out there for conferences, and I don't actually have the session until I am accepted somewhere, and then I actually need to create it. This always works, so don't worry about that, but it might save you some time with creating abstracts. So we're creating a tech session now, and that requires some preparation. And I've seen that gone wrong, and I've done it wrong myself with thinking I had taught a few classes. I have thought about this stuff. And I was like, oh yeah, I can do that unprepared. So I can probably do a session unprepared as well. Session is different. Your story needs to be more aligned and you have a shorter time span. So you need to do some preparation to get an awesome session out there. And one of the most important parts is the structure of the session. And that's one I see people forgetting. Think about what you are talking about on your session and why. So this structure, yeah, this is out there. There needs to be a beginning, a middle, and an end. But there are a lot of theories about how you can structure this well. In the beginning, you saw that I first did just a few lines on what we're going to talk about and why you need to follow this session. So I'm making the selling point of telling you this is why you should follow this session. Now in the middle, the session is actually happening. And in the end, I've often seen people forget the end. They are to the end of what they want to tell, and they're like, okay, this was my session. But on the end, it's good to think about what do I want my audience to do? What do I want them to get? So maybe you give them some sources for if they want to continue their learning. Or maybe you do some sort of call for action where you say, visit this website or start your own technology, stuff like that. So that's often forgotten. It's great to have that at the end. There is another part of the structure that I feel is really important, and that's one that you also saw at the beginning, where I said, this is the schedule. This is what we're going to talk about. And as you see, my sessions are all often in 3 parts. And you can do 2 parts, 3 parts. The reason for this is because of the human attention span. Humans have an attention span of 10 to 15 minutes overall. 15 minutes is pretty safe, sometimes 20 minutes. But after that, they get distracted. That's natural. It's not something to be ashamed of. It doesn't mean your session is boring. No, that's just how the human brain works. So it's better to work with it. So I often divide my sessions into 3 different sections. So that means if someone gets to that point where they're distracted, I can say, and now we're going to start something new. And what I hope to do is get a new attention span going with this. I lay them out pretty clear, those chapters. And I do that because of my own experience that I sometimes doze off a little bit during a session. Sometimes I just lose my focus for a second, and then I want to grab it back again, and I get lost in the story because I have missed parts. And by creating different sections, I give people the opportunity to get back into the story, because I say, okay, what we talked about is done, and now we're gonna start something new, so you can grab on again. So that's the reason why I like to work in sections, so why it's smart to have that kind of structure. Using PowerPoint, I will give you a second here, because that's the point I want to make. I see a lot of PowerPoint with a lot of text on them. And if there's a lot of text, you can't read and listen at the same time. And I found myself, since I'm aware of this, that I always try to force myself to listen to the speaker and not read the PowerPoint. But I have to do that consciously. So if you have a choice, there's a good chance people are reading your PowerPoint and not getting your story. So with text, less is always more. Remember that that PowerPoint is there to help you tell your story, not to tell the story for you. So less is more, and actually I've seen a few people, and I've given a few people the challenge to have a PowerPoint without any text at all. And this can be done. It's pretty difficult because sometimes it helps you to tell the story. So if it's fitting, you can add text on there. But stuff like this, I think this is already too much. But then again, PowerPoint is a great tool. I really love what you can do with PowerPoint visually. PowerPoint can really help you with making a visualization of what you're talking about, especially if something is a lot of text because it's a lot of code or stuff like that. It can visualize the stuff for you. And less is more with text, but absolutely not with pictures and animations. I don't know about you, but I learned in school that animations are not professional. Around the same time that people thought that Comic Sans in a PowerPoint was a good idea. But I have found animations that really help me to tell my story. And I want to show an example here. This is an animation I have used for a session around Azure Functions. And I was talking about all different parts of Azure Functions. And I add all the animations together now, but I used this throughout the session to explain where we were at that point. So this is the animation that I used, where I have all different parts that I can talk about at different times. And I'm trying to do this a lot because I feel that it helps with telling my story. And that's what it's supposed to do. So here in PowerPoint, I hear people say, like, you don't have to do animations, less is more. No, sometimes animations are a good thing. And PowerPoint is really powerful. There are so many great options in there. You can use morph to zoom in on certain parts of a picture, and that can look really, really professional. So I do challenge you to check PowerPoint, see what you can do with it. And here's my animation again to give the most important message of this whole talk. If you don't remember anything, or if you can only remember one thing, this is the one. Practice your sessions. I sometimes see that people tend to think that it's cool to tell people that they are unprepared for sessions, where people send out tweets that say, yeah, I'm at the airplane, maybe I should preparing my session now. And a session becomes so much better when you practice it. Practicing really means set it up for yourself, set a clock with it, and do your session, do your story. And this is going to help you for a few reasons, because you're going to find when you practice what things don't work. Or maybe you're going to find when English is not your first language that you're not sure what the correct term is for some things you want to talk about, which in your head make complete sense because in your head you hear them in your native language. And then you have to translate them in English, and you might find out that you have no clue what the word is. So this can really help. If you practice, then you can make sure that that doesn't actually happen on stage. Practice can also really help with feeling more confident about your story. And I know we do it internally. We have internal, when people do sessions, I always say we're going to do a practice run beforehand. And without any doubt, anyone who does this says, I'm really happy that I practiced it, that I did it once before I actually had to do it. So if you only remember one thing, I still practice every session I do. I try to do it 3 times. Doesn't always happen because time can be difficult. But I always practice every session that I do. And I think I did 1 or 2 sessions that I was not that prepared for, so I didn't practice it. And not only did it show, but it made me feel unfulfilled because I was like, I could have done this better. Another thing that practice helps you with is the timing of your session, because that's actually pretty difficult, especially if you're not that experienced with it. You might feel it take like 30 minutes to tell a story, and it might only take 10 minutes. And in a user group, not that big a deal. But in a conference, people really want to know what timing is set up because there's a pretty tight schedule overall. So you can be 5 minutes short or 10 minutes short. That's not that big a deal. But if you go longer, for example, they often don't like it. So it's a good way to time your session, have a timer there, and know if you're on track. So you can time them, and I did that once. I did once give a session where I was like, I got cocky, and I was like, oh, I can do this. I've done this in a group. I should be fine. So I started doing the session, and I was through all my material within 20 minutes, and I had 15 minutes. So that's really can't happen. And I was very lucky that this was a subject where I could improvise on and fill up the whole session. But this was not the quality I'm aiming for. So I learned it the hard way there. Always practice all your sessions, if it's only for timing, but practice your sessions. So finally, now let's talk about how you deal with demos. Demos are the greatest thing in tech sessions because they bring it to life. They bring to life what you're talking about. Like, you can give a lot of theory, but this is what it looks like in real life. And people love watching demos. So more demos, always have demos in there. I always like to do, if I have a session with demos, I like to put them in between the sections. So it also really helps with the people that get a bit of fatigue, where their attention span is gone. It's like, hey, something new, look, exciting, movement. We're going to talk about the demo and we're going to show it in real life. So demos, always a good idea. But there are some things that can help your demo. And the first one is that you don't have to depend on the demo gods. We like to say that to each other. When we start a session and we say, oh, we sacrifice something to the demo gods, and we're going to pray to the demo gods that everything will go right. Demos fail. They do. It happens. And that's, on one side, that's what makes it fun, because it makes it authentic. It shows you that it's actually a live demo. So demos are going to fail, and that can happen, but it's better to be prepared if it fails. Because you're thinking of, well, maybe something going the wrong way, and I can show you how it was supposed to happen. But what do you think about just the technology is working? It's just really, really slow. Because especially Azure tends to be really slow when it's being watched. It feels that, I'm telling you. So it's better to be prepared for that. So you can do that in a few ways. You can create videos. You can just video your screen, take screenshots of your screen, make a video beforehand. So you still do the live demo. The demo fails or something goes wrong, and you say, okay, that was not supposed to happen. I'm going to show you real quickly what was supposed to happen on this video. And people will like that because, yeah, it's not live anymore, but they appreciate you being prepared. You can show the video. You can actually do the demo on the video. And it will actually give a pretty similar experience to when you do a live demo. So especially for short sessions where timing can be an issue, sometimes I'll just prepare the video and I'll walk through it like it is a demo. And have seen that once before, where I had a coworker who was doing a demo on a video, and I knew it was a video. And I knew it wasn't a live demo, but I was completely invested like it was a live demo. So it's okay to show stuff on video. So you can do the videos, you can get back to them. Another option I always like to use is have the resources I'm creating. If, for example, if I'm creating resources, I will have them set up somewhere. That's also something you can do where you say, okay, this is a resource. I'm clicking here now because I'm deploying this resource, and we're not going to wait for this. So here I have the resource already prepared. And you can start working with that. So saves you some time, which otherwise people might be waiting for you. So this is how you prepare yourself against the demo gods. Now let's look at a few small differences that really can change your demo, especially if you're working with code. This is what I sometimes see when people do a demo. And this seems a bit crazy. I've seen this a lot actually, where this is the demo of, look, I have a bicep template here. And I want to show you how I would do this. This is how I would set it up. So this is the exact same code as we just saw. It's exactly the same as we just had. But this time it's far more readable. So let's put them side by side. As I said, the exact same stuff. So the first thing that we see changed here is light mode. I know people don't like light mode. I like light mode. There's dozens of us, but I like light mode. But especially when you're doing stuff in real life, when it's projected, dark mode is not very well visible. So you want to use light mode. So that's the first small change you can do. The second thing is all the stuff that's surrounding your code. So everything you see in Visual Studio Code, and you see my taskbar is up there. So stuff like this, you might want to switch off. You can hide that taskbar. I actually like to use a fresh install of Visual Studio Code. So I often use like a VM and have Visual Studio Code running there. So you can do stuff like that to have the distractions be gone and just say, this is the code we're going to focus on. And the third thing you see that I did here is I zoomed in like crazy. I've zoomed in very far because the people all the way in the back also need to be able to read your code. And trust me, when you ask them, can you guys in the back read your code? Someone might say yes, but someone else might think, yeah, I can't read it, but someone else already said yes. So be prepared for that, but also be prepared on a mobile device. People might be viewing your session virtually on a mobile device. So if it's a big code, they can actually follow it along. My rule of thumb is zoom in until you get to the stage where you think, okay, this is getting ridiculous. Then you're at the right stage. That's where you need to be. So 3 small things when you're working with code: light mode, getting rid of all the distractions, and zoom in like crazy. And what's the other most important thing we've barely talked about is to have fun with this. So we've talked about everything you need to do to prepare. And giving a session can be a lot of work, especially if you're starting out, you're not that experienced yet. But it's also so much fun. It's really great to be on that stage and tell people about the stuff that you love to work with. At least I'm assuming you love to work with stuff, you want to tell people about it. People come to you to listen to it. And afterwards they may tell you, hey, this is a great session. And that's a really great feeling. And it's a lot of fun to be able to go to a lot of sessions, to a lot of conferences. So it's a great way to contribute to the community. So this was the conclusion part where I can say you can still follow me on Twitter and on my blog, which is forbes4.nl, and my Twitter is BA4BES. Notice how it has been, there it is, how it has been on every slide that I've used and always at the top. Because if you have this in real life, then often the bottom is not that visible. Because people might be in front of it with the chairs. So always at the top and at every slide. They can follow me there. And my conclusion is have a lot of fun and don't forget to practice.
Excellent. Please come back for a second.
Yes.
I really enjoyed this meta session about giving talks. I really liked it. A lot of stuff were very recognizable. Of course, I have to ask, how many times did you practice this?
I've done this one once before, and I
Okay,
practiced
okay.
it then 3 times. And I actually had a thing with the speaking coach for that, so I was really
wow.
prepared.
Okay, that's good. Yeah.
And I wanted to do this 2 times
Yeah.
in the preparation, and I had to do one either yesterday evening or today, and I couldn't make it work.
Yeah.
And I was really
yeah.
bummed that I really was like, I want to do it another time.
Yeah.
So I did it like 4 times the last time I did it, and now once.
Yeah, it does help, of course, because that's also quite a normal thing, right? Reusing sessions for different meetups or conferences.
Yeah.
So because sometimes I read on Twitter that people don't like that people reuse their sessions, but I think it's really normal. It's really,
because how often are people going to be at the same conference? Yeah, we got a bit spoiled with the virtual sessions.
Yeah.
But with conferences,
yeah. And it's also like it takes a lot of time to create these sessions, so it's also not really worth, let's say, the time of the speakers to just give it once and then be done with it. So
yeah, exactly. It actually takes quite a bit of time to create a good session.
Any final word except for the practice?
Yeah, did we talk about practicing yet? You need to
not
practice your
enough.
session. By the way, if you're feeling insecure, especially if you're doing this for the first time, find someone to practice with.
Yeah.
And I will tell this about my one of my first conferences that I was going to do. I was accepted. I was I'm going to do a talk. Oh, I should be fine, no problem. And I had a mentor back then, and he said, oh, no, you're not fine. We're going to make this work, but you're not fine yet.
That's fine.
And he helped me create that session. He was very experienced. Was Sander Berghauer. He is very experienced, also an MVP. And he helped me create that whole session. And he set up like 3 different times where I could practice it in front of a group.
Excellent.
Stuff like that. He was really like, and I call it setting up for success.
Yeah, exactly. Yeah.
And that session would have been a lot worse if he didn't help. I think it was a good session considering how inexperienced I was.
Yeah. I think that's very good closing advice, right? Like always either seek a mentor or a buddy you can practice with.
Yeah, a lot of people in the community are also able to help you.
Exactly.
You can always ask. The worst thing that can happen is that they say no.
Yeah.
Or yes.
Okay. Well, this has been great, Barbara. Thank you so much for joining us today.
Yes, thank you.
Excellent. Okay, we'll take a small break and prepare for the final speaker of today. Hello everyone, welcome back. And yeah, we are at the final session now almost. I have Callum here, welcome.
Hello, nice to see you, Mark.
Yeah, it's been a long time since we've seen each other.
It has been a long time, and probably it was virtual because it's great. It's great finally to have people back in person.
Yeah, exactly. Yeah. I did once also attend like a Dugfest, I think, also in Utrecht. I think that was the last time I were in real life.
Possibly. Yeah,
it's really quite some years ago. I definitely need to attend the next time again. That was super awesome.
Yeah, it's a great event. It's always a great event. And it's great to be in Utrecht, and haven't been here for a few months. I've heard the sun's come out for us.
Yeah, that's the best excuse. The weather is always so good here. No. Today you're talking about scaling in Azure.
Yeah, and with .NET apps, but not really .NET apps actually. It applies to anything. So
anything. Okay.
Anyone that's watching, you can take these concepts and you can.
Okay, that's
you
good.
Can use them broadly.
All right. Yeah, no, I'm super curious. I would say let's get started. Get ready at your laptop, and we can get going. So while Callum is preparing, please hold on for this one final session. Going to be like a super interesting technical one. Quite a contrast with the previous one, but I think it's nice, all this diversity in speakers and sessions. I think Callum is ready. So go ahead and enjoy this final session, everyone.
Fantastic. Let's get started. Okay. Well, as Mark's already introduced me, I don't have that much to say here, but I'm Callum, and I'm going to be talking a little bit about scaling your application with Azure, or maybe we have a saying in the UK, 3 ways to skin a cat, 3 different ways to approach scaling in Azure. And if you're doing JavaScript, if you're doing Python or Java, actually all of this applies. So hopefully there's something in this for everyone. Just quickly, a little bit about me. As I said, my name's Callum White. I'm quite active on Twitter. If you like to get hold of me after this, I'm a Microsoft Developer Technologies MVP, and Umbraco MVP. Umbraco is an open source .NET CMS. If you don't know, it's a very good one. You should go check it out. I do .NET development. I run a small web agency in the UK, working with Umbraco. I speak at events, organize events. Love donuts. I'm trying to cut down on a bit of a health kick at the moment, as a few of us are in the new year. But yeah, that's me. So we often, in our line of work as engineers, get asked about scaling, right? And scaling is a topic that people often get wrong, or maybe just think it's going to be super easy. And it's not. It requires a bit of thought. So in today's session, I'm going to explore 4 areas, or 3 to 4 key pillars of scaling your application. These are the different constraints you're going to have, the different challenges you're going to come up against when scaling an application. The first one's compute. So this is your amount of compute power behind your application, what's needed to run your application at scale. Of course, the more your application's in demand, the more compute you are going to need. Scaling that is a challenge within itself. Persistence, data. What do you do with your data at scale? How do you handle, multiple requests, writes, geo-distribution of that data? It's a big challenge, and something that maybe shifting a legacy application to a cloud platform or trying to scale that isn't going to be so easy to do. State is a tricky one, and that's why I've graded out here. We're not going to touch on this too much today. State is very difficult to do at scale, and doesn't really apply to every context, which is why we're not going to talk about it so much. Let's say you're building a big e-commerce system with logins and people's baskets and tracking of checkout sessions. Well, okay, yes, state's really, really important there. If you're building a, let's say, something like IMDb or Wikipedia, where you've not got that much ongoing, say, edits or sessions, it's mostly read-only traffic, well, state doesn't matter so much in that case. So we're not going to talk about that one today, because that could be a whole talk in itself. And finally, the third pillar is observability. One of the biggest challenges, and possibly the most important of the 3 here. This is the when and why you scale, not the how. The other first 2, persistence and compute, are really going to be more about how do you scale, how do you get your compute to be multiple instances, how do you get your data storage to be able to handle lots and lots of requests. Observability is when and why do you need to perform actions that will make compute and persistence able to handle all the traffic. So just as a bit of an example, we've got a few different forms of compute in the Azure world. Let's say we have virtual machines, which would be maybe the legacy approach to having compute. This is virtual machines are running an operating system. You install whatever software you need, and you host your application on there. You have app service, or like a PaaS type platform, where you can chuck your code at the platform and it sort of runs it. And it can handle things like scaling as well quite nicely. In the virtual machine world, scaling is semi-automated, but you still have to roll out physical hardware, or virtual hardware in this case. With an app service or a PaaS platform, those apps get provisioned on as many machines as you need, and you can scale up and down pretty dynamically. Quite cool. There's also another paradigm that's maybe somewhere between app service and this next option, which would be a serverless option. And we're not going to touch too much on that today, but it's a similar concept to app service where compute is provisioned as you need it. And finally, Kubernetes. So Kubernetes is a container orchestration tool. And we're going to touch a little bit on what that means and how that works in practice in a second. But Kubernetes is a way of deploying multiple instances of an application running in containers across many, many virtual machines. And it will sort of manage that for you. Azure has a fantastic Kubernetes service that is great for managing Kubernetes clusters at scale. And they've got some other flavors of Kubernetes running in the cloud as well, which we're going to have a look at. For persistence, so maybe the more standard, typical thing, if you had a physical server, you're going to have physical spinning disks. People still have those running in data centers in places in the world. Disks is probably the most common form of storage you'd be aware of. You have a disk in your computer that's storing all of your data there. Now, in the cloud, we maybe have a more modern approach to something like disks, which would be a service like blob storage, or in this case, a managed storage service. So rather than this being disks that fill up, you've got almost infinite space there, and those get spread across multiple disks in Azure's data center and could be distributed globally if you need them to as well. The blob storage service is part of a storage account. A storage account can contain tables, it can contain blobs, files, loads of other stuff. And again, geo-distribution, replication, fault tolerance, all the stuff you don't get from disk. If you had to have disk, if you wanted to do the same with disk, you'd have to manage all of that stuff. And this is kind of the same with traditional SQL or relational databases. If you're using a traditional database, those typically don't scale very well or scale globally very well out of the box. So you have to come up with some alternate solutions. Now, Azure SQL is the preferred for us way of hosting SQL databases in Azure. But you can do a lot of stuff with this as well. It can scale. You can do data replication. It can do fault tolerance, but it's not quite as good as its cousin, should we say, from another planet, Cosmos DB, which is a kind of an anything DB. It has graph storage. It has relational database storage. It has NoSQL style storage. It can kind of do everything, and it's geo-distributed. And it's all powerful. Where the Azure SQL, with the approach with Azure SQL, you're sort of, again, resource constrained based on requests, inbound pipeline. Cosmos DB will scale, in theory, infinitely for you. So depending on where you want to store your data and what types of data you have, any of these options could be viable, but each one comes with its own challenges. So if you had media that you need distributed globally, well, blob storage is probably a great shout. If you have some relational data that maybe doesn't need to be high query volume or doesn't need to scale so much, Azure SQL is great. If you want to pay a little bit more, maybe have geo-distribution, maybe you're going to have multiple reads and writes simultaneously in different places all over the globe, well, Cosmos DB is really great at helping you out there. Again, you could probably do a talk on each of these options on their own, so we're not going to dwell too much on the individual implementation of these products. Finally, observability. What are our tools in Azure? Well, we have two main tools. Azure Monitor, which is one you've maybe not heard of so much, and Application Insights. Application Insights is a log analysis tool. You can dump all of the information about your application into one place and then start to action things based on it. Or if you're, say, running an application with 15 different servers and you need to get some logs from a very specific server, you don't want to have to go and find that server. Or if you're running in a PaaS setup, you don't have a server to go and log on to. You don't know necessarily where those logs are. This allows you to keep all of that data all in one place. and get a really good understanding of the health of your application at any given time. Now, Azure Monitor is sort of underpinning every Azure service. You've probably seen this or interacted with this without knowing. If you go into the Azure portal and you go to a web app, you'll see the sort of CPU usage or the traffic, the number of requests. Now that's Azure Monitor doing its job. It's keeping an eye on every single part of the Azure infrastructure. You can then set up more specific alerts and actions if you wanted to there as well. Again, probably a whole talk on that. We're not going to go into it today. Right, so the when to scale. As I said, observability is possibly the most important bit. You can throw metal at your website or your application to make it scale. It's not necessarily going to perform very well, it's not going to be easy to maintain, and you're not necessarily going to be doing the most efficient thing in that case. So this when and understanding when the right time to perform these actions is really, really valuable. So these are some common scenarios that I've seen people decide they're going to scale their application. By request count, so you know that, hey, our application handles roughly 1,000 requests, and then it needs to scale up, or maybe many more, maybe many less, concurrence, that is. However, that's a problem, because requests are not all made equal. Some requests are a simple, if you think in web request terms, that's an options call to an API is going to be a very minimal amount of data, versus doing posts that then have to write data to storage or go fetch other data from other systems. Those could be, they're not going to be equal. So you can't accurately measure or quantify really how many requests your application can actually handle. You could maybe do it for each type of request, but then that's going to be a nightmare. You have a whole other observability problem if you need to know scaling based on certain numbers of types of calls. So that's one thing, probably not the best option. The other ones are by performance. So you could monitor with a tool like Azure Monitor times to respond. So if you have an API, how long it takes on average to respond to a call, or how long your database calls take, those sorts of things. But this is also a problem, because if you depend on a third-party system, or you depend on a Microsoft service that maybe has an outage, scaling may not fix the problem if there's a problem with one of those external services. Yes, you should try and mitigate those, but again, this is tricky to determine. Equally, coming back to that example I gave a minute ago, a post request with lots of data is probably going to take a lot longer than a simple GET request to hit the cache. They are not all equal. You cannot necessarily choose based on that you want to scale. Resource usage, interesting one. Ideally, in an ideal world, you would optimize your application so you're using as few resources as possible to run. But again, sometimes someone releases some code to production, you get a memory spike, or it's not been quite optimized as it should, and your thresholds get hit, and then you have to scale up. Does that mean your application's at danger of crashing? If you don't, well, probably not. Maybe your thresholds just set wrong. I've seen people setting their resource usage thresholds for, say, scaling far too low, 60%. And then you have a highly memory constrained application. Well, if you're trying to put as much data into memory as possible, you will be using probably 60% of the available memory in your system. If you've got a CPU constrained application, maybe you're doing some machine learning, well, actually, you're probably going to use most of the CPU. So you've really got to decide what metric you're trying to measure there, and how you're going to quantify that your resource is being maxed out. The final one is maybe on a schedule, but I'd hope you're not really doing this in production. It does make sense for some workloads. So if you have tasks that need to happen overnight, perhaps, you might scale those up in the night and scale them back down in the day, and equally scale up certain resources during the day when users are using your system, scale them down at night. But it's not so resilient, because for that one or two times where something does happen in the day and you need to add more resource or need less resource, it's kind of tricky. Manually, I really hope no one's doing this, please, please, please. But everyone's probably been in that position where marketing come knocking on the door. Hello, we've just sent an email out to 1 million people. That's going to be fine, right? No, probably not. But in those cases, you can scale manually. I think the real answer here is it's a mixture of all of these options. You've got to find which one fits your application best, and you've got to find which one fits your use case best. If you have predictability around your usage patterns, then yes, you can maybe go for more of a scheduled approach, more of a proactive approach, shall we say. Whereas if your traffic spikes are completely unpredictable, then you're going to need to be more reactive. So one of the first few options there are probably better. I don't know why there's a black screen there. Right, I'm going to give you a sample application. I've done a longer version of this talk where we've got a proper working example and a demo. I'm not going to go into that today, but this is my sample application. And it's been very specifically chosen for several reasons. Firstly, it's Umbraco. I love Umbraco. I mentioned that. But secondly, it's actually a kind of perfect example because we have a .NET 6 app. And that's just a regular .NET 6 application. There's nothing special about it. It's got a database connection. It has some files that are stored on disk so that I can run my website. So here I have a Azure VM. It's set up. It's got an SSD there where I'm storing my assets and my logs. And my SQL database lives on the same server in MS SQL. And I have a DevOps pipeline that's building and deploying those things, but that's not really a big deal. This is a standard setup for a small website, shall we say. Now I've made it big time. So how do I scale this? I need it on multiple machines or in maybe multiple locations. What am I going to do here? Well, we have got some options. In Azure, we could use web apps. It's platform as a service. I don't have to manage servers or VMs anymore. I don't have to worry about patching. That's all good. I can manually or automatically scale my application as and when I need. That's great. Instead of having my SSD with all of my files on it, which is, well, one, not very fault tolerant, but two, can't be geo-distributed easily, I can put that on a managed storage service like blob storage. For my database, that doesn't need to live on a VM either. That could live on a managed database service like Azure SQL. And for all of my logging that was previously stored on that SSD, I can also put those on something like Application Insight. That's a really easy way to start mitigating some of those infrastructure dependencies I had, where I'm kind of relying on stuff being available on my server, and make them a little bit more scalable and reusable. I will quickly show you, just as an example, what Azure Web Apps actually looks like, in case you haven't seen this, and here's sort of how we would go about creating an application. So I've created a few resource groups here. In this case, called VACD app. I'm going to go to Azure and I'm going to search for an app service. And you can then provision. The search in Azure has got really bad. App service plan, which is, if you want to think of it as a server, you can think of it as that. It's a block of compute. A web app is a way of deploying, it's a type of application that will run on app service, on that compute. So in this case, I have my web app. When I click that, I can go through the steps. I can decide which resource group I want to create it in. I can give it a name. I can choose a source for the code and the files that I'm going to run. It could be my own custom code. I can push to it with Kudu. It could be a Docker container. They've got static web apps as well. A bunch of runtime options, and we're good to go. Now, I've already set this up because it does take a couple of minutes to run. So I have a very simple web app with nothing on it. This is just the first welcome to your web app screen. So yeah, that's that. Now, if I wanted to scale this, I've got built-in options for scaling. So I don't have to worry too much about handling that myself. I can either scale up, which means put my app service plan on a more powerful plan. I'm on the S1 tier currently, but they've got SP, they've got development tiers, testing tiers, a free tier even, and all the way, it can go even further. So yeah, I can scale up my plan, or I can scale it out. Scaling out is adding more replicas of my application. This could be done manually, as I say here, just drag, or based on a rule that I define. So here, I can start to set up my conditions. So add a scale condition. There we go. So in this case, no, not what I wanted to do at all. There we go. So you choose the mode that with which you'd like to scale. In my case, I'd like to scale up by one item, but by one instance, based on a metric that I choose. Now, these metrics are powered by Azure Monitor. So all of that data is being fed into the Azure platform constantly. You remember back to that slide where I was talking about all the different options you could choose to scale by? Well, here they are. You can choose the amount of data coming in, your HTTP queue length, which is quite a good metric. because that's how many requests you've got waiting to be serviced by your app service, meaning people trying to get through that can't right this second. Memory percentage stuff. Memory percentage, CPU, they're the ones you want to be really careful with, because as you can see here, my value was 69% constantly. I think that's an error with the graph, but that's not really a problem. If I'd set my scaling metric to 60% and I scaled out to another app, well, it would scale out again straight away to another app and another app and another app infinitely, because my application regularly uses 69% of memory. Same goes for the CPU. So yeah, just choose those metrics carefully. You can choose your conditions, the rules within which it should scale up or down, and then you're good to go. And it's genuinely as easy as it seems. So yeah, that's scaling with an app service in web app. Now, we have another option where perhaps if you wanted to unlock another tier of hosting options here, Kubernetes for one, or perhaps you've just decided that you've containerized your application, you'd like to ship all of your application within a container, you can run containers on web apps themselves. So you don't have to deploy your code straight there. You could deploy your whole container, and that could contain anything you want. So if you want your database to live inside the container, it can live inside the container, or other infrastructure dependencies, perhaps a queue or something like that. So the exact same setup as we had before, exact same code, but it's now containerized. That's possible to run in Azure too. I've got another quick example of that, where I've got a container-based app spun up. When I created, instead of choosing code, I chose Docker container, and I can choose a source where that comes from. This is a containerized app. It doesn't really say as such, but you'll have to trust me that it is. Thankfully here, scaling options are exactly the same as they have been in the web app, because they are either based on, manually scaling up or scaling out. It's probably the easiest way you can deploy and scale a Docker container in Azure. If you're going to run it for, say, a website or something, this is probably the easiest way to do it. Same metrics, everything you had before, super powerful and super user-friendly. So where do you begin? If you want to containerize your app, you have to think through a few different options. Docker's generally the preferred containerization tool nowadays, and Docker's pretty straightforward to get started with. The first thing to do would be to install Docker and create a Docker file. Now, for me, as someone who doesn't know anything about Docker really at this point, that's scary. But there is a Visual Studio extension. When you've installed the Docker desktop application, it adds an option in the dialog, so you can click on your project and say, add Docker support. And based on you having .NET, or depending on what you've got in your project, it will create the relevant Docker file. So I didn't have to do any work. I was able to get a demo of this working where I didn't have to write any code or any configuration. I don't have to worry about YAML, those sorts of things. So then we have to package up our application. This puts our code inside the container and allows it to run. We then need to store our container somewhere so that we can deploy it. That's called a registry, and then we deploy that from our registry, our Docker image, into the real world, onto an orchestrator for it to run. You can do this with the command line. So Docker build will package up our app. -t here is a tag, and that gives your package a name. I'm here just calling it app latest for something generic. The dot there is symbolizing that it's the current folder that I'm in. You can then run your application. This is worth doing before you try and deploy it, just to make sure it does actually run as you'd expect. And then you can push that to a registry. So Docker push, give it a name of a registry. There's plenty of registries. You may have heard of Docker Hub. Azure has a fantastic one called Azure Container Registry, which on the basic tier is free to use, up to 10 gig of storage, I think, and it's pretty generous, and it probably meets most of your needs if you're only deploying Docker in a small way in Azure. And then finally, you want to deploy your image. So just like I showed you a minute ago, we can deploy a web app on Azure, and that web app allows us to select a Docker container. And I've just chosen a region there. I'm not that worried about any of this. When you come through to the next options, you can choose a source for that Docker image. yes, I can take a off-the-shelf standard example, or I can choose from one of their registries. So container registry already integrated. It's worked out that I've created a container registry called VACD containers, and because I've not deployed an image or a tag there yet, it won't be there, but it would be my app, would be my image, and latest would be my tag, and away it goes. Alrighty, so the second of the three options we're going to look at for deploying and scaling our application was Azure Kubernetes Service. As I said at the start, Kubernetes is a managed, is a container orchestrator tool. It allows you to deploy instances of your Docker container, or any container for that matter, across many, many physical servers, which are called nodes. You have two concepts that we need to get our heads around here, where in web apps, we were talking about scaling an app. That's a single instance of something. Here we've got two things we can scale. We can scale clusters, and we can scale pods. Now, a cluster is your physical machine, the number of VMs with Kubernetes installed connected to your network. So that could be 5, 10, any number, thousands of physical virtual machines running in Azure with Kubernetes installed. Then you have pods. Now, pods are instances of your running container, and that number of pods gets distributed across your cluster. So, in theory, if you have 5 nodes and you have the pod, one pod, but it's scaled out to 5 nodes, you'll have an instance of your application running on every single node in your cluster. If you wanted to go further, you could scale that even more. You can have multiple different pods, so you could have different versions or different infrastructure components running in pods on Kubernetes and scale those accordingly. You could decide, well, we've got a back-end service that is just churning away constantly. It doesn't need to be that performant. We will say that pod can only be scaled out to 2 servers at a time, whereas we've got a front-end service, and that needs to be scaled out across the entire cluster and kind of take up as much resource as we can possibly give it at this point, and you can configure exactly that too. Because Kubernetes service is more designed around like servicing microservice type architectures, is not really out of the box geared up for servicing web applications, building a full publicly accessible application. It doesn't have any public DNS service as part of it, whereas the app service is already publicly available. So you have to put something like an application gateway in front of that application, in front of Kubernetes, for it to talk to the outer world. It does have an internal DNS service that will allow you to resolve requests to a given instance of your container running on a certain port, but yeah, that is Kubernetes. Now, again, very quickly, I've got an example set up of this running in Azure. So I was able to create a Kubernetes service, and I don't know a thing about Kubernetes. I don't want to have to write configuration. If I was hosting this myself, I'd have to manage all of that. I'd have to manage patching. In this case, Azure sort of handles that for me, which is quite nice. I can go up here and I can create either using YAML, or I can use one of their quick start templates. If you're going to use a quick start template, I can choose from an image that already exists, such as one that I've put in my Azure Container Registry instance that we spoke about a minute ago. Or I can just choose an off-the-shelf example. Let's choose an off-the-shelf example here. So it's given me a nice simple example. It's going to give me a voting application, cats versus dogs. Which one do we prefer? As my example. It gives me all of the YAML configuration that's needed to run that application in Kubernetes. I don't have to worry about it. I can modify this if I wanted to and change the config if I know enough about Kubernetes. If I don't, you're pretty safe to just hit deploy and it will run. So in this case, I've hit deploy. Now you've seen here, it's already very quickly scaled that out to 5 different things it's deployed to Kubernetes. It's deployed the namespace, which is effectively the reference for my pods. It's deployed 2 backend services and 2 front-end services, which is really cool. And whilst we've been talking, it's already spun that up. I've clicked twice, and I've got a Kubernetes instance running an application on Azure. Give it a second, it will spin up, and we can vote for cats because they are evidently the best. Maybe it's going to take a little while. yeah, it was that straightforward. I will close that. There we go. Cat. Woohoo! Demo gods aren't on my side. Okay, you'll have to trust me. I have one that I made earlier, which is lucky. So when it comes to scaling in Kubernetes, we can do that manually. We can scale everything up ourselves, or we can we can add more nodes. As I said, I've only got one node actually running in my instance because I didn't want to have to set up loads and loads of VMs, but it was pretty straightforward to do. So I can add more nodes to my pool. I can change my running namespaces. I should have two because I have the ones I deployed earlier. My Azure Vote one, I guess, from 2 hours ago. That makes sense. And I can, start to change the configuration of all of these. Equally, my services, I can start to change those. That's my load balancer. If I wanted to scale these up, I can do so. It's pretty powerful. Where is the thing I'm looking for? I don't know. I think it's actually back on the overview. Never mind. In summary, though, with Kubernetes on Azure, you can set it to auto-scale if you'd like to write the Kubernetes configuration to do so. If you want to use the UI and the out-of-the-box tools, you're going to have to do it manually or maybe through one of the Azure APIs. It's not out of the box going to automatically monitor your application, scale it. It's up to you to configure how you want your Kubernetes cluster to run. So there's a manual element to this one. Now, option 3 here is sort of a hybrid of all of the options we've looked at already. Azure Container Apps. It's taking a managed, almost serverless Kubernetes setup and abstracting away all of the configuration. So you can do everything you can do in like a web app, as in, here's my application, just run it, and it's still Kubernetes under the hood. It has an option to scale with something called CADA, which is Kubernetes Event-Driven Architecture. That is effectively a way of writing reactive configuration to say, when this happens, when this event's broadcast in my Kubernetes cluster, you need to do these things. It's also mostly designed around DAPA, Distributed Application Runtime, which is the Microsoft runtime for building sort of microservice architectures. It's more designed around microservices. It's not really for building, say, a website, but you could if you really wanted to. The best thing, because it's a sort of serverless platform, is that you can pay for a very, very small amount of compute, and only the compute that you use. With Kubernetes service, that's provisioned 5 VMs, and you're paying for those VMs all the time, regardless of if they're being fully utilized or not. With this, you can do it in half-gig increments of memory and also in compute. You can then also change versions of your application running. They've got this concept of revisions, so you can have multiple versions of a container running and say, we're going to have 80% of our traffic use this one version and wait between the two. Very quickly, I'll show you how that works as well. So I have created a Azure Container Apps instance, a Container App environment, and under that I can add an app. I created one that we'll have a look at in a second. When I create my app, I can choose a source. So in this case, I give it a name. Let's just call it Virtual Azure Day. Give it a location, choose some settings, the amount of CPU power I need, the amount of memory I need for my application. I can then also choose the source of my application. In this case, it's seemingly only letting me deploy a Hello World app, so let's not worry too much. I have my Hello World app deployed, and it's here. So because the container apps is already kind of publicly accessible, it's given me a nice URL. It's not a friendly URL, but it has built-in DNS. So if I wanted to attach a custom domain, I could do so without having to configure and provision a application gateway, a bit like I'd have to with Kubernetes service. So that spun up a very, very simple welcome to container apps application. So how would I go about scaling this given app that I've got? Well, they have as I said, really nice way of managing revisions. I can go to my tab, I can have multiple versions of this. So I can deploy new container images and say, well, this is a new version of my app, again, from any source that I wish. And I can scale those and set the scaling for those accordingly. So you can say between these numbers, and it will work there, and set scaling rules. These scaling rules can be based on HTTP requests, so number of concurrent requests to my service, which if you're building a microservice application, it's a bit more realistic being able to say, yes, this service has one HTTP endpoint and we know it can handle this much traffic. If you're building an application that has a lot, that's maybe less realistic. Based on an Azure queue, this is a really interesting option that isn't available, as far as I know, in the other options for web apps or for Kubernetes unless you were to configure something yourself. So you can give it a queue that's in Azure and say, well, when my tasks are backed up like this, give it more power so it can churn through that queue quicker. This is, again, far more leaning itself towards a microservice architecture, but is a perfectly valid scaling metric, actually. And then you've got your custom rules, and these are all based on these CADA type rules. So you can have a a custom rule here, and you can set it all up. This isn't just for revisions. This applies generally as well. So I can set my own scaling rules for my application when it's running in the real world. This is a pretty nice hybrid, I would say, between Kubernetes and the configuration where if you want to do anything special, you have to know about Kubernetes. But then what they're abstracting away from you there is the virtual machines and having to manage those, your cluster. Here, it's taken the app service approach where it's a proper platform as a service. I can throw my container at it. It's serverless, so I'm not paying for compute when I don't need it. Truly scalable, kind of infinitely. I think my maximum here is just because of the plan that I'm on. But yeah, it should be scalable. So yeah, that's container app. Now, very quickly, a summary of the three options we've looked at. The app service, for me, is comfortable. It's plug and play. It's very easy to start. A few clicks. I don't need to know too much. I have my code written, and I can deploy that code, and it should just work. I don't need to know about containers unless I want to. I do have the option there as well. So it can be really simple, or it can be a bit more powerful. The auto scaling is really painless. You can manually scale if you want, up or out, but you can also automatically scale with the Azure Monitor-based metrics. Just make sure you know what those metrics mean in the real world of running your application. It includes public DNS, so if you're going to host something that needs to be publicly accessible, then that's great. And then for your other infrastructure components, you can just use the other Azure managed services. So managed database service like Azure SQL, or you can use, say, blob storage for your storage. Kubernetes service requires some Kubernetes knowledge. You have to really understand what you're doing there. Whilst they're abstracting away the management, you still need to run your Kubernetes cluster, if you will, and use it properly. The scaling is manual-ish. If you know what you're doing with Kubernetes, you can automate that within your cluster, but the actual scaling of your cluster is going to be pretty much manual. If you want to do anything publicly facing, you have to have a gateway there, which is another cost, but it's also more to manage. And then finally, if you're going to run other infrastructure components alongside your application, those may have to run within your Kubernetes cluster itself, or you could run those elsewhere. So you could run SQL as a pod, if you will, running in Kubernetes. But you have your own challenges there. And finally, for container apps, this is a sort of hybrid of the two approaches. You've got a platform as a service approach to hosting containers and your infrastructure, to hosting your any components, really. You could have your database living in there if you wanted and running on a serverless basis, or you could have your just different microservices, split your application out accordingly. The scaling is slightly different. It's fully customized if you want to go and understand CADA, and you can also do it based on HTTP or a queue, which could be quite helpful if that's something you're looking for. It includes public DNS out of the box, including domains and things. So if you're going to build something that needs to be public-facing in any way, then great, you can do exactly that. And finally, it's a PaaS or an IaaS product. To summarize on the pricing, this is where it gets interesting, because app service is actually the most expensive. Whilst it's probably the easiest to use, you're paying for that privilege. You are paying quite a lot of money for constantly provisioned resources, whether you're using them or not. So the S1 tier, I think, has 1.75 gig of memory. And if you're only going to use half a gig of that memory, well, you're paying for the rest regardless. Thankfully, with something like the container app service, you're only paying for exactly what you use. It's purely serverless as a platform. So that's maybe a little bit more cost efficient if you want to invest in the upfront cost of setting your application up in a containerized way and making all that stuff work. And Kubernetes service, I've said here it's the sort of medium priced option, but I'm not sure if that's always the case. It is the case if you're going to run it yourself and maximize the infrastructure. You're still provisioning a number of virtual machines. If you're going to maximize each one and use as much resource as you possibly can from each, then absolutely, it's going to be the most cost effective. If you're only going to use a bit of it and you've still got a lot of idle resource usage there, this probably isn't the most effective. And there's a huge learning cost involved upfront as well. And with that, I'm going to bring my time to a close. I'd like to thank the organisers of Virtual Azure Community Day for having me back again. I think this is my second or third event. I can't quite remember. And also, thank you all for watching and joining in today. There we go.
Yeah. That was perfect timing, so thank you so much.
It was perfect timing. Thank you.
Yeah. I think you are so excited about this topic. We could have left you.
I probably
for
could
like
have, yeah.
hours, right?
I probably could have. I've got a longer version of that talk if you'd like me to just keep going. I'm joking.
Well, I have to admit, are we gonna just say it? I'm looking at Punima, but we're not even on camera right now.
Okay, how do I come in on the camera?
Come
Okay,
sit there.
let me come along then.
So this is not chaotic at all, or like
Okay,
a weird
yeah,
social-
I'm here now.
Basically, it's like kind of like women taking over the studio. Do you want to join us too?
Yeah,
Absolutely.
Let's
just do it.
It's not
Yes.
even mic'd. It's not even mic'd up.
Because let's be honest. I think, yes.
This is like true community feeling, right?
It is.
It's everyone
Yes.
in the same room.
Exactly what we need.
Isn't this what community is all about?
100%.
Providing a stage for everyone to share their passion for technology. Still having Hank behind the camera.
Yes.
That's his favorite spot. But yeah, I think this was an awesome day.
I agree.
I think you're still so excited. You're still all here.
Definitely, yeah. I thought I had to leave, but apparently we didn't. So, yeah. But no,
It's
It
not
was very
confusing
nice.
at all.
Not confusing at all.
Please
yeah.
leave. No, stay.
Yeah. Well, I did definitely also like your talk, Callum. But
thank you.
I do still have a question because the customers usually want and need auto scaling and stuff like that, but they don't like the automatic billing part. So, do you have any suggestions for that?
It's this. So the question, because Mike's not got
Yeah.
Mark's not got a microphone on, was customers like the auto scaling, but actually they don't want to pay for it. So what gives here? It's like the old adage on a project: they want complete flexible scope but fixed budget. It's never really that possible. Yeah. So you can of course put sensible limits in place, and I think another important thing to note is there's different tiers within all of these products where you can choose lower powered virtual machines or lower powered or higher powered app service plans. There's no way of automatically switching between those, but you could choose to distribute your workload nicely across the relevant platforms to get the best bang for your buck, if you will, when it comes to scaling. I think container apps is really exciting because the billing units are so small that actually the scaling is kind of macro, whereas with app service you're scaling up really, really large amounts of compute. So there's other options coming out for that exact case.
Nice. Yeah.
And yeah, doing stuff at night, making better use of your idle infrastructure is another great way of squeezing those extra few miles out of what you're already paying for. I guess.
Yeah. Clever. Okay, thanks.
Thank you.
Cool.
That
Thank
makes
you.
sense. It gets me all excited about all the new possibilities that are just a corner. So stay tuned. No, but without kidding, I think it's time for us to wrap up, even though we would still love to party, probably taking it into the wee little hours of the night. But I think we gave you a great impression of how Virtual Azure Community Day is all about providing this awesome stage for the community to share our passion for technology. And hopefully we'll be able to invite you on this stage next time. And with that, I think it's a wrap. Right, Hank?
Yes.
See you later.